Good morning, sir. Dr. Purushottam, good morning.
Hello.
Good morning.
Good morning. Am I audible, sir?
Yeah, you are audible. I am audible.
Yeah, one sec.
You can please project your screen. Once again, you can have an initial checkup.
Okay, is my voice clear, sir?
Yeah, very clear.
Yes. Do you have a screen sharing option?
Yes.
I think it has to be enabled.
It is enabled just now. Yeah, we can see your screen.
Yes.
Yeah. Yeah, another 3 minutes we shall start the presentation.
Yeah. Sir, in case if I get disconnected, in the talk, just give me a call. Okay. So let me check it.
Okay. It will not be.
Yeah.
Let us hope. Yeah.
Right.
Yeah. Okay. Thank you.
Yes.
We shall be back at 3 minutes.
Yes. Thank you.
A very good morning, all of you, the delegates joined online and offline. So we are in the last day, day 3 of National Workshop on Cryptology. The last 2 days deliberations went on very well. All the talks and paper presentations were over in time. So today we are starting the first session by Dr. Purushottam BR. After this session, we have Dr. P.K. Saxena, who is the security advisor to Prime Minister's Office, former director of DRDO. He will be delivering the talk. Later, After tea break, we will be having Dr. Indivar Gupta, who is presently with Scientific Analysis Group of DRDO. Post-lunch session, we will be having a famous mathematician with us, Dr. Balasubramaniam R, who was the former director of Institute of Mathematical Sciences, Hyderabad. He'll be talking about a popular topic, elliptical cryptography. The last session will be by an young researcher, Dr. Gururaj HL, who will be talking about roles of AI in cyber security. So these are the details of the whole day presentations. Anyway, at 4 o'clock, we will be signing off from National Workshop on Cryptology through a valedictory program. Principal Dr. Nagendra Prasad will be presiding over the function. So with this short details of NWC 2021 day 3, we will be moving to the very first technical session on secure access, delegation of access control mechanism to untrusted cloud storage server by Dr. Purushottam BR. Now I invite Mrs. Sumati, Assistant Professor, Department of ENC, to introduce the speaker. Over to Sumati.
So it is my immense pleasure to introduce you all Dr. Purushottama B.R. sir. Dr. Purushottama B.R. sir has obtained his PhD in Cloud Computer Science and Engineering from NIT Warangal, India, and he did his MTech in Computer Science and Engineering from National Institute of Technology, Karnataka, Surathkal. He is currently working as Associate Professor in Department of Computer Science and Engineering at National Institute of Technology, Goa. His areas of interest are cryptology, key management, cloud security, data security, provable security, network security, and algorithms. So this is about the brief profile introduction of Dr. Purushottama B.R. sir. Thank you, sir, being with us today. Over to you, sir, for your technical session.
Thank you, madam. Am I audible?
Yes.
Yes, sir, you're audible, sir.
Yeah, good morning, everybody. And for the next 1 hour, I will be focusing on the issue of secure access delegation of access control mechanism to untrusted cloud storage server. And this is the outline of my presentation. I will be introducing some of the cryptographic primitives like symmetric key cryptography, asymmetric key cryptography, and proxy encryption. The whole talk of my next 40 to 45 minutes will revolve around introducing this proxy encryption scheme. And I am hopeful that many researchers, many postgraduate students will be attending this workshop. And the challenges that I will be posing with this proxy encryption can be taken forward once you understand the applications of the proxy encryption scheme. I pose this access control problem in the scenario of data outsourcing to an untrusted cloud server. And we will see how to approach to solve this access control problem using the existing cryptography primitives. There are many primitives, correct? No, like say attribute-based encryption and key aggregate crypto systems and everything. But I am going to just focus myself on this primitive proxy encryption, which has a wide variety of applications. And let us see that whether we can apply this proxy encryption as a cryptographic primitive to solve this access control problem. And if I trivially directly apply this proxy encryption scheme for this access control problem, what are all the problems we are facing, and what are all the challenges ahead with respect to this proxy encryption encryption scheme. And once I see about all this, apply this existing cryptographic primitives to solve this access control problem, we'll try to see what are all the problems with these approaches. And some of the research challenges, correct? No, let me pose it at the end with respect to the application of all these cryptographic properties to solve the access control problem. So as you are aware, what about the symmetric cryptography? The problem that cryptography fundamental objective it solves is the establish a secure channel between Alice and Bob, where then exchange the message. And there are many ways. Encryption methods are the one which you use to secure the message which travels from sender to the receiver, like Alice and Bob. And there are two kinds of encryption methods, as you know. One is symmetric cryptography, and as history tells that until 1970s. Basically, Alice and Bob, they want to exchange the message on an insecure communication channel using the symmetric cryptography. They have to rely on the secret information which has to be shared between these communication parties. And once the shared key is available with Alice and Bob, that encryption can be done with the same key, and the decryption can also be done with the same key. So it's called asymmetric key cryptography. So prominent examples of symmetric key cryptography, as you know, is DES and AES. And I'm not getting deep into all this, intricacies of YEDES and YEAS. But take-home point is that symmetric key cryptography, like DES and AES, requires a pre-shared key between sender and receiver. And once the pre-shared key is available, they should be able to exchange the messages or any secure communication channel. And there is another type of encryption methods to preserve the confidentiality of the messages from sender to the receiver. This is called asymmetric key cryptography. And the public key encryption methods are basically asymmetric, right? So instead of a single key, what each person will be having, each person will be having two keys. One is the public key and the secret key. And public key, as usual, it is made public, and the secret key is kept secret with the user. And if suppose say Alice want to encrypt a message to the Bob, Alice has to encrypt the message using the public key of the Bob and using an encryption algorithm like E of PKM, and which will give you the ciphertext. And at the other end, the Bob is going to decrypt this message by using the corresponding secret key corresponding to this public key, which has been used for encryption. And this is what the asymmetric key cryptography is. So, see, as you see, there are some of the famous public key crypto systems or asymmetric key crypto systems are RSA crypto system. As you are aware that security of the RSA crypto system is going to rely on the hardness of this integer factorization problem. And there is an LGML crypto system whose hardness is relying on the defilement problem. So if you see, say, Alice and Bob sitting at the different corner of the world, if they want to exchange a large amount of data, and how they can extend a large amount of data. Because say, if you see all these crypto systems and computations which happens inside the algorithms of the crypto systems, they are very complex, very costlier operations compared to the symmetric crypto systems. So symmetric crypto systems in a hardware and software, they have faster implementations compared to this public key crypto system. So you cannot afford to encrypt the large amount of data with the public key crypto system. So, but you need to choose the symmetric key encryption system because they are faster to encrypt the large amount of data. But the thing is, using the public key crypto system and the symmetric key crypto systems, in a combining way, they can, Alice and Bob, who are sitting at the different corner of the world, they will be able to exchange the message. So what they can do is they can choose a key and they can use the public key crypto system to exchange that key in case of DS 56-bit. And once the key is exchanged between Alice and Bob, they should be able to, exchange the large amount of data by encrypting with a symmetric key. So this is what the outset. These are the fundamental primitives which are used to protect the data from the eavesdropper or an adversary. So let me take into this. As we as a cryptographers, we know what is symmetric cryptography, what is asymmetric cryptography, and you know that what is the encryption algorithm and dedication on both input and output also. So let me all together introduce bring forward some other primitive called proxy encryption. I will set the scenario and the motivation, and we will see that how proxy encryption can enable to address the problem which is exhibited by this scenario. Suppose, say, I have these two entities like Alice. Suppose he is the manager of some organization, and Bob is a colleague of Alice. So this is the setup. Imagine that Alice is leading an organization. Bob is a colleague of Alice. Suppose Alice wants to go on a vacation for a month. So being a manager, you want to take off for a vacation for a month. And during this vacation, you don't want to get involved himself in answering his mails, because he really want to enjoy his vacation. But the point is, you don't want the work to stop. So Alice, during the vacation, you don't want his work to be stopped, and you want to temporarily forward the encrypted emails to Bob. In the sense, say, assume that Alice's email box is getting the mails, right? So which are encrypted with the public key of Alice, and when the mails are encrypted with the public key of Alice, and Alice is the only person who is having the corresponding secret key to be able to read the mails, right? Because they have been encrypted with Alice's public key. So during the vacation, you want to temporarily forward the mails which are coming from his friends or his business partners, so that he will be sending that one to the Bob. and you want these mails to be replied from the Bob. This is what the fundamental problem is. So how actually Alice will enable the Bob to mail Bob to respond to the emails which he will be receiving. So at the outset, how actually the mails are coming to him? Mails are coming to him by encrypted with the public key of Alice, right? Which could be decrypted by only the secret key, and secret key is only with the Alice. So as I was telling that, we assume that Alice's mails which are coming are encrypted with the Alice's public key, which is known to everybody. So the mails which the Alice is having is encrypted with the Alice's public key, which I want to stress now. And when it is encrypted with the Alice's public key, this can be decrypted with only the secret key of Alice. But the point is, he is going to go on the vacation, but he wants his mails to be forwarded to the Bob, and Bob should be able to respond to these emails of Alice. Now the task is, how can Alice delegate the task to the Bob? Let's keep thinking about it. Correct? No, how he will enable the Bob to respond to the mails, correct? No, which are being encrypted to Alice. You just forward to them and try to see that how we can delegate the task. One of the possible approach, which is obviously a trivial approach, is it's like giving your password of your email to somebody, your friend, and asking to just respond to the mails which are coming. So the trivial approach is Alice can give her secret key to the Bob. Definitely does this solve the problem of responding to the mails of the Alice? Definitely it solves the problem, because Bob is indeed having the secret key of the Alice. It's like handing over the secret key to the Bob means Bob Alice is no more Alice, Bob is an Alice. Correct? No, that's the point. What is the problem with the trivial approach? By giving the secret key of Alice, by giving the secret key to the Bob, basically he is giving the complete control to the Bob. So you may be knowing that what are all things it can be done by the secret key, by anybody's secret key. All other things can be done by Bob only. So you need to keep a trust factor in Bob. The whole goal of the cryptography is to remove the trust. Correct? No, I don't trust somebody, but I want cryptography to solve these problems. The challenge is how Alice ensure that Bob reads the data, correct? No, which is encrypted to her. Now, the problem here is when he gives the complete control to the Bob using the secret key, he can sign some of the documents, but obviously Alice is giving the secret key to the Bob, thinking that he is going to respond to the mail soon. But because he is having the secret, and he's asking the Bob not to do anything other than reading the mails and responding to the mails. But in that case, Bob has to listen to Alice. Bob may choose to sign some of the documents on behalf of the Alice, but Alice has not delegated that kind of task to the Bob. But this is the problem with giving the secret key completely to the Bob. The challenge is how Alice, because you don't want to give the secret key, because he knows that that level of trust you may not be keeping in Bob. So how Alice ensure that Bob reads the data which is encrypted to her? That's the point. Right now, I don't want to give the secret key to the Bob. Now, what I will do is, so I am not trusting Bob, so I am employing somebody, and I'm employing somebody who acts like a proxy to me. Okay, so he's going to do my job of responding to the emails, read the emails which are corresponding to the Alice. So what I will do, rather than keeping my trust on my colleague, which is Bob, I'm going to employ somebody called a proxy. Correct? No, so I will ask the proxy to carry out the task of reading the mails. So in this model, correct? No, there are three entities now. Correct? No, one is Alice, and who is a delegator, and the proxy. Correct? No, who is going to enable the what is the goal here? Alice want to enable the Bob to read the messages which are coming to her. So in this model, he is asking the proxy to enable the reading of the messages from Bob to Bob. Correct? No, of the messages which are destined to the Alice. So there is another entity called a Bob. Here, Alice, who is the delegator, want to delegate the responsibility of responding to the mail to the Bob, who is the delegate. And this enabling, in the first approach, trivial approach, Alice, if he gives the secret key to the Bob, problem is solved, but you don't want to give the secret key to this person. So Alice, what he will do is he will employ the proxy. Proxy's responsibility is to enable the Alice messages to be read by the Bob. All this proxy is going to enable the enable the Bob to read the messages of the Alice. Indeed, correct now, who is the person who is going to respond to the Bob in any case? You want Bob to respond to the mails of the Alice, and the enabler is asking proxy to do it. Now, the responsibility of the proxy, the third person who is in between Alice and Bob, is to enable the Bob to read the messages of the Alice, which are encrypted with the public key of the Alice. Question is, by bringing the third party, does it solve the problem? That is not the problem of not giving the secret key to the Bob. Can Alice give secret key to the proxy? So what proxy can do if you give the secret key to the proxy? It takes the mail, correct now, which are encrypted with Alice's public key, decrypt it and encrypt it again with the Bob's secret key, Bob's public key, and send it to him. Because the messages are being now decrypted and encrypted with some other key, Bob will be able to read it. But can Alice afford to give the secret key to the proxy? Yes, he can definitely give the secret key to the proxy. But the thing is, it requires an unrealistic level of trust in the proxy, right? In the case, if you are keeping a trust, if you have to keep a high level of trust in the proxy to do it. So the whole goal is, I don't want to give the secret key to the proxy. I don't want to give the secret key directly to the Bob. In any case, correct now, I want Bob to respond to the mails which are encrypted with Alice's public. How do you do it? What is the next one? So we have two approaches. One is to give secret key to the Bob. We see the problem. Employ somebody other than the Bob and give secret key to the proxy. This is also supposed to be the problem. So there is a possibility. Alice can designate a proxy to re-encrypt. This word is like re-encrypt or incoming mails which are encrypted with Alice's public key into a format that the Bob can decrypt using his own secret key. That's the goal. In the process of how it does this, it is exactly proxy re-encryption. It's somebody who is there in the middle. We will enable the proxy to re-encrypt the ciphertext of Alice in such a way that Bob can decrypt using his own secret key. How can we basically enable? So this is what the proxy re-encryption is, right? So proxy re-encryption allows an entity proxy to transform a ciphertext computed under Alice's public key, so that the transformed ciphertext can be opened by Bob's secret key. And when proxy is transforming the messages of Alice to Bob, correct? No, proxy should not learn any information about the underlying message corresponding to the ciphertext which is encrypted with what? Alice's public key. So that's the outset, right? The responsibility, it's called proxy re-encryption. Message is already encrypted and it is re-encrypted. What is the result of the re-encryption? A message encrypted with somebody's public key is transformed into a message, correct? No, which can be decrypted by somebody else's secret key other than the original sender's secret key. So to put this proxy encryption at the right place, let's assume that Alice has a key pair PK and SKA, and Bob's key pair is PKB and SKB. We know that there are accompanying algorithms like encryption. So CA is a ciphertext, correct, which is encryption of a message with the public key of Alice. And this message, you know that it can be decrypted. The CA is a ciphertext of a message M, which is encrypted with the public key PK, which is Alice's public key. You can imagine that CA is a mail, correct, no, which is sent by somebody else, correct, no, and this M is a mail which is encrypted with the public key of Alice, and C is the corresponding ciphertext of the mail. You know that somebody can read a mail if you use the corresponding decryption algorithm with this encrypted mail as an input and a secret key, corresponding secret key of this public key A. And also we know that if somebody, so we know Bob is also having PKB and SKB. If a message M is encrypted with the public key of B by using an encryption algorithm, let's call this as CB. And this message, we know that it can be decrypted by Bob using the secret key SKB. So this is what the this is the understanding of the public key crypto system is. But what we want basically, we want the CA to be transformed into CB. If it gets transformed into CB, it looks like it's encrypted with the public key of the Bob, so that this message could be decrypted. So we want to CA to be transformed to CB, transformed to what is that? CB. So for this, in proxy encryption, what I will do, Alice is the person basically is going on a vacation. And Alice should enable the proxy to transform the ciphertext CA to CB. Now, Alice, to enable the proxy to transform the CA to CB, he generates a proxy key, which is RKA to B. It's a proxy key which will be an input to a re-encryption algorithm. And Alice gives this RKA to B to proxy. And proxy takes the CA and uses the re-encryption algorithm, RNC, to get this CB. So observe this. So in this proxy re-encryption, there is a key generation algorithm, there is an encryption algorithm, there is a decryption algorithm, there is a rekey generation algorithm, and a re-encryption algorithm. This addition, as usual, public crypto systems will have three algorithms: key generation, encryption, and decryption. Because we are bringing a proxy in this case, apart from this key generation, encryption, and decryption algorithm, there will be key generation, rekey generation algorithm, which is the responsibility of OSAL algorithm is going to generate a rekey, correct? No, so like RKA to B, and there will be a re-encryption algorithm, correct? No, which takes the ciphertext corresponding to the delegator, which is Alice, and a re-encryption key RKA to B, and it is going to provide this CB. This is very important. How you generate the re-encryption key, how Alice generates the re-encryption key, how the re-encryption is happening. This re-encryption algorithm output is a transformation. If you observe, it takes CA, it takes RKA to B, and it gives you CB. Once CB is available, you know that if the Bob uses the decryption algorithm with CB as an input and a secret key, his secret key, you should be able to get the message corresponding to this ciphertext. So in this process, whoever the person who is going to execute this re-encryption algorithm, the design should be in such a way that they should not reveal any information about the underlying message corresponding to the ciphertext CA during this transformation. That should be the design goal of a proxy re-encryption scheme. There are several applications. One is like email forwarding, as I was telling, and performing cryptographic operations on a storage limited devices, and secure network file storage, and access control to outsourced data. So back home, you can see how you can apply to all these three applications, how proxy re-encryption can solve these problems. But my focus today is on the access control to outsourced data. So you have a data, you want to keep this data on a certain cloud server because we don't have enough storage to keep it. And you keep the data and you want to preserve the confidentiality of the data. Once you preserve the confidentiality, you don't want your data to be like, sitting at rest, but you want the access to the data to be given to a set of users, correct? Who will be interested to pay for the information. In that case, how you are going to give the access control to the outsourced data? Suppose I am the data owner, I am going to keep my data to the server. Some user comes that among all these data items, I want some set of data items to be accessed. How you are going to give a selective access to this outsourced data? That's actually the access control to outsourced data. Let us try to use this proxy encryption scheme. Correct? No, let's try to work by understanding the access control problem. Can we solve this access control problem directly with symmetric key cryptography, public key cryptography, or can we apply this proxy encryption scheme to solve this problem? And will there be any limitations on that? Right? If some problems open up, let us see. So you can use for key management also. There are some desirable properties for a fixed encryption scheme. And I'm stressing this, these are all not only the properties, depending on the applications, the proxy encryption scheme has to satisfy some other properties other than these properties also. But in general, these are all some of the desirable properties of a proxy encryption scheme. A proxy encryption scheme should be unidirectional, it should be non-interactive, it's a proxy should be invisible, there should be a original access to the data, it should be key optimal, and it should be collision safe, and it should be temporary, and it should be non-transitive. Let us see quickly walk through these desirable properties of proxy encryption scheme, and let's try to understand what does it mean by proxy encryption satisfies unidirectionality. So what unidirectional means? Delegation from Alice to Bob does not allow re-encryption from Bob to Alice. It means that if Alice is going to generate a key from A to B, that is RKA to B, using RKA to B, if he is not able to transform the CB to CA, it means that the scheme is unidirectional. Obviously, for several applications, this unidirectionality is very, very required because Alice is interested in transforming his message to the Bob, so he generates RKA to B. The same RKA to B should not enable the Bob ciphertext to be transformed to the CA because Bob is not interested in these mails to be read by Alice, right? That's what unidirectionality is. What is non-interactive? Suppose re-encryption keys, basically who is going to generate the re-encryption key? It is the Alice who generates the re-encryption key and give it to the proxy. So re-encryption key can be generated by Alice using the Bob's public key, right? So that is non-interactive. Suppose if Alice has to interact with the Bob, correct, no, to generate a secret key, generate a re-encryption key, basically, Bob may be reluctant to interact, but obviously the scheme should always without interacting with the Bob, without engaging in any communication, pre-communications, correct, no, to establish RKA to B, which is not in the interest of the Bob, the Alice should be able to generate the re-encryption key by using the Bob's public key only. So if you use this Bob's public key, or if no trusted third party is required for interaction to generate the re-encryption key, then the scheme is said to be non-interactive. Why, if I am a Bob, correct, why I will involve in, why I will spend time involving in interaction with the Alice, correct, to generate the encryption key. It is the responsibility of the Alice to generate the encryption key. And if you want to employ in this application, definitely you require that application of that one should be non-interactive. So proxy encryption, without walking through this, correct, now let me try to see what exactly proxy invisible. See, if you look at the Bob's perspective, there are some kind of ciphertext which will be coming to the Bob. So what kind of ciphertext can be coming into the Bob? See, on the one hand, there may be Bob's friends, correct? No, Bob's official mails, which could be encrypted directly using the encryption algorithm and the Bob's public key. And even all the messages which are encrypted with Bob's public key, there are also the messages which can be decrypted by the Bob's secret key. And are also there are some ciphertexts which are coming from which are coming through proxy, correct? Which are the re-encryptions of the ciphertext of the Alice. So there are two kinds of ciphertext which will be coming to the Bob. One which have been directly coming to the Bob by his friends or his own organizational circle, and some of the things, correct, are the delegated ciphertext, in the sense the ciphertext which are transformed, the Alice's ciphertext which are transformed and converted into Bob's ciphertext and coming to the Bob. But what basically, so this proxy invisibility is a desirable property, but I will tell you an application where proxy should be visible also. Suppose now Bob, whenever he collects the ciphertext, whenever he sees that what are all the ciphertexts are coming from, proxy invisibility tells that, correct, you should not be able to distinguish, correct, no, whether the ciphertext is coming from the proxy or ciphertexts are directly coming to him, correct? No, that's obviously so that Bob will be able to answer all the mails, correct? No, so some of the applications are there. Bob, you think that, correct, you want to finish within known, you want to finish the answering of the mails, correct, no, of his own, and later in the afternoon session you can you take the responsibility of answering the delegated ciphertext. In this case, you should be able to distinguish whether the ciphertexts are being coming to him are delegated ciphertexts which are transferred from the proxy, or they are the direct ciphertext, correct? No? So depending on the applications, these properties can be, correct, tweaked, correct? No? So in that case of distinguishing, you need the proxy to be visible, and proxy invisible basically tells that you should not have the distinction of direct ciphertext which are coming directly and messages directly encrypted with the public key, and the ciphertext which are coming, correct, from the proxy, correct, transformation of Alice's public key to the Alice's message to Bob's message. That's what the proxy invisibility is. Original access tells that Alice can decrypt re-encrypted ciphertext that were originally sent to her, whether the message as it was sent from the Alice, correct, during his vacation for really the message, correct. You want to see that he should have original access to the encrypted ciphertext. So let us see about the Bobs, because Bob may be the friend of so many people in the organizations, and they want to delegate the task of responding to their emails, correct? Because multiple people may be going on vacation. They want to entrust Bob to respond to all the emails because he is a very close friend of many people. But the point is, look at the Bob's perspective, correct? Now, because he's going to accept the responsibility of answering all their mails, and means he is going to accept the delegations. It should not increase any storage, correct? No, at Bob, right? So the size of Bob's secret storage should remain constant, regardless of how many delegations he accepts. Suppose it is n number of people are going to give him the responsibility. In that case, also his storage should remain constant. Suppose there are n people and n people want different keys to be stored by the Bob, and Bob will not be interested in spending his storage for this. Obviously, the scheme should be key optimal, irrespective of whatever application you are using for proxy re-encryption. So definitely this is a fundamental requirement, collusion safe. In the model, you have Alice, you have a Bob, and you have proxy. Alice is going to generate the re-encryption key as a function of his secret key and the public key of the Bob, because assuming that the scheme is non-interactive. Proxy is going to give the re-encryption key, but Bob and proxy, by colluding, they should not be able to, derive the Alice's secret key. If Bob and proxy colluding, can derive the Alice's secret key, because see how actually re-encryption key is built. It is a function of re-encryption is a function of Alice's public key and Alice's secret key and a Bob's public key, and he gives it to the proxy. What Bob is also having is a secret key. So using a secret key and the re-encryption key, if they're able to get Alice's secret key, then obviously it is as good as the Alice directly gives the secret key to the Bob, right? So they should not be collude. They should not be able to collude and get the secret key. So temporary in the sense that it should be, this is not nicely addressed in the literature, because Alice is going for the vacation for only 1 month. After 1 month, you only want to see that the message is not Bob, but it should be temporary. After a period of time, you should be able to revoke the capability which he has given to the Bob, right? So that's obviously a desirable property. So it should be non-transitive in the sense proxy alone can delegate delegation checks. In the sense, suppose a delegation to the proxy has been given by A to B, delegation is also given from B to C. But A is not interested in delegating to C. What is RK to B? A is interested in delegating to B, and B is interested in delegating to C, but A is not interested to delegate to C. And in that case, because A is interested to delegate to B, RK to B is given, and because Bob is interested in delegating to C, it is RKB to C is given. Requirement of the Alice is that Bob should respond to his mates. So you don't want C to be answering his mates. In that case, I require that by using these two keys, you should not be able to generate RK A to C. That is non-transitive. So non-transferable is in the sense, given this RK A to B, secret key of the Bob and public key of the C, they should not be able to generate RK to C. In this case, why it is? Because C might not be interested in getting the delegations, from anybody. So because if they are able to generate using PKC and SKB and proxy can, to generate, transform the ciphertext to the, Carol, despite is not interested. So let's quickly walk through an example of a scheme which is of 1998. The purpose of presenting this example is to understand what are all the properties actually this proxy encryption scheme is going to satisfy. It's basically an LGAML based scheme. You are aware of the LGAML crypto system. It chooses a safe prime key, and G is a group where capital small g is the generator of this group. And Alice's secret key is A, and the public key is G power A. As usual, it's like a LGAML crypto system. Box secret is B, and public key is G power B. Let there be a semi-trusted proxy, and let proxy key and delegation key be B by A mod Q. Please observe this, it is a B by A mod Q. So how the proxy key is generated? B is a secret key of Bob, A is a secret key of Alice, correct? No. So if Alice want to generate this B by A, how it generates. What is the encryption for a Alice? For an encryption for the Alice, randomly it chooses a number K, and it multiplies that message to be encrypted by G power K, and it takes the public key of Alice, which is G power A, and raises this random number to K, which is G power AK. So this is the ciphertext, how the encryption algorithm is going to work. Encryption algorithm chooses the random K, then it computes G power K, then it multiplies M into G power K, it takes the public key of G power A, and it multiplies with K. Now this is the ciphertext corresponding to the Alice. So proxy, how actually the proxy re-encryption algorithm does is, it keeps the first component as it is, M G power K mod P, as it is kept. Then what it will do is, it takes the second component, which is G power AK of the ciphertext CA, and it is going to raise this second component G power AK by B by A, because B by A is the delegation key. So when you do this, observe this, what will happen when you raise it by B by A? So AA gets cancelled, it will be G power BK. So M G power K mod P, G power BK mod P is basically the ciphertext which can be decrypted by Bob, because it is G power here A is getting replaced by B, so it is a ciphertext which will be intended for what? Bob. It looks like correct now as if the ciphertext is encrypted by using the public key of Bob. So Bob can decrypt CB by using the secret key B. Let us see what are all the problems with this blessed scheme. It is bidirectional, because if it is bidirectional, say B by A is the secret key, they can get the inverse of it, so it will get A by B. By the proxy we is having B by A can get the inverse of it to get A by B, then you can just transform the messages from Bob to Alice also. So the value B by can be used to divert the ciphertext from Alice to Bob and vice versa, and it is transitive. If you check it, correct now, it is B by A into A by B, B by C, correct now, A B by A and C by B, proxy can be from Alice to Carol. And there is a collision problem. If you see what is the collision problem, secret key is B by A, proxy will collude with Bob, Bob's secret key is B, so B by A into B is 1 by A, so inverse of this one will be A, correct now, we will get which will be the Alice's secret. So there will be several problems, and basically you cannot use this blessed ETL scheme to, in a practical applications, because it is bidirectional. The major problem is collision, correct? No, you try to see that whether transitivity can be used with bidirectional, any applications are available, but it suffers from collision problem. So the take-home point in this scheme is why I presented this scheme basically 1998. This basic scheme is just to see that our re-encryption is what things can go wrong, whether it satisfies all the desirable properties of a proxy encryption scheme. And this is not going to generate this is not going to satisfy the desirable properties of general scheme, which is a major problem is this collision problem, right? So let us now come to the access control scenario. Now we have three primitives with us. One is symmetric crypto systems, public key crypto systems, another one is proxy encryption scheme. Now let us see the access control scenario. And then I'm proposing the access control problem. Once I pose the access control problem, we'll try to solve this problem using the primitives which we have already seen. And let us analyze, correct, what are the problems with the primitives, correct, if I try to apply to this to access control scenario. So the model, the outsourcing model, you can imagine that I am the owner and there will be a server, correct, who is cheaply giving me the storage and everything. There will be a set of users who are interested in my data, correct, they want to get access to my data. So these are all the three entities which will represent in the outsourcing model. So there will be a data owner, who is basically the data owner is the person who processes the data to be outsourced. I don't have enough space to keep it. I want to keep my data onto some server, and I call him as a data owner. And he does not want to reveal. The very important thing is he doesn't want to reveal whatever the data, what data it is to any third party. Any third party in the sense including the server where actually he is going to store this data also. So definitely you require this data to be encrypted because you don't want anybody to read this data. And not only that he encrypts, very talented, just he encrypts and keeps the data onto the server. But he should also give access to the data. And to whom and all you want to give access to the data, you want to give access to the authorized users. Suppose the data items D1 to DN are there, which are being outsourced. They have been encrypted and outsourced because encryption is required just because of the reason that confidentiality of the data has to be maintained. Not only that, you want to give access to the authorized users. Some user U1 comes and asks that I need access to D1, D3, D5. And now he's going to give access to that, he should be able to give access to that data items, right? So the goal of a data owner is confidentiality of the data has to be maintained, and also that you want to give access to the authorized users. And another entity in this model is the cloud storage server. It's an untrusted or honest but curious cloud storage server. And he possesses enough storage and computation power because it's a server. And definitely data owner depends on the cloud storage server to store his data and in an encrypted form. And in that model, correct, there are a set of users. And who are these users? These users want to access the data which is outsourced by the data owner. Like I showed that D1 to DN are the data items which have been outsourced. And you want to just allow some set of users to access to some subset of data items. How is going to give access to them. So what the users will do is they will request the data owner, please give me access to this some subset of these data items. Then I pay for you, correct? No, so that's what they say. Then the data owner should be able to give access selectively to these set of users which are authorized. So let me summarize this. Basically, data owner, his goal is his data has to be protected. Not only data has to be protected, he has users requesting him the access to the data selectively, and he want to give access to the authorized users. And cloud storage server is untrusted in the sense I cannot give it. I cannot give him data like this only, plain only, because he can also read the data. But I want from anybody, any third party also includes cloud storage server. So I want to keep it in encrypted form. And once I keep it in encrypted form, definitely right how you encrypt it, how you give access to the data. The problem is that given the scenario of data outsourcing, where data items are encrypted and kept on the server, how to enable the authorized users to access the data? That's the important goal. Let us see a symmetric key solution for providing access control. At the outset, you know the data items from the data owner must be encrypted to provide the confidentiality to the data items. So consider the set of data items. So D1 to Dn. These are all the data items that are to be outsourced. And I want to preserve the confidentiality of the data. You know that I cannot keep D1, D2, Dn on the cloud storage server as is. If I keep D1, D2, Dn on the cloud server as is, correct? No, it beats my requirement in the sense that third party, who is a cloud server, will be able to read this message, data items, D1, D2, Dn. This is the message. So first of all, I need to preserve the confidentiality. How to preserve the confidentiality? You have to encrypt this data item with some encryption algorithm. First is, let us put this symmetric key solution for providing access control. So as a data owner, I will encrypt every data item D1, D2, and Dn with the key K, with a single symmetric key K. Let us see this. Correct? Now, trivially, what I did, I took a symmetric encryption encryption algorithm. Then I have a single symmetric key K. I encrypt using the encryption algorithm, using the D1 using the key K, D2 using the key K, D3 using the key K, and Dn using the key K. So all these, so I will have a ciphertext C1, C2, C3, C4, Cn, correct? No, which are all the ciphertexts corresponding to the data items. Then I will store C1, C2, C3, C4, Cn onto the cloud or the storage server. In a sense, how the encryption is the confidentiality of the data is preserved. Definitely the confidentiality of the data is preserved because data owner, as a data owner, I am the only person who is having the single symmetric key, and nobody else will be able to read the data items by looking at the ciphertext C1 to Cn. And only thing is that all these data items are encrypted with the same key K. Correct? No, D, like E of D1, D1 comma K, E of D2 comma K, correct? No, which gives us C1, C2 like Cn. Now, to provide access control to this outsourced data, what will happen? Now, suppose one user comes, and suppose when one new user comes, he wants access to the data item, say D1 to D1, D3, D5. So to give the D1, D2, D3, suppose say this person data owner gives the key K. See what the user is interested in. User is interested in, I'm going to pay say some amount for accessing D1, D3, and D5. Only 3 data items come among these n data items. Suppose data owner's method tells that I need to give the key K to this particular user. What will be the problem? Suppose say he provides the users with the key K, then using the key K, users can decrypt the data for which they have obtained the authorization. So this is the solution. This is one solution. Let us see that this is one approach. Correct? Now, what are the problems with this solution? So he encrypted every data item with K. Whenever a user comes and asks him for access to some data items, he gives the key K to that user. Using that key K, the users can decrypt the data item which they have obtained authorization. Like he can decrypt D1, he can decrypt D3, and definitely he can decrypt C1, C3, and C5 to get D1, D3, and D5. So whether any problem is there with this approach? Suppose because the data owner has chosen to give the key K to the user who is requesting access for D1, D3, D5. Not only that, correct, user is not authorized to access D2, D4, and up to Dn. He is authorized to operate D1, D3, and D5. And other data items he doesn't have authorization to access it. But your method is giving a key K to the user. Not only that you will be able to access the data items which is authorized to access, but also you will be able to access the data which is not authorized to access also. So because using the key K, a user can decrypt every data item that is outsourced. So what will be the other approach? Hey, this problem is coming because I'm encrypting each data item with a single key. Let me encrypt each data item with a distinct key. Correct? No, using the symmetric key solution. In this case, what I will do, rather than encrypting each data item with a single key, I am going to choose a distinct key for each data item, and I am going to encrypt D1 with K1, correct? No, D2 with K2, D3 with K3, and Dn with Kn. So I will be having the corresponding ciphertext C1, C2, Cn, and this this one will be sent to the cloud storage server. And suppose a user comes. When a user comes to access the data items D1, D3, D5, in that case, I will give K1, K3, and K5 to that user. And by using K1, K3, K5, he will be able to decrypt only D1, D2, D3, D5, and no other data items can be accessed by this user. Correct? No. So, what are all the problems with this? Correct? No. Suppose how many keys has to be generated? N keys. This N keys has to be kept by the is to be stored by the data owner. Then users who are having access to say N data items, they should be also able to store N data items to corresponding to item. So it increases the amount of storage of the user. Also, it increases the amount of storage as the data owner also. And data owner has to be online always, correct? No, to distribute this key case, correct? No, so whenever request comes, data owner has to be online, correct? No, you should give the key to corresponding keys to the users. Correct? No, these are all the problems. So let us shift to the public key solution for providing access control. So same set of data items, say D1, D2, Dn, I want it to be outsourced. I know that I cannot encrypt everything with a single key, so I will use distinct keys K1, K2, Kn to encrypt this D1, D2, Dn, and these are all the corresponding ciphertext. I know what was the problem here. The owner has to store N keys. I don't want owner to store more number of keys. In that case, what I will do, let this PK1 and SK be the key pair of a data owner, and data owner encrypts K1, K2, Kn with its public key, and CK1, CK2, CKN. So D1, D2, Dn are encrypted with K1, K2, Kn, and the corresponding ciphertext of C1, C2, Cn, and the C1, C2, Cn are kept on the server. Not only that, he encrypts the keys K1, K2, Kn with his public key. And let me denote the ciphertext corresponding to the encryptions of these keys as CK1, CK2, CKN. So CK1 is a public key encryption of the KK1 using the public key encryption algorithm, and there's a public key of the owner. And this CK1 can be decrypted by using the secret key of the owner only. But the point, what he will do, the data owner, he stores the C1, C2, Cn, which are the symmetrically encrypted ciphertext of D1, D2, Dn, and CK1, CK2, CKN, correct? No, and which are all the publicly encrypted keys, correct? No, on a cloud storage server. So what is the move that we did with this approach? And here, the owner need not to store all the keys; he can store only SKO. Then all these aspects of confidentiality, everything has been maintained. Definitely the confidentiality of the data has been maintained because both keys are encrypted and kept on the server. Both these data items are also encrypted and kept on the server. Now the question is how actually you give access to the data items which are requested by the authorized users. Suppose the user comes with the access request of D1, D3, D5 among all these data items. How actually owner is giving, how actually owner gives the access to these data items. Imagine now, just I ask you to imagine the scenario where everything is encrypted and kept on the server. Only secret key of the owner is with the owner. So user requests the owner, I want access to D1, D2, D3. Owner has to be online. He has to download the CK1, CK3, and CK5, and he should decrypt those one with secret keys, his own secret key. Then you should encrypt it and give it to the user. Correct? No, and you should do this. Satisfying the access requests of the authorized users for every user, correct, who is going to approach, right? So U1, U2, UKP, the set of users. Let each user have this key pair PK, UI, and SK UI. And suppose UI user requests the item for a DJ, and also the data owner give access to the requested data. So data owner downloads that CKJ and decrypts it and encrypts with the public key of UI and sends it to UI. So through this, you will be having the KJ, and you can download the encrypted data item CJ from the cloud, and you can decrypt this. Decrypt this ciphertext. Okay, so this is how it does it. So the problem is serving every data access requires participation of the data owner. Say that the data owner, he should participate in downloading the encrypted keys. You should be able to decrypt them. Then you should encrypt it, correct? No, and you should be able to send it to the users, the keys, actually which users are requesting the keys. Now, in all these things, my goal is that for every user request, he has to come and do all these exercises of downloading, decrypting, encrypting to every user. He may be a resource constrained device. You may not be having that much computational power and the network bandwidth to do it. So here in this public key solution, it is required to be online all the time. So now the challenge comes is, why not delegate? Because this is computationally intensive task. What is computationally intensive task? When a user requests the data owner for certain data items, downloading the encrypted keys, decrypting them with secret key, then encrypting them again with the public key of the users. No, it's a computationally intensive task. There will be n number of users, k number of users will be having different access requests for everybody has to do it. So now the question is, why can't I delegate the computationally intensive task of providing access control to the cloud? What I will do is, I will ask why can't I ask the cloud himself to follow this? Can I don't want to come online every time, correct? No, I don't want to, do all this job of downloading, decrypting, and encrypting. Why can't I delegate? Whenever the delegate is coming, correct? No, let me try to bring the proxy encryption into the fold. So the approach is to apply this proxy cryptography. So I want you to see carefully, correct? No, why? How actually the owner can delegate the task of providing access control to the cloud. What owner has to avoid? I don't want to come online all the time, correct? No. So I want you to carry out this mechanism of selectively giving access to the data items of the authorized users. So let us see this. So the goal is to delegate. I want cloud to do the job which I am doing. Whether bringing the proxy encryption scheme, correct? No, proxy cryptography into the fold of delegating the mechanism of providing access control to the cloud storage server, can we solve it by using the proxy encryption scheme? As usual, we have to process and store the data, that D1, D2 with the items, correct, which should be outsourced to the data owner. K1, K2, K1 be the keys in which they are encrypted using the symmetric encryption. And C1, C2, Cn be the corresponding ciphertext. I am assuming there is a symmetric encryption scheme, there is a public key encryption scheme, and I also have a proxy encryption scheme in proxy encryption scheme. These are all the primitives. How can I do this? To protect the confidentiality of these data items, I choose the distinct KIs, then I produce the CIs, and these are all symmetric key encrypted data items. Let PKOC SKO be the key pair of the data owner. Data owner definitely encrypts K1, K2, Kn with PKO to get CK1, CK2, CKN. This, to some extent, solves the problem of not storing all the keys at the data owner. And he just sends that CK1, CK2, and CKN to this. And what exactly the data owner is storing now? Data owner is just storing the secret key of his own, correct? No, that is SKO. So data owner also sends all these things. Now request for access. Suppose U1, U2, UK be the set of users who are going to request for the access, correct? No, suppose each user who is going to request is having their key pair. He requests that now the data owner gives access to the requested data. So approach is, look at this. Data owner generates re-encryption key RKO to UI. Sorry. Same problem till now. How actually, what will be the approach by using the proxy encryption key? Data owner generates a re-encryption key RKO to UI. What actually R2 UI and gives cloud storage server. Now, the cloud storage server will be used like a proxy to transform the ciphertext, which are encrypted with this public key of, which are encrypted using the public key of the owner to a ciphertext, which can be decrypted by the secret key of the user UI. Let me stress this point. This RKO to UI is the re-encryption key given to the cloud storage server. Now, cloud storage server is like our proxy in the model which we have discussed. And what you can do with the re-encryption key, you can transform the ciphertext which are encrypted with the public key of the data owner, who is O, to a ciphertext which can be decrypted by the secret key of the user, UI. Right? That's how the transformation can happen with RK or to UI. And who can do it? It is the cloud storage server who can do it. What is my assumption? There is once I use this proxy encryption key for the transformation, cloud storage server will not be able to read any message corresponding to the ciphertext which is re-encrypted. In that case, confidentiality of my data items is also satisfied. The cloud storage server executes the re-encryption algorithm CKI. CKI is basically the key. This is the CKI is the, if you see what is the CKI, how CKI has been obtained, it is the encryption of KI with the public key of the owner. Means it is the asymmetric encryption of the KI using the public key of the owner. And re-encryption, what is that? Its purpose, re-encryption algorithm takes a ciphertext which is encrypted with some owner's public key, and using the re-encryption key, it transforms the ciphertext CKI to a ciphertext CUI. This CUI is the one which can be decrypted by the user UI. So, in this approach, I generated a rekey as a data owner. I gave this rekey to the cloud storage server, and cloud storage server re-encrypts the CKI RK/UI to get this CUI, right? So cloud storage server sends CI and CUI to UI. Because CI is the encryption of the DI using the symmetric algorithm, CUI is the re-encrypted ciphertext, and UI, what it does is, using a secret key, you can get the corresponding KI, and using this KI, you can decrypt the CI to get DI, right? So that's how UI will be able to obtain the data items. So UI gets the KI by decrypting CUI, and he gets the DI by decrypting CI with what K. And look at this. Now suppose the user UI has requested for requested for D1, D3, D5. Let us not change that request. D1, D3, D5. What the re-encryption can be done? So you will do CK1, RKO to UI. Then you will do re-encryption of CK3, RKO to UI. Then you will do re-encryption of CK5, RKO to UI. And you will send that, that you will get CI, then this CU1, CU2, CU3 to the C3 to CU5 to UI. And you will be getting the corresponding keys K1, K3, K5, and you will be able to get the data is on D1, D2, D5. But earlier solution, without the proxy, all this downloading, decryption, encryption were done by the data owner. And who is doing the re-encryption here? Just the responsibility of the data owner was to generate the re-encryption key and go off. And it was now taken care by what? Our re-encryption key. You can imagine that there is an ACM matrix, correct, access control matrix, which guides, correct, no, which are all the users who are authorized to access, which are all the data items, correct. No, this has been given to the cloud server. Assume that it has been given to the cloud server. And if it is given to the cloud server, how cloud server can do is, he can choose the particular ciphertext corresponding to the keys, and he should use the re-encryption key and get to CUI. And he will do that one for CK1, CK3, and CK5 for this user. Definitely, user will get K1, K2, K3. But is there any problem with this? Cloud server not only re-encrypt by using, what is this RKO2I? RKO2UI is capable of re-encrypting any ciphertext which is encrypted with the public key of the owner to the ciphertext which can be decrypted by the secret key of the user, any ciphertext. But access control mechanism, as guided by the, as mentioned by the data owner to the cloud server, tells that UI is capable of, accessing only, is capable of accessing only D1, D3, D5. But here cloud storage server, using this re-encryption algorithm and RKO2I, not only that you can re-encrypt CK1, CK3, CK5, You can also encrypt to that user UI, the CK2, CK4, CK7, CK8, and all these things. But is not authorized, UI is not authorized to access those data items. At the one hand, with the problem of giving the access to the keys has been followed by the cloud storage server. But because cloud storage server in our model is untrusted, correct? No, is not trusted to follow the access control matrix given by the data owner. Is untrusted, but the delegation can happen with proxy encryption scheme. But the cloud storage server can re-encrypt any data item to user UI, not only the D1, D3, D5 also. So cloud storage encrypt any data to the user. Just to put this very concrete for the last 5 minutes, consider an example of a D consists of 5 data items, D1, D2, D3, D4, D5. And there exists 5 users, U1, U2, U3, U4, U5. This is the access. What is the entry 1 means? UI is authorized to access D1, U1 is authorized to access D2, D3, D4, D5. U2 is not authorized to access D1, but is authorized to access D2 and is authorized to access D5. And like that, this access control master can be steady. Now, what is the responsibility of this? Correct now, all these data items, which is D1, D2, D3, D4, D5, are encrypted with K1, K2, K3, K4, K5 respectively. And all these K1, K2, K3, K5 are encrypted with the PKO and public key of the owner, and they have been kept onto the server. This access control matrix has given to the cloud storage server, and the data owner generates RKO to U1, RKO to U2, RKO to U3, U4, U5. All these re-encryption keys are generated. Okay, then it will be this access control method, and all these re-encryption keys were given to the data owner and given to the cloud storage server, and that person goes off, and means he goes offline. Right now, cloud server is having this ACM. He knows that according to this ACM, guided by this ACM, U1 should be given access to all data items. U2 should be given access to only D2 and D5. U3 should be given access to D3, D5, and likewise. But he is having a encryption key RKO to U1, RKO U2, RKO to U5. What he can, I have already explained you what he can do with RKO to U1. And any ciphertext which is encrypted with the public key of O can be re-encrypted so that it can be decrypted by the secret key of U1. That's the meaning of RKO to U1. So this data item is given to you. What cloud server can do? Cloud server, by using RKO to U1, he can give access to all the data items, as I was telling. But come to the curious case of U2. U2 should be given access to D1, D2, and D5 only. By using RKO to U2, he can, if he is honestly following, he is not honest in the model. If he honestly do, what he will do is, suppose say the user U2 is telling that I will pay $100 to access this D2. Give me the access. That is the 100 plus $100 is what is given to data owner. Now RKO2 comes, correct? No, he will just tell, he will encrypt this D2 and D5, and he will tell that I will give you $50. He will tell to the cloud server, I will give you $50. Can you give access to D1? Definitely, what can the cloud storage server violate this? Definitely, he can violate this. By using RKO2, he can take CK1 and he can convert it to the ciphertext, which can be decrypted by decrypted by user U2 only. So he has no access. So what is the challenge here? The challenge is I should generate there is a need to limit the re-encryption capability of CSS. In this, I need to restrict I should generate the re-encryption key in such a way that he can re-encrypt only data items of he can re-encrypt the ciphertext corresponding to data items of D2 and D5 only. That restriction has to be kept on this RKO2. The trivial application of proxy encryption scheme on this cannot completely solve the problem of access control, but the way you are going to generate the secret key, re-encryption key, should limit the capability of a cloud storage server. What I mean by limit the capability of a cloud storage server, the proxy should be generated in such a way that restrict the CSS from re-encrypt ciphertext to an unauthorized user. So this RKO1, OU2, OU5 in a trusted environment, that's fine. But CSS is not often trusted. Okay, that's the reason that how you generate RKO1 so that it can give proxy CSS should be able to generate the access to D1, D2, 5 only. RKO2 when you generate, you cannot open access to all other items which are marked 0. but it should be able to generate the corresponding keys for re-encryptions for D2 and D5 only. So that's basically the challenge. How you are going to restrict the capability of a cloud storage server? That technically boils down to how you generate the private key. If and only if the DI entry is 0, then only you should be able to get the secret. So you can pursue, somebody can just see that. That's basically a challenge. Correct? No? How do you do this? It's a big challenge, right? Because I'm just focusing on products. There are attribute-based encryptions, correct? No, there are key aggregate crypto systems. They're also going to solve this access control problem. But what my restriction is on this proxy key encryption, use the delegation and try to restrict the capabilities of a re-encryption. That boils down to how you generate the proxy re-encryption key. This is the reference that I have taken from. It's a very nice paper which has been written. Very nice introduction to proxy encryption schemes and apply to the secure distributed storage. Thank you.
Thank you, sir.
Yeah.
Thank you very much, Dr. Purushottam. Any questions from the audience, those who are connected online? If you're having any question, you can unmute yourself and you can ask with the speaker. Yeah. As there is no questions, I thank Dr. Purushottam BR for presenting very nicely the application of proxy re-encryption in access control. Definitely, it will be an eye-opener for the audience for taking up any research or small projects in this particular area. So once again, I thank Purushottam BR for joining second time, 2016 also he was there here with us. Once again, I thank Dr. Purushottam for delivering the talk. Thank you so much, sir.
Yeah, thank you. Thank you for the opportunity. Yeah. Can I sign off?
Yeah, please.
Yeah, thank you.
Good morning, Dr. Saxena, sir.
Good morning. Very good morning to all of
very
you.
Good. Yeah, very good morning, sir. Very good morning. Very nice to see you online. Yeah. Your audio is very clear. Can you please project your screen so that we can have an initial checkup? Permission ಕೊಟ್ಟಿದ್ಯಲ್ಲ? Yeah, we can see your computer screen. Yeah.
Is it visible?
Yeah, it is visible.
Okay.
Yeah, thank you so much, sir, for joining with us. Now I invite Shweta B for introducing Dr. P.K. Saxena to our audience, please.
Good morning to one and all. I, Shweta B, Assistant Professor, Department of ECE, JNNCE, Shimoga, take this opportunity to welcome you all for the 7th technical talk of NWC 2021 on challenges in securing information. In this regard, we have an eminent speaker, Dr. P.K. Saxena, with us. It's my privilege to introduce Dr. P.K. Saxena to you all. Dr. P.K. Saxena had been an outstanding scientist and director of one of the premier laboratories in DRDO Scientific Analysis Group located in Delhi, presently engaged with Office of Principal Scientific Advisor to Government of India as PSA Fellow. He joined Scientific Analysis Group DRDO in 1981 as Scientist C and became Scientist G in 2002. He was appointed as Director of SAG with effect from May 2003 and headed the lab till his superannuation in July 2014. Dr. Saxena became Outstanding Scientist in 2009. His area of interest include algebra, cryptology, fuzzy logic, artificial neural networks, information cyber security, and speech technology. He has published over 65 research papers in national, international journals and conference proceedings. Dr. P.K. Saxena had been a member of working groups on cyber security and technology committees for review of the project funded by DRDO MEIY Office of Principal Scientific Advisory. After joining Office of Principal Scientific Advisory, Dr. Saxena has been involved in activities pertaining to cyber security, machine translation for Indian languages, and quantum computing. He is Chairman Advisory Board and member of Governing Council for Society of Electronic Transaction and Security, SCTS, an organization working in Chennai under Office of PSA. On behalf of NWC 2021 and Electronics Department JNNCE Shimoga, I welcome you for the session, sir. Over to you, sir.
Thank you. Thank you very much. Am I audible?
Yes, sir. Yes, sir.
So I am going to talk about these challenges in securing information exchange. I hope the video, audio, everything is okay.
Yes, sir.
Okay. So let's start with the concept that what is actually securing information when it is being exchanged. Okay, so actually we will be talking about exchange of information mainly on a network. So we are not going to discuss much about the communication, electronic communication side, electronic communication equipments and other things, but the concept in general, whether the communication happens on electronic network or computer network, whatever it is, I think concepts remain common. But mostly the information which is being exchanged between two entities, that is digital in the current scene. And in the world of digital information exchange, in fact, this is full of devices, computers, systems, sensors, networks, smart utilities, servers, microcontrollers leading to global connectivity. And we exchange the information with devices or systems, or devices and systems interact with devices and systems in a network or point-to-point basis. So when we talk about this exchange of information, the all the parts are included. Like on one side maybe human, other side may be a system, or both sides there may be system, or both sides there may be human, but the media through which the exchange happens, that is computer or electronics, and that may be anything. It may be just a simple custom network, or it may be LAN or WAN or whatever it is. So all the things are included in this discussion. So if we look at the progress, what is happening and where we are, in fact, we are full of this Internet of Things devices, which we are using every day in our life. We have programming of devices to function without human intervention, high-speed trains, aircrafts, maybe surveillance drones, these days bitcoins, cryptocurrency. So many of these applications are for common use without any restrictions from the any advisory or any regulatory instructions from the government. But in some of the cases, because of the security concern, there are some regulatory guidelines and directives issued by government. So, for example, the surveillance drone. As such, so far there was not very clear written guidelines, and this was drone using drones was totally prohibited. But a guideline and the advisory is soon coming on how to use drones, what are the restrictions, what are the norms of licensing and all. Similarly, this cryptocurrency and Bitcoin, in our country, this is not a regulated currency. Government is considering it how to deal with the increasing use of cryptocurrency and people investing in cryptocurrency in our country. So as such, it is illegal, but Reserve Bank of India is planning to come up soon with a digital rupee concept, which is different from the centralized cryptocurrency. But then a lot of these exchanges and trading in these currencies is going to happen through digital communication and this only. So all these concerns, I mean, the security concerns remain in all these areas. So there are some other developments which I think all of you may be aware about this wearable electronics. In fact, last week or 10 days back, there was a news item that Japan, they have come up with a dress which can change the colors and design after you wear it. But there are so many wearable devices which we use, like, for example, wristwatch, wristband for our health monitoring and all. And these health monitoring devices, they will record your data, health data like ECG or pulse or whatever it is. They will communicate it with your mobile device. And if you share your mobile with your friends or some in your network, then this is available to all those with whom this has been shared. That means the actual exchange of information is happening from your body to the electronic watch, to your mobile, and then to anybody connected to the network, including maybe your doctor or so. So the challenges are that how do we ensure that all this remains fruitful, faithful, and without any threats in between. Similarly, many other devices like CCTV camera, smart homes, air quality, air visual suffer. All these applications, I think many of you may be using in your day-to-day work. We also use social networks like Twitter, Facebook, mailing, messaging, WhatsApp, FaceTime, Skype, all those in which the exchange happens in the digital form. So the most commonly used cyber services are like online ticketing, online bill payment, shopping, e-wallet, net banking, iTax return, KYC through Aadhaar and all. And in all of these, the biggest concerns remain the security or somebody misusing or posing at somebody. So many such concerns remain when we talk about this exchange of information in digital form. So let us see that what are the actual requirements of information exchange. So whether it is a computer network or it is mobile communication or it is electronic networks and whatever it is, the core of this remains whatever is reflected in this transparency. So the first thing becomes that the information could be either a text form or it could be a speech or it could be a photograph or a map or drawing, or it could be a video which is mix of photographs and speech, or it could be a just raw data. So anything is to be exchanged between two entities in a network, two nodes. So the first requirement becomes that how do we code this into bits? Because ultimately on the channel, the bits have to travel. So there are so many ways in which different types of information can be coded. Like in text, you have ASCII coding, Murray code, so many other coding methods are there which can convert written text into bits form. Similarly, in speech, you have n number of speech coders, analog to digital coders like PCM, CBSD, delta modulation and all, which will convert this speech into bits. In photograph also you have different formats like JPG and others where the information is converted into bits with some information header and other information telling that what kind of image it is. Video is a mix of photograph and image. Data maybe in the form of numerical data or digital data. So that again can be converted into bits through binary logic. So first part becomes that converting the information into bits. Then since these information currently on the channel, this information is not digital information is not traveling continuously. It is actually traveling in terms of packets. So these packets are structured in some manner where the formats is decided about this packet. Packet will contain lot of information like first is that what is the actual content which is to be embedded into this packet. The other thing is that the source and destination addresses, because this packet has to travel a long distance, switching from one place to another place and all. So addresses are required to be included in these packets. The sync information is also to be included. Then again, whether it is speech, text, or so, some information about that is also to be embedded into these packets. So it is first is coding, then second is packeting of the information in. Then again, if encryption security is required, then some encryption has to happen for this packet. Now again, the question arises that whether the whole packet with all these embedded additional information is to be encrypted, or only the content of information, actual contents are to be encrypted. It depends on the requirement, and it depends on actual the channel on which it is to be sent. The next requirement is multiplexing. In fact, a channel is not exclusively being used for single purpose. Simultaneously, it is exchanging different variety of information is being exchanged simultaneously on a channel. So this multiplexing is required, where one packet for one information goes, then subsequently second time maybe packet from the second information, and like that. So so that the channel is being used very effectively and economically. And then this transmission happens. So multiplexed signal is being transmitted, and if the network is broad WAN or LAN or something, then routing is also required. Routing or switching of these packets is also required. At the receiving end, the packets are to be received, but then demultiplexing is required, so that the information, all the packets pertaining to one information, they are collected together, and then the repackaging them and decrypting whatever part has been encrypted here, that decryption is required, and then reconstruction of the information from these packets which have been sorted out and found out in a sequence. Then they have to be put together, and then from that the additional information which was regarding addresses, type, and other things are to be removed, and all information bits are to be put together to reconstruct the information bits. And then once this totally reconstructed bits information in terms of bits is available, we have to decode it, because we have to ultimately get this information in terms of text, speech, photo, or whatever it is. So this is the whole process of exchange of information in whatever is network, point to point, in electronic, and whatever it is. Now, for all this, there is a protocol which is required to be decided, that what will happen first, what will happen next, so that all the entities taking part in that communication, they follow the protocol and the communication happens. And then the total concern remains about the overall security. You see that this encryption part, this takes care of only the encryption of the bits which are there, information bits. But there are n number of things which are there, like if somebody intrudes and he disturbs this formatting itself, then the channel, or after receiving this disturbed packet, one would the all the formatting will be disturbed, so it will be impossible to reconstruct the signal at the receiving end. So it will be kind of a denial of service, because the communication is not going through. Something is happening in between, and the information is being disrupted. Similarly, if somebody disrupt this coded information also, say inserting few bits in the contents, that may disturb, because the if it is a 5-bit coding, for example, and if you insert something in between, then the clubbing of 5 bits together to find to make the character, that will be disturbed. And though it is not actually encryption or decryption, but the reconstruction of signal will be, I mean, it will be a junk. So there are so many issues here rather than just encryption. So if the total communication is to happen in a secure manner, then every step we have to take care of, and we have to ensure that things are happening and being executed in a proper manner. So overall security mechanism and this protocol is very, very important. Now, another aspect here is that suppose I want that information, exchange to be secure, then one thing is that we go to some proprietary things rather than public things. So that the intruder doesn't know to access the information. So it's not that everything can be done in a proprietary manner. For example, this if it is a general network, it is not one dedicated network of few systems or all. Then it may not be possible to have a proprietary multiplexing. It may not be possible to have proprietary routing because the network is constituted of different heterogeneous entities. So these proprietary things cannot happen there. But encryption can be proprietary. At the receiving end, of course, you have to ensure that sharing of keys and all, but that could be proprietary. So it depends on the requirement, and then the network or the communication channel where we have to exchange this information, that what things could be done in a proprietary manner and what could be done in a using public tools and techniques. So let us see that what are actually the threats to the information during this exchange. The first threat is that which we call as a denial of service. Like between these two nodes A and B, there is some intruder who interrupts this channel and the communication doesn't happen. Say, for example, I told that somebody intrudes and disturbs the packet formatting itself. So multiplexing is disturbed. So the multiplexing is not happening at the receiving end and all. Maybe on the channel, some additional, information is being exchanged, which floods the communication channel, and the genuine communication doesn't get the sufficient time for the exchange. So this is the first kind of a threat, which is known as denial of service attack. The second kind of a attack is where eavesdropping happens. Like the A and B, they have communicating each other, but somebody without their knowledge, somebody intrudes and gets access to the information. So this is the second kind of a threat. The third is that this intruder not only listens in between, but he captures some packets, modifies, and then sends this to B. So A and B, they are not aware of that what is happening within this channel. So some information is being changed and communicated here. And it's not actually disruption, but deliberate corrupting the message and misguiding B. The last one is that somebody without knowledge of A, somebody poses as A, and then it sends the information to B. So these are mainly four kind of threats to the information when it is being exchanged digitally. So what our goal remains that we have to protect the contents from the unauthorized access. That remains the primary objective, that if our information is secure or confidential, that should be protected. So through encryption or whatever it is. The other requirement remains authenticating the persons and systems exchanging information. So somebody eavesdropping and then posing as A and sending it to B. So to avoid those kind of things, the authentication of A and B before actually the exchange happens is very, very important. And protection against modification, fabrication, safeguard against imposters, non-repudiation. Somebody sends the information, but later on he denies that I have not done that. So ensuring integrity of information exchange and trust and reliability. This is required that whatever information is being exchanged, it is not changed or modified in between. Service, availability of service, and acknowledging receipt of information. So these are broadly the goals for exchange of information. So if I summarize, actually there are three main important issues here. One is that our ability to exchange information on channel. We should be able to use the channel and communicate whatever we want to communicate. And whatever we want to communicate, that should remain unchanged during this exchange. And before that, we should establish the identity of the entities exchanging the information. So these remains the primary objectives. So if now we look at the current, kind of threats, actual threats, and what is our growing concern to address that. So I think every day we are reading newspapers and getting information from CERTIN and others. Actually, CERTIN is the organization in MIT whose main responsibility is to keep on recording any kind of attacks which are happening on government networks, and then suggesting them that what are the safety measures which they have to take. So there are many instances reported every day. It's a known phenomena. It's not only our country; it's everywhere that this happens. And this happens because of the sophistication which is happening in the technology. And whenever some new feature is placed in a device, say this is placed in a device to facilitate the user, to make him more comfortable and user friendliness and all. But the same features, the other side, I mean the intruder tried to exploit that feature for the attack kind of a thing. So there are other technological user trends which are happening, which are increasing the risk of security, like Wi-Fi networks, outsourcing of data service and storage, peer-to-peer sharing, offline to online business shift, this PDAs, laptops, memory devices. I think these are the increasing use of gadgets for digital transformation, digital transmission that is happens, and that as I've told that like these PDAs. Now this very user friendly and very convenient for everybody to use. But then there are some devices, additional devices can be connected to this, and where your all this card data can be is stolen, and then these attacks, digital frauds can happen. So there are some other kind of attacks also which are not directly on the sophisticated attack using the devices, but there are some other social engineering kind of devices also, where one is attracted to attack to use that facility and then get trapped in that. This is, for example, this drop thumb drive attack. This was one experiment which was done where around 150 thumb drives, they were dropped in different cafe by a study group with some devices having malware on those devices. So just to see that how this public is aware about, and whether people are not going to use them without any scanning or something like that too. So ultimately, he found that almost 80% of the people, they use that device without any cross check whether this, because this is available free. It was something which is available free. People don't bother about its vulnerability and the threats which it can pose. Similarly, these drop boxes, which this facility which is available in cloud, they are also suspicious because all your data you are putting on these drop boxes. So your location is there, everything is there, your personal data, your photographs. So this is also posing a risk. CCTV is a media of attack because it gives online your presence, that whether you are present in the house or you are not. So built-in bugs in these CCTV cameras is a common practice. There are other attacks which are happening these days, like there are some bulbs, Philips bulbs, which was later on withdrawn. But these bulbs, the brightness and lumens can be controlled through your mobile, and they can be, since they are connected to Wi-Fi, so anybody can intrude on those bulbs. And it was a common threat observed that the lumens and the frequency of light through emitting from these bulbs could be adjusted so that it causes epilepsy. So, this kind of attack on your health through these bulbs is possible. So similarly, there are other kind of attacks which are possible in devices which we use. I think many other such attacks have been demonstrated every day. People are demonstrating that this thing is vulnerable. Then some patches come, and then again some attacks come. So this race of patching and attacking this continuously goes on. But the technology is moving, but certain things, they can be actually controlled through some policies and some others. So they're in this, they're like Zigbee. This is a well-known radio protocol. This is now being, it was found, of course, 1990, but now it was found that this can be used to spread malicious software in devices and all. So maybe at that point of time, Zigbee was a very useful tool, but somebody studied it and found the that misuse that it can be. So light bulb I have already told, but this is, I think, a very interesting kind of experiment which has been done in Israel. That the principal mechanism in this attack is that a bulb is actually in your room, and there whatever is speech, whatever we are talking within that, then that speech influences the wavelength and light waves emitted by the bulb. So the distorted optical signal can be captured by telescope mounted with electronic optical sensor placed on eyepiece. So just outside, if that light is coming out of that room, somebody outside can monitor the frequency of the wavelength of the light wave which is emitting from that bulb, and that is actually capturing what is being speech signals there. So a specific device, this electro-optic, was constructed which demonstrated that at a distance of 80 feet, the conversation going on in the room was reconstructed and heard. So you see that who could have imagined that this light bulb which is there that will capture the speech signal. So all these kind of sophisticated attacks are happening when this information is being exchanged. Is another applications in this mobile app is this is also I think a common threat which came to light by this cyber group working in this area, that the oxygen level measuring this was widely used during COVID time, oxygen saturation level. But it was found that it sends a link which may be a malicious. So this asked for access to storage, photo gallery installation. You need to put index finger on camera, taking finger print. So of course there is a only signal, but there could be a camera also there that could take the fingerprints and then communicate it. So personal details can be compromised through this fingerprint and other. So similarly, the other photographs and videos stored on mobile can be compromised. And the reference, I mean, if somebody is interested, that Hectovo, it can be searched and then it would be further details can be seen there. Similarly, this phishing links inside this .ics calendar. This is a common practice. We use these calendars to fix up our meetings and all. But this PDC discovered that cyber criminals are using calendar invitations to launch phishing attacks. And the reference is here. One can see further details. This another attack, this vulnerable RC vulnerability impact Windows DNS server. So a new critical 17-year-old vulnerable remote code execution vulnerability in Windows DNS server could let unauthorized hackers compromise the entire corporate network using unauthorized domain administrative privileges. So these kind of sophisticated attacks are happening. This was also in the news last year. Twitter accounts were hacked for well-known personalities like Joe Biden and Elon Musk. And it was published in this thing. So these kind of Twitter attacks can also be seen in the reference given here. Similarly, other Twitter accounts were also hacked. Bill Gates, Joe Biden, former President Obama, and all. And Twitter and other investigations uncovered an operation that targeted Twitter employees to gain access to internal systems. So whatever social networks we are actually using, they are all vulnerable. So one has to be very careful in posting the information on that. And this location service, I think many of us are very frequently using, which is very, very serious things. Another hacking happened on this coronavirus research itself. I think a lot of news was there about China and America that who is told the information from whom. And this is one evidence which was reported in this, that US accuses 2 Chinese hackers of seeking and installing coronavirus vaccine research for commercial purposes. So I think these are kind of attacks which are happening. And sophistication in all these attacks is now when the attackers found that maybe I will not be able to disturb the packet size. I will not be able to disturb the multiplexing. I will not be able to decrypt the information which is encrypted. So all those things which I told in the initial transparency for securing communication, people found that it is very difficult because the sophistication is happening and the service providers, they are taking all care and all. So then the attackers, they came up with new concept of ransomware. Well, so maybe I will not be able to do anything in the accessing the information, but I can post some malware which can encrypt whole of the disk or whole of the file on your computer system, and then ask for money, and this key will be only available with the intruder or with the attacker. And if you pay the money, then your data will be decrypted and your access will be given to you. So this kind of attack is actually a kind of a denial of service attack, and it's actually the theft of your data, and I mean asking money for the services. So I think this is latest kind of attacks which are happening not only on private networks or private systems, but on corporate also. Some such things happen. And I think you may be aware about latest information on what kind of ransomware attacks have been launched on different kind of networks. They have happened in Russia and they have happened in US and all. There are certain groups which are identified and which are suspected from Russia or from China, that they are very good in mounting these kind of attacks. So I think these are different kind of attacks which are happening, and the core of such attacks is the malware. Because everything disturbing your communication or stealing your information, everything happens through some malware which will be put on your system through whatever means it is possible. Maybe through some patches also it can come. It may come through some links which we click on our computer or on our mobile. Some links are sent and we click that. So these malwares can come through various means, and then they can do whatever kind of attack they are designed to have. So I think there are certain malware analysis tools which are available. So I think this Remix Linux version 7, this I am just giving because in your network, if some such attack happens, then maybe help can be taken from such tools which are available. There are some malware reverse engineering handbook which is available and which gives complete guidelines then how to deal with it and how to handle these. But the bottom line is that you should not pay them because it's not certain that after taking money they will actually decrypt. They may again blackmail and you may not get. So it's better not to pay for this ransomware, but take help from such tools which are available. So now with all these kind of different scenes where the disruption or stealing of information or malware attacks then can happen, that what we should do? So first thing is that the designer of the or service provider, they have to take care that whatever tools they have for various requirements of this digital exchange, they should have that robustness in all those things, like coding, multiplexing, and encryption, and all those points which I told in the beginning, which are requirement. So all those tools, they should be very robust, and the protocol should be robust, because ultimately these modules or these sub-modules in the total scene, they are to be integrated together so that the communication happens. So that is guided by the protocol. So the protocol has to be a very strong and secure protocol. Wherever there is a possibility of having proprietary solutions, we should go for the proprietary solutions like encryption and maybe this authentication between the node A and node B. So all those places, wherever possible, there should be, like if it is a dedicated small network for sensitive applications, then I think more things can be done in a proprietary manner rather than using publicly available things. So I think more proprietary and less public, that is one principle depending upon the application. The other things is that we have to keep regular backup, because whatever we do, I think the features and the capabilities of all these tools which are required for this information exchange, they are so sophisticated, and the codes for all those are several thousands of lines, and like even the operating system, millions of lines, and you don't know whether the operating system itself has got certain vulnerabilities. That's why every day new patches come. So when the things are so broad, where you can't screen everything, you can't make sure that everything is foolproof and all that, we have to take a precautionary measure of taking regular backups so that if anything happens, at least the information is available. And then the risk analysis is to be done organization wise periodically. It depends on the kind of organization. Some organization may not have that much risk of attacks of stealing information, but some working in some sensitive area, they may have that. So this periodic risk analysis is to be done. Then the people who are using the systems, they have to be aware of all kind of threats which are there, and they have to be made sure that they follow the guidelines and the policies which are in place. So some of the things can be controlled only through policies, not by technology. So vulnerability which are happening and patches come, then those patches should be installed on the systems. Applications whitelisting, and these applications, mobile applications, we should not blindly download all applications, because the intruders or attackers, they are actually launching many such applications which are actually malicious, which are not genuine. So downloading applications on mobile as well on systems, we should be very careful. We should always see that whether this is HTTPS or it is HTTP. So links also should be seen, and whether it is a secure link or it is a unsecure link where you are exchanging the information, that part is also to be seen. And if some incident happens, then there should be some team some responsible team in the organization where this whatever incident has happened, that is to be reported. And then this analysis is to be done, that why this attack has happened, and what went wrong, and how to what loss has happened. So to do the loss of assessment, to find out the reason of that attack, and then try to put in safety measures in place so that such attacks do not happen again. And this kind of periodic testing helps in that. So penetrating testing, taking our own systems and finding out whether the intrusion detection system is working properly, intrusion prevention system is working properly or not. So all those things, whether network management system is working properly or not. So all those things can be actually tested during this penetrating testing. So I think apart from technology, there are some regular discipline which is also to be followed. And there is always a kind of a concern whether the Windows operating system is better than Linux operating system and all. And so most of us are tuned to Microsoft. But switching over to Linux, so there is no conclusive evidence that which is better, which is not better, because both are millions of lines of very long codes. And but I think there is some flexibility in Linux. So some suggestions are there that whatever security requirements are primary requirements, then maybe Linux and restricted kernel of Linux may be better. So these are, I think, some advisory that what we should do. So as a safeguard, I think for total communication, as I have earlier told, that the awareness of vulnerability and threats is prime. Unless the user is aware that where the things may go wrong, what are the vulnerabilities, I think he or she will not be able to take proper care. And security is to be designed in layers. Like if I talk about physical security, then perimeter security, then so we talk about 7 layers of security in our information security curriculum. So all those kind of layers are to be implemented and followed. And some hybrid approach where according to the requirement and the policies and guidelines, every organization should have their own policies, written policies and directives for the users, that what is to be done and what is not to be done, do's and don'ts, and they should be followed by all employees. And one should also be clear about the cyber laws that like forwarding the messages. It's a common practice on our mobile. Whatever information we get, we forward it to the next without whether it is a misguided information or it is some dummy information. So these cyber laws are becoming strict and strict about these kind of sharing of information. So one has to be very careful about sharing or forwarding of these messages. As far as technology is concerned, I think which can help in providing security at different level, this cryptography, hash functions, coding, different kind of coding techniques, compression, expansion, error correction, steganography. I mean, these are different kind of technologies which are useful for providing security. Say in terms of this coding, I think I was talking about that wherever possible we should go for proprietariness. So in case of speech security systems, I think there is a good chance and scope of having the proprietary A to D converter rather than having publicly available things. Because the device from which you will speak and the device from which you will listen, say for example, mobile phone. If it is a Nokia mobile phone talking to Nokia, and if that chip is designed where this coding is proprietary, then there is no issue. But if it is one mobile to another mobile, then this propriety may not be possible. So in sensitive application, in a closed group communication, some proprietary coding can be used and proprietary algorithms can be used for speech communication. So these, I think, are necessary things for the designer, that security should be by design. I mean, if something has been designed and if we add features to security, those features may not be sufficient and they may be prone to the attack. So if we want that security is to be designed from the very beginning, taking into account security for all the modules or for all subsystems in a total communication network. So the I think the other things are again two-way authentication for I mean new mechanisms like in our mobile also, or in network paying system, or a banking system. Earlier we just had one kind of a challenge response kind of a thing, but now we have CAPTCHA also for networking, and then we have a password also, and then OTP also is sent on your mobile. In some of the ATMs now, you can withdraw money only when OTP is sent, or mobile and all. So these are some new additional authentication mechanism which are being which have become necessary because the other things were not sufficient. So I mean there are certain other possibilities of security certificates and all to provide that security at different level. So this is, I think, the summary of what are the technologies which I mean, which can be helpful in our cybersecurity requirements, where information is to be exchanged in digital form and in a secure manner. So hash functions, I mean, I am sure that in other lectures, whatever is written here, and most of the things would have been discussed and detailed I mean, talks might have happened. Hash functions, for example, they are very useful functions, one-way functions, which are mainly used for authentication purposes, but they are used for many other purposes also in this total security process. And encryption systems, maybe they are I mean, private encryption, or maybe symmetric key cryptography or asymmetric key cryptography, a different kind of usage. But mainly they are used for securing the contents. But I'm sure you might have been told when these public key crypto systems and private crypto systems would have been discussed, that they can also be used for authentication purposes, establishing the identity between A and B nodes who are communicating. So in authenticating, hash functions can be used, public key crypto systems can be used, and private crypto systems, I mean, symmetric key crypto systems can also be used. There are different protocols which can be used depending upon the speed and the requirements. Say for example, if the computational requirement is not only small information is to be exchanged, then maybe asymmetric key crypto systems, digital signatures, and then encrypting, those can also be used for authentication purposes. There is another area, steganography, which is also used for securing information and exchanging the information in a secured manner, where actual information is hidden in some photograph or some video or some audio, and send it to there. And there are actually hybrid approaches also, where something is first encrypted and then it is hidden in a photograph or video, and then this video goes on the channel. So look at the complications in all these things. First encryption happens, then it is hidden in their photographs or video, and then everything happens like multiplexing, demultiplexing, exchanging this photo, steganograph photo to other side, reconstructing signal and all. So again, this is I mean, not very commonly used, but for very specific security requirements, this is useful. Then security transmission, frequency hopping, SDR, crypto protocols, all those things are happening. And in secure customization, I think this is hardware security network, this network management, firewall routing, secure source coding, secure system engineering, all those things are important. So this is the last transparency that summarizing that for secure communication, what are the technologies which are available, but mainly the technology as well as the policy and the self-discipline is the prime requirement if we want to exchange the information in a secure manner. So with this, I stop, and if there are any questions, I can answer.
Thank you, sir. Now I request the participants to have their queries, if any. If there are no queries,
yeah, I just want to say that it was a very beautiful lecture, and the students would have found it very convenient to understand the various aspects of the security involved in it. It was a very nice lecture.
Thank you very much. Any questions? If there are there, I can. So since the topic, I mean, contains so many technologies, going into detail in any specific topic that requires a separate lecture in itself. Like coding itself is a one big topic. Multiplexing, formatting itself is a big topic. So I just wanted to give a overall picture, and then details can come in specific lectures on each of them. I'm sure that in this workshop, many other talks would have covered things which I have talked here. So thank you for giving this opportunity. And any questions later on also, if somebody, you can give my email address to the participants, and they can communicate with me one-to-one at any point of time if it is required. Thank you.
thank you, sir. I take this opportunity to thank Dr. P.K. Saxena for the wonderful session on challenges in securing information. Thank you, sir, for being with us through the NWC 2021.
Thank you.
Thanks.
Yeah, I thank you, sir. Thank you once again, Dr. Saxena, sir, for your time and in continuously interacting with me in preparation of this workshop. Good afternoon, sir. Dr. Balasubramanian, sir, you are online. Thank you so much to see you. And Dr. Indira Gupta also joined, who will be talking next. Let us join at 12 noon exactly after having tea. I request online participants and our students to join exactly at 12 o'clock so that Dr. Indira can start his lecture. Thank you, sir.
Hey, Indira. Nice to see you. So I will sign off.
Sir, Saxena, sir, there is a small question from our student.
Okay, I will sign off. Okay.
Sir, To you only, Saxena sir, there is a question.
Yeah. Okay. So I will leave. Yeah.
Come. It's fine. Yeah. Till that time, what you are doing? Oh, you started now, right? Good morning. Good morning, Dr. Indivar. Am I audible? Dr. Indivar, am I audible?
Hello.
Yeah, you are audible.
Yes. Now I am audible.
Yeah, good morning.
Good morning.
I can see your computer. Please project the screen for initial testing.
Okay, just a minute. Is it okay?
Yeah, please move this slide. Please move the slides. Please go to the next slide. Yeah, it is moving.
Okay.
Okay. Yeah, welcome back again, the audience connected online and offline. Now we are going to the third technical talk of today's presentation. So we have Dr. Indivar Gupta with me, who is the well-wisher of JNN College of Engineering and very fond of conducting national workshop on cryptology. I'm very happy to introduce Dr. Indivar. He did MSc in mathematics from Jivaji University, Gwalior, PhD from IIT Delhi. Presently, he has been working as a senior scientist at Scientific Analysis Group, DRDO, New Delhi. His areas of interest include cryptology, information security, high performance computing, computational algebra, and number theory. He has guided many MTech and PhD students. He has more than 25 papers in his credit in national and international journals. So today he is with us for presenting a technical talk on applications of public key cryptography in secure communication. I think Dr. Indivar would be with us for another 45 minutes to 1 hour. Now it is over to Dr. Indivar, please.
Good afternoon to all. So today I am going to talk on the application of public key cryptography in secure communication. So before we move ahead, just I give you quick about the basic structure of cryptography. We just see how we use the cryptography for secure communication from this image. So whatever input we have, input may be text, image, facts. Okay, so first we have to use some encoding technique to convert in the computer language or binary bits. Then we use the compression techniques. After that, we use encryption techniques. Then we use steganography, and then error control coding, and finally modulation. And then we send this to wireless or wired media. Okay. And then for this receiver end, we have to do the reverse process of that. So you can see here where the role of cryptography comes. Okay. So for this, see that for inputs, we use some kind of encoding. For text, like we are using ASCII. For speech, we are using PCM coding. For picture, movie, JPEG, MPEG, fax. For fax, modified Huffman coding. Okay. Now this talk, I think it might have been covered in earlier talk about the cryptology. What is cryptography? What is cryptanalysis? Then symmetric key crypto, public key crypto, hash function, digital signature, non-repudiation, data origin and authentication, message authentication, entity authentication, key establishment, certifications. So these are the basic terminology we use generally in cryptography. Okay, so here the by more focus on public key cryptography. So in public key cryptography, as in the traditional symmetric key cryptography, Elias and Webb both agree on common secret key. However, in case of public key cryptography, each user having their own public key and a private key. And that's computing private key from public key has to be interactable. Okay. So now what is public key cryptography and how it's developed? We have discussed the public key cryptography. So the public key cryptography developed by Diffie-Hellman and Markley in mid-70s. Okay. And then as discussed, each user has a pair of key that is known as a public key and a private key. Everyone has access to public key, but private key information can be accessed by the only owner. The biggest things here is public key depends on computational hard problem that prevent inverting the public map. And the second thing is computing private key from public key has to be interactable. So this is basic concept of public key cryptography. So when we talk about the public key crypto systems, so it's basically 5 tuples: a set of plaintext, set of ciphertext, set of keys, then encryption and decryption. Okay, and as I discussed, it is computationally infeasible to compute decryption key from the key, that is encryption key. Okay, and then if image a message, so we use encryption key, and then to revert to get back the message, we used to use a description algorithm, but description key. And ED operations, mean encryption and decryption algorithm, both should be a very efficient, computationally efficient. So what is the advantage and disadvantage of public key cryptography over symmetric key cryptography? The main advantage here is key security. That is, only private key need to be kept secure. Second advantage is longevity. That is, key pair may be used without change in most cases over the long period of time. However, in symmetric key case, we have to change the key very frequently. For the key management, we have in the large network, fewer private key will be required. And then in symmetric key, we have to exchange the key among all users. But however, we don't have to exchange in case of public key cryptography. Biggest advantage of public key, we can design a digital signature scheme. Yes, there are some few disadvantages. That is performance, because performance-wise, it is slightly slow in general. And the second thing, here we are dependent on the role of certifying authority, and we need public key infrastructure. And the third disadvantage is it depends on well-defined computational hard problem. Okay, so presently we know that this computational hard problem is an exponential problem or sub-exponential problem. But if some algorithms comes, then we have to change the computational hard problem, or we have to design some new public key based on the different computational hard problem. Okay, so now we see the actual application of public key cryptography, where we are using public key cryptography. Just to see check the online banking side. Online banking side SBI. Okay. So when we check its detailed certificate, if you click here and you check the detailed certificates, what they are going to use here. So you can see here is it privacy history, and then regarding the site. Okay. So here connection is encrypted. That is, whatever connection in the SBI banking online, it is encrypted, and they are using transport layer security, elliptical Diffie-Hellman exchange (RSA), and then AES 256 GSA mode, SHA-384, and 256-bit key, and the TLS 1.2. That means they are using transport layer security 1.2 version. And for the encryption, they are using AES, and for key exchange and signature verification, they are using elliptical based Diffie-Hellman key exchange protocol. So here we are using for signature as well as key exchange protocol in SBI online banking. Okay, now we see that famous website, that is NTA, Online Testing Agency. Again, you check and verify. That check and verify. Online, after online banking, email, you see the government email ID, email.gov.in. Okay, and see what kind of protocols they are using. It is connected and encrypted. They are again using elliptic diffie element problems, key exchange problem, RSA, and they are also using transport layer security 1.2 version. Okay, NT website, they are also using. So this is a standard format we will get here when we check the website. Okay. So what is meaning here is just I explained TLS, elliptic diffie element exchange, RSA with TLS. What is meaning here? Elliptic diffie element key establishment protocol. RSA parameter are signed using RSA algorithms. We can verify it publicly. If we are using AES 128, that means we are using confidentiality provided by AES 128 in cipher blockchain mode. Okay, so the CBC represents as AES is using in cipher blockchain mode and key size is 128 bit. Okay, then hash function they are using size hash function and HMAC is message authentication code. So these are the general interpretation in TLS 1.0, TLS 1.3. Okay, so now again you can see what is the interpretation of this this TLS version 1.2, which is being used in SBI online. Okay. Now you see this WhatsApp web. So here you can see in what kind of security they are using: TLS AES 128 GSM, SH 256 128 bit, TLS 1.3. So they have started using TLS transport layer security 1.3. So what is meaning of here is TLS 1.3. Just you can interpret, but here we have not mentioned anything here regarding the public key cryptography. It is understood either RSA or ECDSS, RSA or elliptical digital signature algorithm are being used for signature, and another things may also be used the diffie element exchange that they use ephemeral diffie element key exchange, okay, or ephemeral elliptical diffie element key exchange algorithm for key establishment. So here they have not mentioned here they are using TLS 1.3, but transport layer security 1.3. So here AES 128 they are using in Galois counter mode, SHA 256 hash function they are using, and then they have given the freedom for us that we can use what kind of primitive like RSA or elliptical digital signature algorithm for signature parameter verification, and then ephemeral diffie element or ephemeral elliptical DL1 for key exchange protocol. So this is the standard format to write this TLS 1.3. Now we come to the security in WhatsApp. So WhatsApp again they are using elliptical diffie element protocols, key exchange protocol for key exchange mechanism, and the another thing they are using curve 25519. Okay, it's well-known curve they are using in WhatsApp. So you can see what kind of application public key cryptography we are using public key cryptography. So just if you summarize these things, so Sunline online document, session key encryption we use, open PGP that is a pretty good privacy we use public key cryptography, smart devices, personal digital assistant we use public key cryptography, for disk encryption we use public key cryptography, in blockchain techniques or cryptocurrency we are using public key cryptography. So in summary, for what kind of application we are using for public key cryptography, we are using key exchange protocol, we are using for it for the digital signature and round validation, we are using for message authentication, we are using for confidentiality. But generally to provide the confidentiality, because this is public key crypto systems are slightly slow, so most of the time we use symmetric key crypto system. So what is basic concept of PKC? Now we come to that talk. So to introduce the basic concept of PKC, we will have to go on some, we will have to discuss about something about the complexity in cryptography. Okay. So because this is the important topic. So first we come talk about the representation of number. So how do we represent a number in bits or words? So that you can see if we want to represent the number in binary or in number to the base b, then total number of digits is required. That is log n to the base b plus 1. B is basis. So if here is 2, then we will write log 2n plus 1. Okay. So like if we want to represent digits in form of number, like for example, 15. So take log 15 to the base 2 plus 1. So that means number of bit required to represent the 15 is 4. Okay. Then we talk about some definition of running time of algorithms. So what is meaning of running time algorithms, size of input, size of output, then big O notation. So here is running time means number of basic operations or steps to execute an algorithm. Okay. So running time of an algorithm is dependent on the size of input. So if size of input is high, definitely it will take more time. So size of input can be in bits, digits, bytes, or what etc. What do you mean by space complexity? Space complexity means it's measured the amount of temporary storage when performing a computational task. So we are running the any program. So the space that is required to execute that program is a space complexity. Now we come to the big O notation. Okay. So what do you mean by big O notation? So suppose we have a two function f and g. So if we write f is equivalent to order of gn, that is big O notation. If there exists a constant, positive constant c and positive integer n0 such that fn is greater than equal to 0 and it is less than equal to cgn for all n greater than 0. It means g is a simpler function of f and it does not increase much faster than f. Okay. So we use this concept in public key cryptography, like a big O notation. Very much we use in public key cryptography for determining complexity of the computational hard problem and encryption, decryption speed and something. Okay, so this is the big O notation. In complexity theory, this is very popular. So suppose n is cubic, fn is a cubic function, and gn is also simpler form of the cubic function. You can see here is that f is approximately or f is equal to order of gn. We can write it f equal to order of gn. Okay, and we have many similar notations we use in complexity theory, that is small o notation. So if we write two function fn and gn, fn is fn equal to small o order or order of gn if fn upon gn n tends to infinity tends to 0. That means gn is upper bound of fn. Clearly, so this means that n is that function gn is growing very fast in comparison to fn. So you can see that small example here is factorial n is equal to order of n to the power n. So n to the power n is growing very fast in comparison to factorial n. We have some other kind of notation. We use this notation here. So now that common function, that if we write order of 1, that means this function is constant. If n is input size, then you can see here double logarithmic function, single logarithmic function, polylogarithmic function, then this fractional, if c is less than 1, linear, polynomial, sub-exponential function, exponential function, and factorial function. Okay, so most of this computational hard problem we use in public key cryptography is either sub-exponential or exponential. Here the sub-exponential function, sub-exponential function is lie between polynomial to exponential. So that you can see here is a small example of the sub-exponential function. So if you take alpha equal to 0 or alpha equal to 1, and then that open this, simplify this expression, you will know that this function is working in polynomial time or exponential time. So based on the value of alpha, this function vary accordingly. So we have discussed about the polynomial function, exponential function, sub-exponential function. Now we come to the some complexity of an algorithm, like a decision problem. So decision problem is said to be in class P if it can be solved in polynomial time. As I discussed, what do you mean by polynomial time? If it can be polynomial function. Okay. So similarly, like suppose if we are saying, we want to say that n is prime. Is n is prime? So we have to use the AKH algorithm, that Agrawal-Kayal section algorithm. Its complexity is order of log to the power n6. Okay, so we can say that here is this n is that log n is input and log n is size of inputs. That is polynomial time and size. Okay, so that means this algorithm can be run in polynomial time. And decision problem is said to be in class NP if S answer can be verified in polynomial time. So NP means non-deterministic polynomial time. So if we can verify the S answer in polynomial time, then we can say that this decision belong to the said to be an NP problem. Similarly, we can define co-NP if no answer can be verified in polynomial time. Okay, and then we can define some equivalence between two decision problems. And then we have given some example. What is NP complete problem? So NP hard problem. So a decision problem is said to be NP complete if that is problem belongs to NP, and if there's any problem L1, any problem L1 in NP, it is this decision problem is a polynomially equivalent of that problem. Okay. Similarly, like for example, subsection problem is NP complete problem. Similarly, we can define an NP hard problem, and we use this kind of concept in public key cryptography. When we design the public key cryptography, we analyze the complexity of algorithm, encryption, description algorithm, computational hard problems. We use this kind of concept. So more details people can refer to my references that we have given for this complexity theory. And for the computer science student, I think in BTech class or MTech, they generally know about the basic things about the complexity theory. So important topic we use to design the public key cryptography, that is in the some number theory topic, that is Euclidean algorithm, modular arithmetic function and their properties, solution of linear and quadratic equations, Chinese vendor theorem, primary testing and factorization. So these are the important topics that we use in public key cryptography. Important topics in finite field that we use to design and analysis of public key cryptography system: irreducible polynomial, primitive polynomials, method for testing them, construction of finite field, basic arithmetic over finite fields, factorization of polynomial over finite field, combinatorial problem over finite fields. So these are some important mathematical concepts we use to design and analysis of public key crypto algorithms. Now we come to the hard problems. So as we discussed public key cryptography, that it is based on some computationally mathematical problem which is computationally hard. So what do you mean by computationally hard? The computationally hard means the complexity of breaking that algorithm, or complexity of breaking that algorithm, or finding basically like or other way we can say that for solving that a computationally hard problem. Computationally hard problem is about 2 to the power 128 or 2 to the power 128. That means like if problem is computationally hard and the complexity is to keep problem is mathematical problem which complexity is approximately solving that algorithm is with the complexity approximately 2 to the power 128 or more than 128. We said presently it is computationally hard problem. So for example, if we are using elliptical cryptography and if we choose the field size is 256, then its complexity comes approximately 2 to the power 128. And now why this problem is computationally hard? So that we should understand very carefully. That just I will explain why this is computationally hard, what is meaning of more detail of this meaning. Then second thing is trapdoor one-way function. Trapdoor one-way function. So just we see the what is one-way function. That means it is easy to compute, but hard to revert. Means if we have a y equal to fx, then it is computationally infeasible to find x. This is one-way function. And what is trapdoor function? So if we know some extra information called trapdoor information, so it becomes feasible to find out the inverse image. So that means if we know some extra information, or that is trapdoor, then we can find out why. Okay, so we use this concept in public key cryptography. Very much we use this concept. Now we come to the actual reverse side, but why this problem is computationally hard when the complexity is 2 to the power 128. So just to see that if you buy some computer in market, then we choose some configuration like we want 1 gigahertz PC, 2 gigahertz PC, 3 gigahertz PC, quad core PC. So what is meaning of that? That means if we are buying some 1 gigahertz PC, that means that computer run 10 to the power 9 cycles per second. So if we assume that, like if you can run this, if one operation means 10 to, if we assume that in the cycle we are running one operation, okay, one cycle, that means it can perform 10 to the power 9 operation approximately. And 10 to the power 9 operation approximately means like this is equivalent to 2 to the power 30 operation in a second. Okay, so if 1 gigahertz, suppose we have a lot of PCs combined together, we are using, okay, so then what happens? We have a cluster of PCs and suppose we have a 1 teraflop facility. Then 1 teraflop means 10 to the power 12 operation. We can perform 10 to the power 12 operation in a second. 10 to the power 12 means 2 to the power 40. Suppose we have a petaflop PC, then how many operations we can have? 10 petaflop means 10 to the power 15. That means approximately 2 to the power 50 operations we can perform in a second. What? To solve the algorithm with complexity 2 to the power 128. That means how many PCs are, how many that 1 petaflop PC required? That is 2 to the power 128 upon 2 to the power 50. That means approximately like we need how many PC we need to solve this problem in 1 second. So if we run years of this PC, 1 petaflop PC, still we can't solve this algorithm with complexity 2 to the power 128. So that means we need, in fact, if we have a tremendous infrastructure, many 1 petaflop PC, still we can't solve these problems with complexity 2 to the power 128. Okay, so that we have discussed here. So now we discuss the problems which we used, mathematical problem which we are assumed as computational hard. Okay. And based on this, we design a public key crypto system like integer factorization problem. Integer factorization is a hard, computational hard problem. Presently, we have an algorithm which is a sub-exponential time, and we choose the parameters carefully. So based on this integer factorization, RSA has been designed based on the concept, that is integer factorization. Similarly, in abstract crypto system that has been designed based on subset sum problem. These are the computational hard problem. Then Raven crypto system has been designed using quadratic density problem. Eligible crypto system designed based on the discrete log problem in finite field. And similarly, like a similar eligible DLP in elliptic curve over finite field is also computationally hard problem. So many system has been designed using elliptic curve discrete log problem. Then design. These are the problems which has been derived from the discrete log problem, that is computational Diffie-Hellman problem, DC and Diffie-Hellman problem, gap Diffie-Hellman problems, get discrete log problems. Then there are other problems like conjugacy search problem, group action and semi-group action problem, binary DC and Diffie-Hellman problem. JUX protocol is based on famous protocol, three-party clear-given protocol. JUX protocol is based on binary decision Diffie-Hellman problem. Then now people are combining factorization and discrete log problem together. Discrete log with conjugacy search problem. Solving system of multivariate equation over finite fields. Decoding problems. So code-based cryptography is depend on the decoding problem. Lattice-based reduction, NTRO, Falcon, these are the lattice-based problem. Hash-based public key cryptography. So some example of hash-based, some hash-based public key cryptography. Computational supersimilar ICNE problems. So these are the important mathematical problems. They are computationally hard problem, and we use these problems to design a public key cryptography. So as I discussed here, RS is based on integer factorization problem. So what do you mean by integer factorization problem? We have a large composite integer. Integer factorization problem is a find factor of n. So finding factor of n is, I told you, this is a computational hard problem. Similarly, discrete log problem. So discrete log problem is basically it's work in group. So suppose G is a group and Y is a generator of cyclic group and Y is a generator of that group. Okay. And now suppose we have given Y and G to the power X. Then if group size is large, then we have to find out X. So X is called discrete log and we have to find out this X. So this is a discrete log problem. It is computational hard problem. So if you see like many algorithms which has been used for the integer factorization, like continued fraction method, then Line-Star elliptic curve method, multiple polynomial quadratic sieve method, general number field sieve method, special number field, these all are best known algorithms for solving factorization problem, and all are sub-exponential algorithm. So if you choose the size of this ends carefully, then we can achieve the complexity. If you use 3072 size, that means 2 to the power 3072, n की size of n is 2 to the power 3072, then we can achieve the 2 to the power 128 security. If we are using this, if we design the system based on integer factorization problem. Okay. Similarly, we have a discrete log problem, and discrete log problem is based on the algorithm are sub-exponential algorithm. So that is why discrete log problem and factorization problem are being used to design the public key crypto system. So just now we explain a few public key crypto system here. What is meaning of this Diffie-Hellman key exchange protocol here? So suppose P is large prime, okay, and then ZP is a cyclic, ZP star is cyclic group, and let alpha is generator of that. So what we have to, and A and B want to exchange their keys, want to exchange. So what A has to do? A simply select alpha. A simply select X and compute alpha to the power X mod P. Okay. And then they send to B. B simply select by and compute beta to the power pi and beta to the power by. I think there is a mistake, that is alpha to the power y. We simply compute alpha to the power y because x and y is known to, x is known to a, x select randomly by a and y select randomly by v. Okay, so alpha to the power y and send it to a. So now you see like what a will do. A, since x is but as a secret key of a and x is known to a, once we receive the alpha to the power y, once a receive alpha to the power y, then a will compute, simply a will raise power x and he will compute alpha to the power xy. Similarly, after receiving, similarly we receive alpha to the power x and raise power b, then he can compute, we can compute alpha to the power xy. So alpha to the power xy is basically shared secret key. So it can be used by A and B. So this is the first protocol defined by this proposed by Diffie-Hellman. It is based on public key. Here you can see like alpha to the, like alpha to the power x and alpha to the power y is we are sending an unsecure channel. So that means anyone can access alpha to the power x and alpha to the power y. But computing alpha x from the alpha to the power x and computing y from the alpha to the power y is computationally hard because it is based on the discrete log problem. So if we choose large prime P, then we can say that this is secure. Here. So the here that's we can say just so this secure because this is secure as a discrete log problem is intractable. Okay, so the enciphering key can be made public since computationally inferior to obtain the deciphering key from the enciphering key. The protocol, this protocol which is open door to public key cryptography. And second thing, suppose like from we want to compute alpha, since alpha to the power xy is a common shared secret key, and computing alpha to the power xy from the alpha to the power x is open, alpha to the power y is open, and computing alpha to the power xy from alpha to the power x and alpha to the power y is known as a computational Diffie-Hellman problem. We have a alpha to the, we are giving alpha to the power x and we are giving alpha to the power y. But if we can solve discrete log problem, then we can get x or we can get y. Then we can easily compute alpha to the power xy. So from the discrete log problem, we have derived the computational Diffie-Hellman problem. Okay, so now we come to the public key encryption scheme. So public key encryption scheme consists of 4 algorithms, that is setup, key generation algorithm, encryption and decryption algorithm. So just we discussed the RSA crypto RSA schemes, RSA crypto system. So what is RSA crypto system? So in RSA, first task is to select the n. So n is basically large. So suppose we want to achieve 1 to the power 28 securities, 1 to 2 to the power 128 security, then we have to choose n very large. That is size of n should be 3072. That means this approximately n should be approximately equal to 2 to the power 3072. Okay, so for example, suppose we want to work in like 1024 bit, 1024 ports. So n is 1024 bit. So what here we have to choose the large prime P and Q, okay, with the approximately same size, and then we compute the product of P and Q n, okay. And then next we have to choose large integer e is chosen such that it is relatively prime to phi n. Phi n is basically Euler function, and when value of phi n will be product of p minus 1 into q minus 1. Okay. Next, we have to select d in a such way that e dot d is congruent to 1 mod phi n here. So n and e is publicly known, and P, Q, and D are kept secret, and D is a private key. Clear? So what parameter given n, which is large integer and product of 2 prime PQ and public key E, and PQD are kept private. And suppose A want to send a message to B. So we select message M in the integer interval 0 to n minus 1 and compute M to the power E mod n. Okay. So now send the ciphertext C to B. Okay. Here to decode the message N, what that receiver will do, simply receiver will compute C to the power D. So C to the power D is nothing but M to the power ED, and ED is nothing but 1 mod phi n. Okay. So here what we will get back, ED is nothing but 1 mod phi n. So what we will get is M. So we can recover M easily. Now we can see that here is, if we know the factorization, then what we can do here is, if we know the factorization P and Q, so what we can do, if we know the P and Q, then we can compute phi n. Okay, and we can compute phi n. So given a E and given a phi n, then nothing D will be the inverse of E mod phi n. But since factor is not known, so we can't compute phi n. That is why this RSA is based on the integer factorization problem. Okay, this is the simple example of integer factorization problem. I will share the slide, you can see. Now we compute the RSA signature scheme. In signature scheme, we use the public key for signature, and for the verification, we use the corresponding private key. Okay. So suppose we want to sign a message M. So what things we have to use? We have to use one hash function, and then public key is N and E, and private key is D. So suppose we want to sign a message, we compute the hash we know hash function to reduce the size, and then we use the private key D and mod n to verify the signature, because this is publicly verified. E is publicly known. So if we want to verify the signatures, we use the public key of a person that has signed the document. We will compute S to the power E. Clear? S to the power E is nothing but HM to the D into E, and D into E is congruent to 1 mod phi n. So finally we will get back to HM. Okay, so now since we are verified whether this M equal to HM or not, so if the same, then we accept the signature, otherwise we reject the signature. Now we come to the illegal crypto system. Illegal crypto system is based on discrete log problem. Okay, so based on discrete log problem, and here what is a public key? So suppose ZP is a group. That P is large prime, so ZP star will be a group, cyclic group, and then select alpha, generator of that group, and select a random number A, random integer A. So alpha to the power A mod P, will be a public key. Will be a public key, yes, and A will be a private key. And what is public parameter? P is given, P and alpha is known to everyone. Okay, so beta is public key and private key is A. So now we want to send this we want to encrypt the message. So what we have to do first is, public information is given. We know public key and public parameter P and alpha. Alpha is generator and P is large prime. Okay, so now he represent the message M as integer in ZP. He chooses random integer K, and what he has to do, he compute two parameters C1 and C2. C1 is nothing alpha to the power K, and C2 is nothing M into beta to the power K. Beta 2 is public key and M is message. To recover this message, what this receiver has to do, simply here is, you can say C1 to the power A inverse into C2. So what is C1 is? C1 is alpha to the power K, and C1 is alpha to the power K. C1 A to the power is nothing but alpha to the power Ka. So alpha to the power, and then we are taking inverse. So alpha to the power minus Ka. Okay. And C2 is nothing but beta to the power K. And what is beta? Beta is alpha to the power A. So that will be alpha to the power AK. And it will be inverse of alpha to the power AK. So this will be cancelled out. Finally, we will get back to M. So again, this is basically securities lie on the discrete log problem. Now, this is the example of discrete log problem. Similarly, we have a digital signature based on the discrete log problem. We have a digital signature algorithm. Okay. Just like RSA factoring challenge is there, that you can refer the website I have mentioned here. What is the current status of factor? So recently in 2020, RSA this 829 bit has been factored. Okay, this is the current record of RSA 250. Now we come to the basic of elliptical. Okay, so as we can see, as we have seen earlier, like integer factorization problem, then discrete log problem, discrete log problem ZP star natural group. Similarly, we can define in case of elliptical, we can also define a group structure. So we can see here is a standard form of elliptical with y square equal to x cube plus ax plus b. Okay, and if you design over the characteristic zero means if you are drawing this elliptical over rational or over real number or complex number, so it will look like this format. Okay, so this is the most general form of elliptical. And elliptical, that is y square equal to a1xy plus a3y equal to x cube plus a2x square plus a4x plus a6. This is the most general form of elliptical. Okay, so what is advantage of elliptical? Set of points on elliptical forms a group structure. So set of forms a elliptical forms a group structure. Okay. Here we have defined, like if the constant A1, A2, A6 belongs to the constant belongs to either field K or its algebraic closure. This is slightly higher mathematics we are using. So, and if constant belongs to K, field K, then we write elliptic curve over K, and E bracket K is a K rational point on elliptic curve with a point of infinity. Okay, so here we can define a K rational point of elliptic curve, that is a set of points on elliptic curve where the constant belongs to and this base field K, okay, together with the point of infinity, and then the set of points on curve together with the point of infinity, and the constant are element of K. Generally, constant may be the element of K, or this solution may be the element of K, or solution may be the element of higher field K. But when we are writing AK, that is we know as K rational point. So K rational points, if this curve is non-singular, then K rational point on elliptic curve forms a group. So to define the non-singularity, that discrement of this elliptic curve should be non-zero, or equivalent condition is given here. Okay. So what we have seen here is set of points on elliptic curve forms a elliptic curve, that is elliptic curve of the non-singular curve of the form this forms a group with respect to elliptic curve point addition. So we can define a point addition as given by this formula. Okay, so to understand this formula, like if we have a P and Q, then P plus Q given by X3, where X3 equal to this, Y3 equal to this. Okay, so you can understand from the graph easily. P and if we want to add to point PQ, then simply we draw the straight line. Since elliptic curve is cubic and the line of equation is 1 degree, so definitely it will intersect the third point, and then we take the reflection. So this is P plus Q point. Similarly, we can find out the double of point P, then identity how this identity is working and inverse is working. So we can say that from this graphs that all the group properties, all the properties of groups are being satisfied, and that is why this set of point on elliptic curves together with the point of infinity forms a group. Since it forms a group, so we can, with respect to the point addition as defined here, x3 equal to itne and y3 equal to itne. Since it forms a group, so we can define a elliptic curve discrete log problem. But for the cryptographic application, we have to use the elliptic curve over a finite field. And if we are working on finite field, the number of points on elliptic curve is also finite, and then it can be counted, and it can be counted how many points are there, and Hess's theorem gives the bound of number of points on elliptic curve. Okay. So, and these are the simpler form of elliptic curve, that is field of characteristic 2, field of characteristic 3. So, but if we draw the graph over the finite field, then number of points are finite. It look like this here. And it looks like that set of points. Okay, and you can verify this points, all points, and this forms a group. Okay, as I have said that we can define a discrete log problems and elliptic curve with respect to the elliptic curve point addition. So how we will define? Similarly, that it can be defined similar to the discrete log problem and natural group that we have discussed earlier. Okay, so what here, suppose P and Q are point of elliptic curve over a finite field FQ, and Q is element of subgroup of elliptic curve generated by P, and we have given some Q and P, and we have to find M. M is here is scalar multiplication. That is P plus P plus P M times. So it is elliptic curve discrete log problem, known as elliptic curve problem, discrete log problem. It is computational hard, and complexity of discrete log problem is exponential. Okay, so if field size is n, then complexity of elliptic curve discrete log problem is proportional to 2 to the power n by 2. So that is why, like, we can define a computational hard problem here, and based on the computational hard problems, many elliptic curve based crypto system scheme have been proposed. It's a signature scheme, public key scheme, and key agreement protocols. Okay, so this is the elegable elliptic curve crypto system. Very simple example we have given how it's work. This is just analogous to the elegable crypto system based on natural group that I have discussed earlier. You can see the key size comparison with respect to elliptic curve and discrete log problem with RSA. So if we want to achieve the 2 to the power 80 security, then we have to choose the parameter here. In case of elliptic curve, we have to take the elliptic curve finite field size to 160. However, in RSA and discrete log problem, we have to take the large integer of size 1024 to achieve 128, 256 finite field size, and then case of RSA, we have to work on 3072. Okay. So that is why since we are working on the small finite field, so in elliptic curve, so it gives the faster implementation, low power consumption area, less con area, and therefore it can be implemented in the smaller multiprocessor, small device. Okay, and small device, like, and can be implemented it's microprocessor, 8-bit, 16-bit, 32-bit microprocessor. Okay, some challenges are there based on the elliptic curve cryptography. Certicom sites, people can refer the Certicom sites. World record on elliptic curve cryptography is presently we have 12 elliptic curve cryptography with the field size 113. Okay, on FPGA cluster. So now we come to the post-quantum cryptography, especially with respect to the public key cryptography, post-quantum public key cryptography. So if the quantum computer are available, then what will happen? Then we have a Shor algorithm that runs in polynomial time to solve integer factorization problem, discrete log problem, natural and algebraic groups. So once we have this quantum computer, that means we will have a polynomial time algorithm for solving integer factorization problem and discrete log problem. Okay. So that means like RSA, DLP, ECDLP based crypto system, that all these system will be there. Okay, so now the cryptography that will resistant to attack the quantum computer is known as a post-quantum cryptography. NIST announces the post-quantum cryptography standardization, and third round they have announced some third round some systems, announced some system in third rounds. Okay, so some public post-quantum cryptography that is available. So lattice-based crypto systems are there, and then NTRO is the lattice-based systems, which is based on the lattice-based computational hard problem known as a Salter vector problems, Salter and Coolidge vector problem. Similarly, we have a system of we have a public key cryptography based on the multivariate polynomial over finite field. So again, that's solving multivariate polynomial over finite field is a difficult problem. It is computational hard problem, NP hard problem, and some like hidden field equation based problem, S plus square. These are the system based on multivariate problems. Based on multivariate problems. Here we have discussed just RHA and discrete log problem, but they are then again the decoding problems. Decoding problems like GAPA bounded decoding problem, GAPA code distinguished problem. These are the computational hard problem that can be used to design the public key crypto system. These are the again computational hard problem, and these problems will survive even the quantum computers are available. Okay. So some problems like Macaulay crypto system, Netherite crypto system, these are the based on decoding problem. Okay. Then now that we have a isogeny-based cryptography, isogeny-based computational isogeny problem is also computational hard problems. Okay. So some protocols like SIG, SETA, and then for the encryption algorithm, C-SIGN, these are the for signature algorithm. These protocol, and then they said submitted to NIST as a SIG. These are the protocols and encryption and signature schemes which are being have been proposed based on the computational isogeny problem. Some post-quantum candidates that they have finalized in the round three. Okay. Next, we come to the another important part of the public key cryptography, that is identity-based cryptography. Conventional, what is the problem in conventional public key cryptography? Conventional cryptography is dependent on the public key infrastructure, as I discussed. The most drawback in public key infrastructure, public key is basically we need the public key infrastructure. Public key address authentication of public key problem. So what is the like problem in here is we have to rely on the certificate trust party trusted by all users, called certification authority. So that means we are relying on certifying authority, and the certifying authority has to generate the signature signed certification, contain public key of user along with identity. Okay, so this is the most problem. Like to decide whether this public key is correct or not, the certifying authority play the role, and the certifying authority issue a certificate with the public key that this is the public key of that user. So it is PK-based cryptography, both time-consuming as error-prone. So in 1984, Samir introduced concept of identity-based cryptography. It uses user identity such as email address, phone number instead of digital certificates. Okay. And more precisely, the public key user is derived from directly from publicly available information. So that means like we can easily derive the public key from the public information. In that case, we have a very few of certifying agencies. And practical realization of identity-based public key cryptography comes from pairing. Pairing, we use the elliptical. Pairing, we use elliptical. In fact, in the 2001, Dan Won and Franklin proposed the first time identity-based encryption scheme using bilinear pairing. Bilinear Diffie-Hellman problem is bilinear pairing is based on the computational hard problem. This Dan and Franklin scheme is based on the bilinear Diffie-Hellman problem. Okay, but although like we have sorted out some problem, still although they provide some advantage of public key approach, it still is not built on the drawback of key screw problem. So I have not discussed a lot of terminology here, but due to the time limitation. So therefore, then again, the certificate-less cryptography have been introduced. Certificate-less cryptography have been introduced. Okay, so most of the time we are using the concept of elliptical pairing for the design identity-based cryptography and pairing. So now we have almost covered this concept of public key cryptography. For the implementation of public key cryptography, we can follow some important tools which are available open source. Like SAGE is very important library. It is available open domain. Pari, GP Pari is important library, Crypto OpenSL, cryptographic library, GEF library, NTL, Miracle, and JNUMP. These are the library available open domain. And then other many libraries are proprietary library are also there. So people can use these library to implement the public key crypto system. Now there are some differences. We can follow these references for further study. Thanks. If any question, hello, hello, hello.
Hello, sir. Hello.
Yeah.
Thank you so much. If audience have some questions on public key cryptography and the details, India would be very happy to answer. So any questions from the audience online connected? Meantime, Dr. Indivar, it was a wonderful presentation. We were exposed to various complex mathematical terminologies and the elliptic curve cryptography details. In short, in detail, we have in the afternoon, I think Dr. R. Balasubramaniam will be presenting the lecture on elliptic curve cryptography. So it is an eye-opener to the researchers, those who are intended to pursue their research in the area of public key cryptography. I learned that even though Dr. Indivar is with DRDO, in weekends he is guiding PhDs. That means he is a academician, serious academician, because he was connecting to me in the weekends and he was telling me that I was with my PhD students, so I could not pick your phone. So that shows that Dr. Indivar is a very serious academician in the area of public key cryptography. So I use this platform to thank Dr. Indivar for presenting a lecture, and he loves NWC. Personally, he helps me to organize NWC with the DRDO. We know that this NWC is sponsored by DRDO. For that, Dr. Indivar helped very much, actually. Thank you so much for helping us to organize this premier event. And definitely it will be helpful in one or the other way to our audience, because we could listen such a standard lecture in a common platform. So thank you so much, Indivar. Very nice of you. Thank you to see you online. Let us hope to have such occasions. At least let us have physical interactions in future if there is no harmful pandemic in future. Thank you so much.
Thank you. Thanks for giving this opportunity.
Thank you, sir. Thank you so much. Dr. Indivar, please join at 4 p.m. We'll be having valedictory. If you are free, please join at 4 p.m.
Okay, okay.
Thank you so much.
Thank you.
Audience connected online, we will be sharp joining back at 2 p.m. For a lecture by Dr. R. Balasubramaniam, and followed by a lecture by an young researcher, Dr. Gurraj HL, on the roles of AI on cybersecurity. Sir, good afternoon. Sir, good afternoon. Am I audible? Come on. Sir, am I audible? Balasubramaniam, sir?
Yeah, 1 minute, 1 minute.
Yeah.
Oh, 1 minute, I have to.
Yeah.
Yeah. No, am I audible? Yes. Okay.
Yes. Yes, sir. You are very much audible. Your screen is also visible.
Okay, very good.
Yeah. We shall start in another 2 or 3 minutes.
Yeah. Now the screen is visible.
Yeah, screen is visible. Your voice is also perfectly okay.
Okay.
Sir, thank you for joining.
Sure,
Very
of
nice
course.
very nice to see you online.
And Indivir has already given something about the elliptic curves.
Endeavor has given something. Yeah. We shall start in another 1 or 2 minutes.
Yeah, sure, no problem. I mean, I just see that
Everything.
audience are entering.
Yes, everything is fine.
Yeah. We are all the audience sitting in the last row. They can even come to the first row.
Sir, again, good afternoon. Shall we start, sir?
Yeah, sure.
Yeah, good afternoon, everybody. Joined online and offline. So we have an eminent mathematician, Dr. R. Balasubramanian, was the former director of Institute of Mathematical Sciences and an expert in the area of elliptic curves. And now he is going to present the talk on elliptic curves for finite fields. I request Dr. Pramod Kumar to introduce Dr. R. Balasubramanian.
Thank you, sir. I'm glad to invite Dr. R. Balasubramanian, President CRSI. He works in the area of analytic number theory. He is also interested in mathematical questions on cryptography, functions of a single complex variable, and combinatorics. He is a fellow of Indian Academy of Science, Bangalore, Indian National Science Academy, New Delhi, and National Academy of Science, Allahabad. He is the recipient of Young Scientist Award from Indian National Science Academy, Young Associate of Indian Academy of Science, B.M. Birla Award, S.S. Bhatnagar Award, Srinivasan Ramanujan Bhatt Centenary Award of Indian Science Congress, and similar award by French government. Lifetime Achievement Award for Department of Atomic Energy and Padma Shri Award from Government of India. He is the president of Cryptology Research Society of India. I am Dr. Pramod Kumar S, Department Electronics and Communication, JNNCE. Behalf of NWC 2021, welcome you, sir.
Thank you.
So over to you.
Sure.
Thank you, sir.
Good. I wish I could be, first of all, good afternoon. Let me thank the organizers for this opportunity to talk to you, even though online. I wish I could have been physically present. One of the problems in the offline lectures, online lectures, is that you do not really know which level to pitch your lectures. Whether you are going a little too fast or too advanced, or you are talking about too elementary, and so on and so forth. Therefore, I am assuming, now that you are attending all this national workshop on cryptology, that you know what the cryptology means, what this symmetric key, asymmetric key, encryption, decryption, etc. What do they mean? I am assuming you know all of those. And probably there were also lectures. At least today, I think there was this lecture by Saxena, where he explained about the encryptions and what are the pitfalls, what are the things which you have to be careful against. And Indira Gupta gave a detailed lecture on encryption, where it is used like in WhatsApp and so on and so forth. And therefore, my assumption, therefore, is that you know what cryptology means, and that's not what you are expecting from me. But on the other hand, you see that there's an elliptic curve coming in cryptology, and you would like to know what is the mathematics behind the elliptic curves. Why are they using the elliptic curves? What is the mathematics behind it? Is what probably I expect you would expect from me. And that's exactly what I am going to do. On the other hand, if I am going a little too slow, or if I am going a little too fast, you can stop me at any stage, and then I will try to explain to you more. Okay, what's an elliptic curve over finite fields? First of all, what are the finite fields we are going to look at? Let P be a prime, and for technical convenience, I will assume the P is different from 2 and 3. And Fp is a finite field of P elements, which is something which all of you would have known, how the finite field of P elements look like. And let K be a finite or an infinite extension of Fp. What does it mean? This K is another field, and this field contains Fp. And if this K is another field which contains Fp, K can also be viewed as a vector space over Fp. And then you can talk of the dimension of the vector space K over Fp. And when you say it is a finite extension, then the dimension is finite. When you say it's an infinite extension, the dimension is infinite. And now what's an elliptic curve? An elliptic curve is a smooth projective algebraic curve of genus 1 with a specified point O. I'm not sure how many of you would have understood any of these words. But anyway, I have to define an elliptic curve, therefore I have defined it, and I am not going to use all of these things. But for our purpose, an elliptic curve is given by an equation y square equal to x cubed plus ax plus b. And any elliptic curve is given by this certain equation like y square equal to x cubed plus ax plus b is true only if p is different from 2 and 3. Okay, that's exactly the reason why I assumed P is different from 2 and 3, where A and B belongs to FP, that is a finite field. And now I also use the word that this elliptic curve is a smooth curve. And smooth curve means that the 4A cubed plus 27B square should be different from 0, which is the same. This 4A cubed plus 27B square is called the discriminant of the cubic. And this is what in the morning endeavor was also trying to explain, that you have to assume that the discriminant should be different from 0. And that is what the smooth means. And now you need another, I said that you need a specified point O. The specified point O is always taken to be infinity, infinity. When x is equal to infinity, you see y becomes infinity. And that point, infinity, infinity is the specified point. This is all what an elliptic curve is. There is a curve which is y square equal to x cubed plus ax plus b, with the conditions that 4a cubed plus 27b square is different from 0, and a specified point O which is infinity, infinity. Actually, we would be many times interested in elliptic curves over complex numbers. Probably when you do cryptology, you may not be. But in number theories, we are interested in elliptic curves over complex numbers. In cryptology, you would be interested in elliptic curves over finite fields. And we are also interested in elliptic curves over Q rationals, but normally nobody is very much interested in elliptic curves over R. But I will just still draw the elliptic curve over the real line simply because that is the only place where one can draw the graph. You can't so easily draw a graph over complex numbers or finite fields or something like that. Only over real line you can draw it, and then the elliptic curve will look like that. Therefore, it will be either two parts, and one part will be bounded on the left, and the second part will be unbounded, or there will be one continuous curve, depending upon whether this cubic has a 3 real roots or 1 real root. All of you would have known that a cubic equation has either 1 real root or 3 real roots, depending upon that. The important point, which is again what Gupta was explaining in the morning, the points of this elliptic curve form an additive group. Okay, this is an important point, and therefore we have a group, and that group is what is very important for us. And how do you do this additive group? This additive group is done by the so-called tangent chord process. What does it mean? This means the following. When you have a group, that means you should know what is the identity, how to add 2 points, what is the inverse of the any given element of the group. That's all what you want to know. And therefore, that's what I'm going to explain now. This is a special point, infinity, infinity, that is going to be the identity of the group. And if you take a point P, which is x, y, then the inverse of P, which is minus P, is x, minus y. Remember, your equation is y square equal to x cubed plus ax plus b. And therefore, if a point xy lies on the curve, then the point x, minus y also lies on the curve, because y comes with a even exponent y square. And therefore, if xy lies on the curve, x, minus y lies on the curve, and that is considered to be the inverse. And if P, which is x1, y1, and P2, which is x2, y2, are 2 points with x1 different from x2, if I take 2 points, P1 and P2, whose x coordinates are different, then how do I add the 2 points? I choose the line L, joining the points P1 and P2. Therefore, I take the line L, joining the points P1 and P2, and that it meets the curve at a third point Q, and I take the inverse of Q. Therefore, if Q were xy, I take the point x, minus y, and then I define that minus Q to be my P3, and then P1 plus P2 equal to P3. This is how the addition is defined. Therefore, whenever you want to add 2 points, you take the 2 points, take the straight line in joining them, and see where it meets the third point and in the curve, and then take the reflection of the third point on the x-axis. And if you do that, what you get is a point P3, and that point P3 is by definition the sum of P1 and P2. Now I'll write it as a formula, okay? And then probably I will explain where the formula comes from. You define your M to be y2 minus y1 by x2 minus x1, because you are given the points x1, y1, x2, y2. Once x1, y1 and x2, y2 are given, define M to be y2 minus y1 by x2 minus x1, and define your x3 to be m square minus x1 minus x2, and define your y3 to be mx1 minus mx3 minus y1. Then the point x1, y1 plus x2, y2 adds up to x3, y3. Now let me repeat what I am trying to say, that you define, once you are given x1, y1 and x2, y2, you define your m, then you define your x3, you define your y3, and then they add the point equal to x3, y3. Now you will be probably wondering how this really translates to what I said earlier. I said earlier that you take the 2 points, take the straight line and joining them, see where it meets the curve in the third point, and take the reflection of the third point, and that is a sum. That's what exactly I defined. And how does this formula come? Okay, let's do that first. Where does the formula come from? Therefore, let P be by 1 point x1, y1, Q is another point x2, y2. These are the 2 points. And L is the line joining P and Q. I take the 2 things. And it meets a curve at the point which I call x3 minus y3, because when I reflect it, then I will get x3 comma y3. Its reflection gives x3, y3, and that's exactly what I defined to be the sum. Therefore, the sum of P, the point P, and the point Q is the point R, which is obtained by taking the line joining P and Q and see where it meets the curve and taking the reflection. Okay, now, but I wrote some formulae, x3 is equal to m square minus x1 minus x2, etc. And you would like to know where this formula comes from. Okay, first I have to take the line joining P and Q. And you know that the equation of any straight line will look like a y equal to mx plus c, where m is the slope of the straight line. And you know, when you join the points x1, y1 and x2, y2, then the slope of the straight line is given by the formula y2 minus y1 by x2 minus x1. That is the m. That is the slope of the straight line in joining x1, y1 and x2, y2, which is given by m, which is y2 minus y1 by x2 minus x1. Also, the point P lies on the straight line. Since the point lies on the straight line, therefore the coordinates x1, y1 should satisfy the equation of the straight line, which means that your C has to be y1 minus mx. Now I have to see what is the third point of intersection. Therefore, I have one straight line, y equal to mx plus c, and I have this curve, y square equal to x cube plus ax plus b, and I want to know where this straight line meets the curve. We have to see the third point of intersection, we have to solve these 2 equations. The elliptic equation, which is y square equal to x cube plus ax plus b, and the straight line equation, which is y is equal to mx plus c. And therefore, how do we solve the equation? And since y is equal to mx plus c, put that value in the first y square. Therefore, you get mx plus c whole square equal to x cube plus ax plus b, which means x cube minus m square x square plus a minus 2mc times x plus b minus c square equal to 0. Now, this is a cubic equation. This means that there are 3 x coordinates of the point of intersection of the straight line and the curve. And the 3 x coordinates, which are the points of intersection of the straight line and the curve, is given by this cubic equation. But you know already 2 x coordinates. x1, y1 lies on the straight line and the curve, and therefore x1 is a root. x2, y2 lies on the straight line and the curve. Therefore, x2 is also a root. Therefore, you have a cubic equation where you know two of the roots. And if you are given a cubic equation where you know two roots, then it is not difficult to find out the third root. And in fact, there is a formula that whenever you have a cubic equation like that, and the sum of the roots is minus the second coefficient by the first coefficient. This is one of the standard formula which all of you may have read, that if you have three roots of this equation, the sum of the roots is minus the second coefficient by the first coefficient, which is m square in this case. That gives you already x3 equal to m square minus x1 minus x2. And now the point x3 minus y3 lies on the line, which means that minus y3 has to be mx3 plus c, which is, but c I have already known to be y1 minus mx1. Therefore, minus y3 happens to be mx3 plus y1 minus mx1, which is the same as saying that y3 is equal to mx1 minus mx3 minus y1. And that's precisely the formula which I wrote, namely x3 is equal to m square minus x1 minus x2, and y3 is equal to mx1 minus mx3 minus y1. Therefore, it is not necessary for you to now draw the line and do anything like that. Once you have the step parts to P1 and P2 given, then you just write your m, which is y2 minus y1 by x2 minus x1, write the x3, write the y3, and then you have the solved equation. Therefore, this is the chord. You are taking a chord PQ and see where the PQ meets. Suppose you want to add the point to itself, namely x1, suppose x1 equal to x2 and y1 equal to y2. Then, of course, you don't have a chord. You have the same point P1 and the same point P1 again, and then you want to add it. And then you do the obvious things. Instead of taking the chord, you take the tangent at the point. Okay. And when you decide to take the tangent at the point, the earlier argument will work, except now you have to find out the slope. And in your calculus class, you would have known how to find out the slope of a tangent.
4 o'clock.
Sorry? Slope of the tangent at a given point, and the slope is given by 3x1 square plus a divided by 2y1. Therefore, you know m, which is 3x1 square plus a by 2y1, and the rest of the formula holds. On the other hand, if x1 equal to x2 and y1 equal to minus y2, they are the inverses of each other. Since they are the inverses of each other, when you add them, you will get identity. But identity is by definition infinity. Therefore, this actually forms a group. And it is not so easy to prove that it forms a group, particularly in trying to prove the associative law, P plus Q plus R equal to P plus Q plus R. You will get into a lot of troubles. But anyway, take it from me that it really forms a group. And that is a group which you want to study. And before I go to the next one, I would probably try to give some examples on a finite field. Okay. Therefore, let me take some examples. Okay, let's take P equal to 5, and I take the field which is F5. F5 is a field of 5 elements. And you know what are the elements? 0, 1, 2, 3, and 4. And now I take an elliptic curve which is y square equal to x cubed plus x plus 2. Therefore, that is the elliptic curve which I am taking. And I want to know what are the points of this elliptic curve. Therefore, I want to know what are the points of this elliptic curve y square equal to x cubed plus x plus 2 over the field F5. Okay, let's try to do that. You have to put some value of x, compute the value of y, and write that, and keep on doing that. Therefore, you write one value of x and compute the corresponding value for y, write it, and keep on doing that, and you should get all the curve. And that is not too difficult because x has only 5 choices. X has to be in the field F5. If x has to be in the field F5, x can be whether 0 or 1 or 2 or 3 or 4. And x does not have too many choices. Now let's talk to the x equal to 0. When x is equal to 0 and you substitute x is equal to 0 in the equation, y square equal to x cubed plus x plus 2, then it comes y square equal to 2. But now what is the value of y in F5 such that y square equal to 2? Okay. And you find that there's really no value of y for which y square equal to 2. because when you take y equal to 0, 0 square is not 2. When you take y equal to 1, 1 square is not 2. 2 square is not 2. 3 square is not 2. 4 square is also not 2. And therefore, there is no value of y corresponding to x equal to 0. Now you take x equal to 1. When you take x is equal to 1, then x cubed plus x plus 2 becomes 4. And therefore, you have to solve the equation y square equal to 4. And what are the values of y such as y square equal to 4? Y is equal to 2 gives you y square equal to 4. And y is equal to 3 also gives you y square equal to 4. Because when you take y equal to 3, then y square equal to 9. And the 9 is the same as 4 in the field F5. And similarly, when you put x is equal to 2, then you get again y square equal to 12, which is the same as 2, and y square equal to 2 has no solution. And when you put x is equal to 3, then again you get y is equal to 2, y square equal to 2, and there has no solution. And when you put x is equal to 4, then x cubed plus x plus 2 happens to be 70, and 70 is equal to 0 in that field, and therefore you get 4, 0. And therefore the points of this elliptic curve over this finite field is precisely the infinity, which is the identity of the things 1, 2, 1, 3, and 4, 0. Therefore, there are exactly 4 points in this elliptic curve. Therefore, the number of points of this elliptic curve, y square equal to x cubed plus x plus 2 over F5 is exactly equal to 4. We'll take one more example. Y square equal to x cubed plus 4x. And we will do the same thing. There is one point which is infinity, infinity. And when you put x is equal to 0, then y square equal to 0, therefore 0, 0 is another point. And when you put x is equal to 1, then y square equal to 5, but 5 is the same as 0, and therefore y again becomes 0. And when you put x is equal to 2, then you get 16, y square equal to 16. 16 is the same as 1, and therefore y square equal to 1 is what you have to solve, and y square equal to 1 has two solutions. 1 is a solution, and 4 is also a solution. Therefore, you get a 2, 1 and a 2, 4. And similarly, you can do when you put x is equal to 3, then you will get two solutions for y, which is 2 and 3. And when you put x equal to 4, then you will be having one solution. And therefore, you see that there are exactly 8 points on this curve. Therefore, we had one example of an elliptic curve over F5, which had 4 points. We have another example where there's an elliptic curve over F5 again, which has 8 points. Therefore, the question naturally you would like to know is, suppose I am given an elliptic curve over FP, how many points it will have? That is the question which we want to discuss next. The order of U over FP. What is the order? How many points are there? You see, again in FP, probably most of you would have read something called quadratic residues and quadratic non-residues, and which means that over FP, there are P minus 1 over 2 squares and P minus 1 over 2 non-squares. Therefore, nearly half the elements are really squares and nearly half the elements are not squares. Therefore, the probability of an element in FP bar being a square is half. Therefore, because exactly out of the P minus 1 non-zero elements, exactly half of them are squares and exactly half of them are non-squares. Therefore, one may expect that for a given x, the probability that x cubed plus ax plus b is a square is close to half. Therefore, for every x, the probability that x cubed plus ax plus b is a square is close to half. And then if that is close to half, then there will be corresponding two values of y, because y is plus or minus, which is what we saw. And therefore, half the value of x only will occur. And for half the value of x, every time you will get two values of y. And totally, therefore, you would expect that the number of points should be around p. Okay. And that statement, that the number of points is around p, is almost correct. And that is a theorem due to Hasse-Weil. It was proved by Hasse for this special case, and then Weil generalized it to real lot of generalization. And therefore, the theorem says that if you take an elliptic curve E over FP, and then count the number of points of that elliptic curve over Fp, then the number of points is close to p plus 1 with an error which is at most 2 times the square root of p. See, you cannot expect an exact formula. You cannot expect an exact formula because we already saw 2 examples. In one example, an elliptic curve over Fi had 4 points, and another example, an elliptic curve over Fi had 8 points, and therefore you cannot write that an elliptic curve over Fp will have exactly these many points. But roughly you can say that an elliptic curve over Fp has around p plus 1 points. Okay. Therefore, you know the group, you know how to add the 2 elements, how to make it as a group, and you even know the order of the group. Okay, not exactly, but almost the order of the group. The order of the group is p plus 1 because E over Fp by p minus p plus 1 is at most 2 times the square root of p. Now, the next question which I would like to know is what is the structure of the group? What sort of group is that? How will the group look like? Clearly, E over Fp is an abelian group. Whether you add P with the Q or Q with the P, it doesn't really matter. You are going to do the same thing. You are going to take the line joining P and Q, see where it meets the third point and going to get the reflection. And therefore, P plus Q is the same as Q plus P. And probably again, all of you would have studied something called the structure theory of abelian groups. And the structure theory of abelian groups says that any abelian group can be written as a direct sum of cyclic groups like that Zn1, that Zn1 means a cyclic group of order n1, direct sum cyclic group of order n2, direct sum, etc., cyclic group of order nr, where you can choose your n1, n2, nr in such a way that this n1 divides n2 and n2 divides n3, n3 divides nr. And this R is called the rank of the group. Therefore, when you have an abelian group, then the structure theorem of abelian group tells you that you can write it as a direct sum of cyclic groups in such a way that the order of the first group will divide the order of the second group, the order of the second group will divide the order of the third group, and so on and so forth. And that number is called the rank. And now there's a theorem which says that for an elliptic curve is an abelian group with a rank 2. There will be only 2 copies, not more than that. The first copy will be something like a Z over AZ, and the second copy will be Z over BZ, and then this A will divide B, because that is what the structure theorem says, and something more, A will divide P minus 1. Okay, this is very important. Okay, and therefore what happens is normally the A would be very small because A has to have many constraints. A has to divide B and A has to divide P minus 1. Since A has many constraints, therefore A will be 1, 2, or 3, 5, some such a small number. And therefore, if that part you omit, then you will have a Z over PZ. And Z over BZ is a cyclic group, which essentially means an elliptic curve is with a small cofactor, a cyclic group. And you know the order of the cyclic group, is P plus 1. And now let me continue with the examples. Therefore, the first example I gave, which is y squared equal to x cube plus x plus 2, and we found that there are 4 points, and that's exactly what the Haseveil theorem will say, that the number of points minus p plus 1 has to be less than 2 times square root of p, and that really happened. 4 minus 5 plus 1 will be less than or equal to 2 times the square root of 5. And I had a second example, y square equal to x cube plus 4x. And that example, we had 8 points, and the same thing is again 2. Okay, have we written that? Yes. 8 minus 5 plus 1 is less than 2 times the square root of 5. And I will give you third example, y square equal to x cube plus 4x plus 1. In this case, again, I have 8 points. And the 8 points, you can easily write again. You put x equal to 0, for example, and then you get y square equal to 1, and therefore y has to be either 1 or 4, and so on and so forth. And therefore, you can write all your 8 points. And again, the same thing, 8 minus 5 plus 1 will be less than 2 times square root of 5. But the next question which you ask is, okay, I have a cycle group of order. What do you need that? Yeah, I have a cycle group, and now what I want really is, how does a group look like? Yeah, well, how does a group look like? For example, in this case, I will claim that this is a cyclic group generated by P1, which means that I know how to add the 2 points, and let's see how to do it. First of all, let's see how to add the P1 and P1. And I know already the formula, how to add 2 points. I have to choose the M, which is 3x squared plus 4 by 2y, and therefore that gives you M equal to 2, and therefore the equation will look like y is equal to 2x plus c, because that's what it is. Suddenly it's not moving. Oh, okay. Okay, that's a mistake within it. Okay. Therefore, the first equation I'm not okay. Take an example 2, and I want to know how the curve looks like. Therefore, I have 8 points. The 8 points are P0, P1, P2, P3, P4, P5, P6, and P7. And infinity is a point of order 1. And there are 3 points of order 2, P1, P2, and P7. Where they are points of order 2, look at P1. And what is this reflection? Reflection is the same as P1. The reflection of x comma y is nothing but x comma minus y. And therefore, the reflection of 0 comma 0 is the same as 0 comma 0. Therefore, you remember, when the second coordinate is 0, then the reflection will be the same. And since the second coordinate is 0, the reflection is the same. Therefore, the reflection of P1 is the same as P1, which means that P1 is the same as minus P1, which means 2P1 equal to 0. Therefore, P1 is of order 2. And P2 is also order 2 because it is 0. And P7 is of order 2 because the second coordinate is 0. And now I want to know what is P3. Therefore, I want to add P3 and P3. And let me explain how to do the P3 and P3. Therefore, we have to first of all compute the M. M is 3x squared plus a divided by 2y. And a in this case is 4. And y is in this case is 1. Therefore, you get 3 times 2 square plus 4 divided by 2. And that is exactly equal to 3. And therefore, the tangent will look like y equal to 3x plus c. And in the point, since 2, 1 lies on the straight line, the tangent, and consequently c is equal to 0. And therefore, we know that the tangent at the point P3 is precisely y equal to mx. Therefore, I know the tangent y equal to mx, and I want to know where it meets the third point. And I have to only know of the y equal to mx, m equal to 3. I would like to know y equal to 3x, which is the other point which lies in y equal to 3x. And then when you do, where is the other point which lies in y is equal to 3x, then you see the point is, what I am claiming, 1, 0. Okay, and therefore P1 is equal, P1 plus P1 equal to P3 plus P3 is equal to P1. Because I have to take the reflection, but the reflection of 1, 0 is the same as 1, 0 again. And therefore P3 plus P3 equal to P1. Therefore, the order of P3 is 4. And we also check the order of P3, P4, P5, P6. Each one of them is exactly 4. Since the order of each of these elements equal to 4, there is no element of order 8. A group of order 8 cannot be a cyclic group. Since it cannot be a cyclic group, it has to be, and it has elements of order 4, and therefore this group has to look like Z2 cross Z4. And therefore this is a rank 2 group, and this looks like a Z2 cross Z4. On the other hand, when you look at the other curve, y square equal to x cube plus 4x plus 1 It has an 8 points, but this group I claim to be really a cyclic group of order 8. And in fact, I claim that it is generated by P1. Therefore, let's do the P1 plus P1, for example. In order to do the P1 plus P1, I have to find out the slope. The slope is 3x squared plus 4 by 2y. And P1 is 0, 1. Therefore, I should put x equal to 0 and y equal to 1. When you put x equal to 0, y equal to 1, then you get m is equal to 2. And therefore, the tangent is y equal to 2x plus c. But the point P1 lies on this tangent, and therefore c is equal to 1. And therefore, I know that the tangent is y equal to 2x plus 1. And I should know where it meets the curve. And what are the other points in the 2x plus 1? And you see 4, 4 is another point which is on the line y equal to 2x plus 1. Because when you take 2x, 2 times 4, which is 8, plus 1, 9, which is the same as the y coordinate. Therefore, you can just check that the point 4, 4 lies on this curve, and therefore P1 plus P1 equal to P6. Because 4, 4, you have to invert 4, 4. When you invert 4, 4, you will get 4, minus 4. But minus 4 is the same as 1, and therefore you get 4, 1, which is the point P6, which I have written. The point P, therefore you get P1 plus P1 equal to P6, and 3P1, what is 3P1? 3P1 is equal to P1 plus P6, because P6 is 2P1. Since P6 is 2P1, I want to know 3P1, which is P1 plus P6, and P1 plus P6 I have to add. And now there are two different points, two different x coordinates, and therefore I have to use the first formula. The first formula, remember, is P1 equal to 0, 1, P6 is 4, 1, and therefore the slope is given by y2 minus y1 divided by x2 minus x1, and y2 is equal to, that is 1 minus 1 divided by 4 minus 0, which is equal to 0. And therefore, that's now the chord. It's not the tangent, because I am adding two different points. P1 and P6 I am adding. Since I am adding P1 and P6, two different points, therefore it's a chord, and the chord is given by the equation y equal to c, and c is equal to 1. I have to see where it meets the curve. The curve meets at P3, and then I take the inverse of P3, which is P4, 3P1 equal to P4. Therefore, this is something which you can check now. 2P1 equal to P6, 3P1 equal to P4, 4P1 equal to P5, 5P1 equal to P3, 6P1 equal to P7, 7P1 equal to P2, and 8P1 equal to 0. 0, as you all know, is infinity, infinity. Infinity, infinity is a 0, which is the identity of the group. And therefore, what you have is that a cyclic group of order 8 generated by P1, and therefore now this elliptic curve is a cyclic group of order 8. Therefore, now you see already we have two groups, both of order 8, two examples. In one example, that group was Z2 cross Z4, and in another example, it is Z8 itself, the cyclic group itself. That's why FP we get now. Now I have to say why elliptic curve is very interesting for cryptology. Well, what do you do with this elliptic curve with cryptology? The reason is, normally, when you do the standard classical ones, you get the curve Z over PZ star. That's the only group which you have. Therefore, corresponding to every prime P, you have a group Z over PZ star. And if that is the multiplicative group modulo P. And if you look at this multiplicative group modulo P, and if that has some nice properties, you can use it for cryptology. But if it doesn't have nice properties, you cannot use it for cryptology. And then you have to look at another primes and another group and so on and so forth. But on the other hand, if you go for the elliptic curve, over FP, over the finite field of P elements, you have around P square curves. What you have to do? You choose any A and any B, where A belongs to FP, B belongs to FP, such that 4A cubed plus 27B square is different from 0. And in that case, the equation y square equal to x cubed plus ax plus b gives you a curve. Okay, and A can vary over P elements, B can vary over P elements. Okay, that is not exactly true. And B can vary over P minus 2 elements, because you have to ensure that 4A cubed plus 27B square is not equal to 0. But roughly speaking, we have P square elements, P square curves, and this practically the order covers the range p minus root p to p plus root p, in the sense that we know that the number of points of the curve is p plus 1 with an error which is at most 2 root p, which means that the order of the curve will lie between p plus 1 minus 2 root p to p plus 1 plus 2 root p. But at least in the middle, practically every element will be covered. Therefore, you have elliptic curves which are covering the whole range, which means around p square elliptic curves of any order you want between p minus root p to p plus root p. Therefore, you take any element between p minus root p to p plus root p, and you say that I want an elliptic curve of that order. You have an elliptic curve of that order. And therefore, there are lots and lots of elliptic curves for the one given prime p. Therefore, you fix one prime p, you have lots and lots of elliptic curves, and therefore that is cryptologically very, very important. And even if the order are the same, not only that you can say that my elliptic curve should have this order, but even then you can also stipulate whether it has to be a cyclic group or whether it's a non-cyclic group and so on and so forth. And that is the reason why the curves are very important in cryptology. And as I already told that I am not going to the cryptological aspect, I'm going to the mathematical aspects, and therefore I am not going to say why it is what we do in the cryptology. And now, next point, when you do elliptic curve cryptology, one of the important things that you will be doing is something called Weyl pairing. And why is this Weyl pairing important? The reason why the Weyl pairing is important is that, you know, that for the standard DLP, standard discrete log problem, okay, it is still not known to be polynomial, and probably solving the problem probably is definitely not polynomial, but at least many sub-exponential algorithms are known. Many sub-exponential algorithms to solve the standard DLP is known. Whereas, on the other hand, for elliptic curves, such sub-exponential algorithms are not known. And that is exactly what makes the elliptic curve to be even safer, much safer than the standard DLP. And as I was mentioning in the morning, therefore, if you use the elliptic curve thing, you can do a much shorter key and get a good security compared to what you do for either the ordinary DLP or RSA. If you need some 180 bit key is good enough for elliptic curves, whereas for the same security, you need 300 bit primes for a standard DLP and around 1024 bit primes for RSA. But then 3 people, Meneses, Okamoto, and Wanstone, came up with one idea of reducing the elliptic curve discrete log problem, or what is called ECDLP, to standard discrete log problem. And once you can reduce to standard discrete log problem, and for standard discrete log problem, since you have an exponential, sub-exponential timing, you can probably cope for a sub-exponential timing for even for elliptic curve. But that's not really the case, which we will probably discuss later. But on the other hand, this reduction of how to reduce from ECDLP to DLP was done by using what is called the Weyl pairing. And if you really do some elliptic curve cryptology, then this Weyl pairing and Tate pairing is something which you will come across again and again. And therefore, probably let me just explain to you what Weyl pairing means. What is it, Weyl pairing, and how does it help you to reduce an ECDLP to DLP? Let G be an additive group. And suppose you have an element G in G. And you say that this element G is M torsion if M times G equal to 0 in G. And remember, this is something similar you would have studied about the order of an element. You say that G is an order of G is M if M times G equal to 0. But there's a subtle difference between torsion and order. And if when I say G is M torsion, I mean Mg equal to 0, and that's all I need. Whereas when I say G is a order M, which means that Mg should be 0 and M is the smallest integer satisfying that property. Okay, therefore I don't need M need not be the smallest integer with that property. If M happens to be the smallest integer with the property, then you also say that the order of G is M. And similarly for the multiplicative group. If G is a multiplicative group, then G is M torsion if G power M is equal to identity. And now what we want to talk about the torsion points. Therefore, let E over FQ be an elliptic curve where Q is the power of the prime P. Okay, therefore you know that all the fields will have only P power M elements for some prime P and some power M. Okay, it cannot have some 6 elements or 26 elements or anything like that. The number of elements of a field would always be a P power M. And let N be any integer not divisible by P, and it's not divisible by P is needed for some reason. And now En is a set of N torsion points in E FQ bar. Now I am not just looking at FQ, but I am looking at FQ bar, and FQ bar is normally what is called the algebraic closure of FQ. And I don't know how many of you have seen what an algebraic closure is, but on the other hand, I mean, at least when you do the mathematical aspect of cryptology, you need to know all these things. Therefore, there's an algebraic closure of FQ bar, and you are looking at E over FQ bar, which means you are looking, the curve, remember, is defined over FQ. The curve is defined over FQ means the equation is y square equal to xq plus ax plus b, where a belongs to FQ and b belongs to FQ. But now E FQ bar means that you are looking at the points x comma y, where x belongs to FQ bar and y belongs to FQ bar, such that y square equal to xq plus ax plus b. Therefore, all those points xy in FQ bar which satisfy the equation y square equal to xq plus ax plus b is called EFQ bar. And that is a group. And in that group, you look at the N torsion points, and that is called En. And then you know that En is an additive group. And you also know how this additive group will look like. Additive group will have rank 2. It will look like a Z over NZ, direct sum Z over NZ. Remember, I am assuming that N is not divisible by P because this particular statement, E of N equal to Z over NZ, direct sum Z over NZ, is not true if P divides N. And now let mu N be the N torsion points of FQ bar star. Now remember, FQ bar is an algebraic closure. You take the non-zero elements, that is a multiplicative group. And in this multiplicative group, you look at the N torsion points. And this is what is normally you would have seen as the nth roots of unity. That is all those elements x such that x power n equal to 1. Therefore, that gives you a mu n, which is the N torsion points of FQ star. And now let G be an additive abelian group. G2 is a multiplicative abelian group. And the fact is that I don't really need them to be additive and multiplicative. I can do anything, but in my example, which I am going to talk about, this is my G1 will be an additive abelian group and G2 will be a multiplicative abelian group. And now you take a map, which is from G1 cross G1 to G2, and this map E, and this is called a pairing. Therefore, a pairing, therefore you take an additive abelian group and a multiplicative group, and then you take G1 cross G1, the Cartesian product, to G2, and then you define a map E from G1 to into G1 to G2, and this map is what is called a pairing. And a pairing is called a bilinear pairing if it is linear in the first coordinate as well as linear in the second coordinate. What do you mean by the linear in the first coordinate? E of G plus H comma K should be E of GK, E of HK. Remember, since G1 is an additive group and G2 is a multiplicative group, in the left-hand side, I am using the additive notation. In the right-hand side, I am using the multiplicative notation. And similarly, it is linear in the second coordinate, which means that E of G of H plus K equal to E of GH into E of GK. And again, you see that I am using additive notation in the left side and multiplicative notation on the right side. This I want for all G, H, K, and G1. And such a bilinear map is said to be non-degenerate if the first coordinate is G and if the first coordinate is not 0, then I should be able to get a second coordinate such that the value is different from 1. Therefore, if I take the first coordinate, if G as the first coordinate, and if G is not 0, then I should be able to get a second coordinate such that the value of E is different from 1. Therefore, that is what is called a non-degenerate. And a pairing is called alternating if E of G, G equal to 1. And actually, one can prove that if E is a bilinear map and an alternative map, then E of GH and E of HG will be the inverses of each other. E of HG into G of GH will be exactly equal to 1, and I have given a proof which I will skip. And now that comes the Weyl pairing. There exists a bilinear, which we have already defined, non-degenerate, which we have already defined, alternating pairing in G, which is En, which is En into En to mu n. Remember, En is the n-torsion elements of U over FQ bar, and which is an additive group, and mu n is the n-torsion element in FQ bar star, which is a multiplicative group, and therefore this is exactly the G1 cross G1 to G2 situation, and therefore this is a bilinear non-degenerate alternating pairing exists, and that's a theorem due to Andre Weyl. The Andre Weyl proved that there exists a pairing which is a bilinear non-degenerate alternative pairing, which therefore in some sense you can use this pairing to take your ECDLP, and ECDLP is something which works in this capital E of n, which is the works in the n-torsion points of the elliptic curve, to mu n, and mu n is an ordinary cyclic group. Therefore, you have converted your ECDLP to a standard DLP. And of course, this Weyl pairing satisfies more thing also, namely that Mn of PQ will be equal to En of MPQ, and it also respects Galois, which I don't, I mean, you should know that it respects Galois. I don't want to go more into it because I am not even sure how many of you know what the Galois group is in this case. And this is called the Weyl pairing. And it was observed by Meneses, Okamoto, and Wanstone. This is a very important result, that in the ECDLP on E over FP can be reduced to DLP on mu L for a suitable FQ, and thus can be solved in sub-exponential time. Okay, therefore that's an important observation which was made by Meneses, Okamoto, and Wanstone, which is called an MOV algorithm. And this MOV algorithm says that you can take an ECDLP, which is a DLP on an elliptic curve, and to make it map it to usual DLP on a cyclic group, and usual DLP on a cyclic group can be solved in sub-exponential time, and therefore even ECDLP can be solved in sub-exponential time. And they actually gave very many examples also, and such a reduction is particularly effective if E happens to be a super singular curve. Sorry, I don't think I have time to explain what a super singular curve is, but it's something called super singular curves. Then you can do this reduction and really can solve the ECDLP in sub-exponential time. That means ECDLP in super singular curves to be weak. And therefore, if you are using for ECDLP for your cryptological purposes, then you should not take your elliptic curve to be a super singular curve. Because if you take your elliptic curve to be a super singular curve, then I mean it gives you no advantage whatsoever compared to the ordinary DLP, because you can always reduce the ECDLP to DLP. Okay. But on the other hand, it was proved by Koblitz et al. That this reduction works only a very small percentage of curves. Most of the curves, this reduction will not work, and it will not give sub-exponential time, and therefore we are really safe. There is nothing much to worry. And as the last part, I will talk about something else, okay, and which is, you know, I explained that you can actually count the number of points of an elliptic curve, and that is rather easy. You choose every y coordinate, sorry, every x coordinate, compute x cubed plus ax plus b and take y square equal to that and see whether that has 2 square roots. And if it has 2 square roots, then you put them, and most of the time, or half the time, it will not have any square root. Leave those x coordinates. And this algorithm is not a polynomial time algorithm, because you have to choose every x, and therefore there will be p values of x we should choose first. And therefore, when you choose p values of x, at least p operations you are doing. And if you are doing p operations, then clearly it is not a polynomial time algorithm. But then René Schoof came with a polynomial time algorithm to compute the number of points of the curve. And this counting this number of points on this curve actually involves what is called a division polynomial. And therefore, if you are actually doing some elliptical cryptology, and if you get an elliptic curve, and if you have to count the number of points of this elliptic curve, then the best way is not to choose every x and then do the y, but essentially follow Schoof's algorithm to compute the number of points. And for Schoof's algorithm, you need something called a division polynomial. I thought I will just introduce what a division polynomial is, but because I will not have time to explain how the division polynomials are used in the Schoof's algorithm. Therefore, let E over K be an elliptic curve given by this equation again as usual, y square equal to x cube plus ax plus b, and let M be an integer. Let M be an integer which is co-prime to the characteristic of K. And you know what the characteristic of field is, and I choose an integer which is co-prime to the characteristics, and then I take the M division point, M torsion points, EM, which I have already defined. What are the M torsion points of EM? And I have already said that that will look like a Z over M is a direct sum Z over M is. And therefore, the number of M torsion points is precisely M square. Hence, other than infinity, we have M square minus 1 M torsion points. For some application, for example, Schoof's algorithm, it is desirable to compute them explicitly. Therefore, I will say that I have an M torsion points, and I would like to compute what are the M torsion points. And that is normally done by the so-called division polynomials. What do they define? Psi 0 equal to 0, psi 1 equal to 1, psi 2 equal to 2y, psi 3 is equal to 3x power 4 plus 6ax square plus 12bx minus a square, psi 4 equal to 4y into x power 6 plus 5ax power 4 plus 20bx cubed minus 5a square x square minus 4abx minus 8b square minus a cubed. More generally, psi 2m is given in terms of psi m plus 2, psi m minus 1, and psi m plus 1. And psi 2m is psi m by 2y into psi m plus 2, psi m minus 1 whole square minus psi m minus 2, psi m plus 1 whole square. The point which you should realize is that when psi 2m plus 1 is given in terms of psi m plus 2, psi m minus 1, psi m minus 1, psi m plus 1, then such an algorithm is really a polynomial time algorithm. This I will leave it as an exercise, that if you are given a formula like a psi 2m plus 1 equal to psi m plus 2 into psi m minus 1 whole cube minus psi m minus 1 into psi m plus 1 whole cube, and then computing every psi m is really a polynomial time algorithm. Give me any psi m, I can compute psi m in polynomial time. And these are called division polynomials, and psi m can be computed in polynomial time. Even though psi m looks like a polynomial in two variables, in fact, it is not so. And in fact, if m is odd, psi m is really a polynomial in one variable, m into x into by m square minus 1 over 2. And the theorem is that if m is odd, then you take this equation psi m and take the roots of the psi m, and the roots of the psi m gives you all the m division points of the curve. And on the other hand, if psi m is even, then you see psi m by y is a polynomial in x, and therefore you can solve separately psi m by y equal to 0 as well as y equal to 0, and that will give you all the m division points. Yeah. the roots of Px equal to 0 as well as y equal to 0. And that is how the M division points are taken. And this is something which you should know really if you want to really understand what is true for algorithm and how to compute the number of points. And I think I am just running out of my time and I will stop here.
Okay, any questions from the audience? Okay. Thank you, sir, for in detail discussion on elliptic curve cryptography. Thank you, sir.
Yeah, thank you.
You want to add?
Thank you very much. It was a very involved discussion on mathematics of elliptic curves. Even though my research area was elliptic curves, the initial things what you have discussed, how that formula of elliptic curves were discussed, how it was derived, it was very interesting because as the researchers who work in the area of application of elliptic curves would not be knowing much about the mathematics of elliptic curves. It was really a wonderful topic using very elementary examples, which would be definitely helpful for the people, those who want to really know about elliptic curves. So thank you so much. We will be back once again joining with you during the valedictory.
Oh, sure.
Yeah, at 4 p.m. sharp, we will join back.
Yeah,
And
sure.
please log in at 4 p.m. and present a valedictory address of NWC 2021. And we are very fortunate to have you as the president of Cryptology Research Society of India. I am very proud that we are having president of CRSI during our valedictory, where secretary of CRSI was there during inaugural function. Very nice there. Thank you so much.
Thanks, sir.
Good afternoon, Guru Raj. Good afternoon, Dr. Guru Raj.
Yes, sir. Good afternoon, sir. Good afternoon. Good afternoon. How are you, sir?
Fine. We are in the last session of CRSI, NWC. Very popular as CRSI NWC. That is why I thought I will definitely say about that. We are hosting the pioneer event of CRSI for the third time. I'm very nice to have you, young researcher Dr. Guru Raj HL, who will be speaking on roles of AI in cyber security, and he will be there with us for another 45 minutes to 1 hour. At 4 p.m. we'll be joining for valedictory function. So now I request Mr. Darshan, who is one of the coordinator of NWC, to introduce Dr. Guru Raj HL.
So good afternoon, everyone. I'm hereby want to introduce Dr. Guru Raj HL to the research community. Dr. Guru Raj HL is currently working as Associate Professor in the Department of CSE Engineering, PVCE, Mysore. He holds a PhD degree in Computer Science and Engineering from VTU University, Belgavi 2019. He has 12 years of teaching and research experience at both UG and PG level. He is professional member of ACM. He is the founder of WING, that is Wireless Internetworking Group. He is a senior member of ACM, lifetime member of Cryptology Society of India, and senior member of IEEE Computer Society. Dr. Guru Raj was appointed as ACM Distinguished Speaker by ACM US Council. He has received Young Scientist Award from ITS SERP, Department of Science and Technology, Government of India in December 2016. He also received Best Project Guide Award consecutively for 3 years at MCE Hassan. He has worked as special editor of EAI Publisher and guest editor of Multimedia Springer Journal. He is an editorial member of various international journals. He has 4 edited books in Springer, IET, and IGI Global. He has published more than 75 research papers in peer-reviewed journals. He has presented more than 30 research papers at various international conferences. He has received grants from CSIR and AICTE to organize international conferences. He has international collaboration with top-notch researchers from University of Texas, University of Houston, and many more. His research areas interests include blockchain technology, cyber security, wireless sensor networks, ad hoc networks, IoT, data mining, cloud computing, and machine learning. Now it's over to you, sir, to deliver the talks. I welcome you, sir.
Thank you so much for your nice introduction. And first of all, I would like to thank the organizing committee and also Satyanarayan sir for giving me an opportunity for this session. Please kindly acknowledge once the screen visible. Let me share my screen.
Yes, sir. Please display the presentation, sir.
Is my screen visible?
Yes, sir. Visible, sir.
Okay. Okay, perfect. Yeah, good afternoon once again, everyone. The topic of the day, which I have taken, is a role of artificial intelligence in cybersecurity. And as I'm Dr. Guraj Ichal, working in the Department of Computer Science and Engineering from past 12 years. To begin with, my talk on cybersecurity with amalgamation with artificial intelligence. These are the contents. Initially I'll give in a few minutes. I'll talk about introduction, followed by how IA can be incorporated for cybersecurity works, and have one research paper which I published in one reputed journal. I'll show you that the results of that, how we can have machine learning incorporation with cyber security. And later on, I'll tell you the impact of artificial intelligence on cyber security. And at last, so whatever the type of emerging technologies we have a lot of drawbacks or loopholes. I mean, to say limitations, we'll discuss at the end of my session. Okay. Yes, I think we all know about what is artificial intelligence. Artificial intelligence, commonly known as AI, which is a field of science which is mainly focused more on finding solutions to a complex problem, adding extra intelligence or taking extra decisions on based on intelligence. Okay, and mainly this artificial intelligence, when we talk about it's an artificial, as name vocabulary sense talks about. Additionally, we are adding the intelligence to any system to make the performance or efficiency better. So out of which, how this will the ultimate motto of this topic is to have how this artificial intelligence or machine learning algorithms makes to decide whether any kind of attack is existing, or any kind of node has compromised, or any kind of data has been theft very smartly with the help of this technique. I'm not going to say that this is the only technology we have. We have a lot of other technologies. It might be manually identifying, or it might be a lot of iterative process. We have a lot of other mechanism, other softwares are available. Along with that, this makes a burden somewhat lesser when we compare with the existing thing. To have an introduction towards AI can efficiently be used in situations where there is a need to analyze tremendous amount of data. If we want to monitor a few amount of data, if you want to track off a few amount of data, the time taken, time is also one of the constraints. I think we'll call it as a delay. I think we don't want to wait nowadays. Correct? Immediately we have to download the video. We have to upload the things. And we are into the pace of internet connections. We don't want to have any kind of delay. How we can overcome the delay sensitive mechanisms for this kind of security threats can be avoided. And commonly we have a lot of networks called as DTNs, commonly known as delay tolerant networks. In such networks, how can we have delay reduction? How can we reduce the delay by identifying the threats? That is a challenging issue here. And with the rise of technological inventions, artificial intelligence was able to make its place in cybersecurity, very major place in cybersecurity. It also provides innovative way to increase cybersecurity, which is based on technologies which are coming up. It might be unauthorized access or to prevent the damage of the information present in the network. See, cybersecurity means that not only data security, along with that, there is a part of network security. Data security, I can equate that to network security plus data security. Combinedly, we can call it as cyber security. Same thing, we have three important terminologies we used to highlight. One is cyberspace, cyber attack, or cyber law. Cyberspace is nothing but the space which is accommodated mutually with the help of any kind of Google space, or it might be the hardware space, standalone spaces or whatever. Any attack happens in the same space, we can save our data. It might be images, or it might be your text files or PDF files, or it might be videos and all. Similarly, we can also able to accommodate somebody's photos, or somebody pictures, or somebody various their person identification information. The attack in which we can have the attack in the cyberspace, commonly we call it a cyber attack. Okay, so any kind of attack for that matter. Similarly, when we talk about cyber law to get reduce these kind of attacks, we have a law. So how can we smartly reduce these attacks with the help of unauthorized access, or we can able to prevent the damage for information present in the network? Yeah, especially every organization, whether it is a small or big, transmit a vast amount of data, both locally and also globally through networks, especially on online systems. I think, this is a better example. I'm using one of the Zoom link application, Zoom video conferencing application to present this, talk. Correct now. So whether this is end-to-end encrypted or not, I'm not sure. Correct now. So when we talk about this kind of encryption, video conferencing tools, whether it is compromised with the third party or not, whether the data which I'm delivering right now, it is shared only with the people who are available, or this kind of things focus mainly on cyber security. And also the data which is stored in the systems which can be attacked by an external interface for extracting sensitive informations like passwords, or it might be the personal identification informations and all. Okay, so the substantial amount of such data include personal or financial information. Yeah, financial frauds also plays a very vital role in the facet of cyber security. Financial, it might be pin code attack, or it might be account or OTP or two authentication passwords, whatever. All those also we can call the financial frauds that commonly happen in especially in this scenario of contiguous network. Okay, so such condition will arise especially only if there is insufficient cyber security measures. Okay, so how can we efficiently we can cope up with the cyber security? We'll see. As I mentioned, cybersecurity ensures that data theft, it might be data manipulation. By taking the data, he'll manipulate the data, or he again feed the data, and cyber attacks are detected timely, and attackers are not able to exploit vulnerabilities which can lead to compromise in sensitive systems. Okay, to deal with such challenges, various agencies and organizations have explored ways of implementing AI in their regular cyber risk operations. Okay, this incorporation of AI with cybersecurity will somewhat reduce the pressure of humans, as they can detect intrusion very earlier at an early stage before having major fraud attacks. One simple illustration which I can tell you is in the bank account of 10,000, if 1 rupee has been deducted, we never bother much. Correct? No? If the amount is larger, which affects you guys, if it affects the respective individual, how can we mitigate such attacks? How can we mitigate such fraud attacks and all? So let me have phase of implementing how we can have the implementation of AI in cybersecurity. I think one important security software, existing security software and database prevention algorithms provide a restricted scope. Thus, they are not able to spot potential threats in real time. On the other hand, adaptive machine learning algorithms, which are basically based on AI, and are designed to detect such suspicious activity and inform the user about the attack, what kind of attack and who when it happened. And I think you can check out the scenario right now. Once after having the attack, we'll get to know what happens and when it happens, and backtrack will happen. But prior information will be not there about the kind of or intimation will be not there about the attacks. Some alarm signals will be sent by the bank agencies, or it might be from the organizations, but prior information regarding, like, immediately when the attack happens, it cannot be catch hold of that attack by any of the systems right now we don't have. Hence, machine learning algorithms are designed in a way that they can continuously learn, keep on learning based on the existing training data set, and inherit those properties permanently on the existing, on the system which is already present. Okay. So usually, I think biometric login access is one typical example for personal identification information. Immediately after one or two attempts, the gesture, the gesture how I present my biometric is totally different from the gesture the other individual present. He may reproduce the same silicon toy of the hand gesture, or it might be face mask, or it might be whatever it might be. Ultimately, the gesture, the how we present to the machine is also important. Initially, when they come up with the biometric application, basically biometric has been introduced to give authentication with the human intervention. We have passwords before that, in which if I know my parent password, if I know my somebody's password, I can able to log in with the help of the system. If I know the password, that's a major drawback. If anybody knows other password, he can able to log in with the help of by knowing the passwords. Correct? That's a major drawback. So they introduced biometric in which the compulsory human intervention was required. In which initially they come up with the regular thumb impression, then palm impressions, then they went with the facial recognition. Now we have the iris recognition and all. But the attackers keep on reproducing the silicon toy, same kind of mask, or it might be hand palm recognition, or it might be facial fingerprint recognition and all. But again, there is a drawback. Okay, so the way how I enter the password, I may enter the password very fast, or I may enter the password by pressing each. The delay between entering one letter with the other letter might be different. Based on these kind of iterative information, based on this kind of inheriting information, the system will learn the respective user behavior. This analysis is also called as behavior analysis of a individual person. Hence, if we take some time to type the password, or if we type the password very slowly, or if I type the password somewhat moderately, or if I type the password very fastly, that also matters a lot when we talk about biometric login access or biometric login system. Similarly, the type how I pose my fingerprints, the direction, or the angle how it represents also matters. Okay, so it does not mean that just to have my duplicate fingerprints or duplicate face mask, I can able to log in. Yes, you can able to log in right now with the system, existing system, but whenever we incorporate the complete machine learning algorithm, the machine will also identify the behavior analysis of the system. Similarly, we have behavior analysis of the network, right? For example, in one day, for example, regular intervals of time I used to download, the usage of network usage was 5 MB, or for example 50 MB or 100 MB, or maximum 1 GB. But one or the other day, if it consumes more, for example, threshold crosses the limit, for example 50 GB of data download or usage, that's kind of behavior analysis makes sure some attack or some threat might be vulnerability, might be some node of the user might be compromised with a third party. Correct? No? So this kind of biometric login access also plays a very vital role. Similarly, machine learning through natural language processing, as I mentioned, cyber security can also be incorporated with the help of natural language processing, such as if you use text to speech conversion or speech to text conversion, that also having behavior analysis, how we reproduce the words, how I reproduce the statements, how I solve the equation, and all that also comes into a part of machine learning. And the ratings, see, if the system is completely secure, I cannot give 100% always. Correct? No. So the ratings of the machine or the network or the data confidentiality, there's a rating, cybersecurity rating. Okay, what kind of passwords you're using, what kind of whether you're using the complete organization is using single sign-in mechanism or the individual sign-in is also required. All this based on this consent, the cyber security organization also will give ratings. Based on that, also we can able to perform better. And intrusion detection, as I mentioned, network intrusion detection prevention system. Right now we have both intrusion detection and also prevention, but everything has been done not completely automated. How we can improve, how we can how we can able to cope up with the machine learning intelligence for this kind of intrusion detection and prevention systems. Okay. Yeah, as I mentioned, the cybersecurity market, it will give the analysis based on scaling. It might be low, medium, high. Increased number of cyber frauds and malicious attacks will rate it as high. If the adoption of bring your own devices policy and getting attacked because they made if the device is external or individual one, they can get compromised with the other systems of the organization or other things. That is also one thing. And growing adoption of IoT and increasing number of connected devices. Yeah, see, these are the ratings based on different constraints. You can check out the source, www.psmarketresearch.com, where they used to have a scale for each and every analysis of the cybersecurity attack. And this is commonly known as impact analysis of the system. How we are get compromised. Okay, so I think we have. I think we all know one thing. I think my browser is visible. Can I get some answer? Please kindly respond. Is my browser visible? Is my browser visible?
Yes, sir, visible.
Yeah. See, this is one website, something like haveibeenpawned.com. Okay. See, where in which you can enter your Gmail address, or it might be something like your phone numbers, all type of attacks. Okay. It will be whether you are compromised completely or you are compromised partially, and all this will be can be identified with the help of one open source website called as haveibeenpawned.com. Again, many people, many audience will have a question, sir, what about this website itself has been compromised? Yeah, that's also will be there. You can check out my personal mail ID with 8 data breaches, and let me give some official mail ID. Okay. Yeah, we have less reduction of the database, correct? Now, so these are the this is one thing wherein which we can able to identify, or within which we can able to identify how much phishing has been happened and all. I think we all know about there are various types of phishing attacks, correct? Now, so we'll discuss that also in a in the upcoming part of my presentation. And yeah, but these kind of things with this kind of drawbacks, this kind of compromising the data, or it might be the compromising the third party data breach, or the network breach, or whatever. So this artificial intelligence provides some solution. Okay, somewhat better identification. Artificial intelligence is a irrevocable one, and it has become vital part of our daily lives. We all know that it has huge potential to bring improvement and innovations in this current data-driven world. And despite providing services in various sectors, the importance of artificial intelligence and cybersecurity remains on the top of the word. Okay, so if you talk about any business or financial services, cybersecurity is one of the biggest threats of them. These cyber crimes, or one important note we have to take care about this. See, whenever we adapt the machine learning intelligence, I will discuss more on this at the limitation part. All the data which we fed to the machine or which we fed to the system, it will be recorded by the database, and all the data will be there. How can we believe the system which we had incorporated using machine learning cannot be get compromised with the third party? Correct? No, our system machine learning might be get compromised. Correct? So that is also one of the challenging issue. But right now, if you want to reduce the attack, we can have the incorporation of this kind of artificial intelligence technique. Okay. Yeah, artificial intelligence is working as a double-edged sword in the sector, as there is various doubts that hackers can also use AI for conducting cyber attacks and eliminating the number of required humans at the same time. The other thing is that it is easier to search out the vulnerabilities of cyber security service, and it is fact that attack networks are never recognized. Okay, but if I can AI can provide advantages to hackers, then it will also help business to improve the cyber security threats. Okay, so they if I know some hacking cannot be done by some experts. If I know hacking only, then only I know I want to do hacking. No, it's not like that. There is a market called as, I think we all know about this, black dark web and all, where if you want to attack somebody's network, somebody's device and all, you don't want to go and attack directly. You can get the exploit of it by just paying the amount of it. Okay, it's same kind of, if you want to kill somebody, you'll give Supari, right? Same thing we can do also here. Like it's not that any expertise who's well-known knowledge with the cyber security or network security, he only has to attack. No, it's not like that. So they will the attackers are ready in the dark web, and it's a marketplace for the attackers to attack the files based on the different services. They'll charge differently. For example, if they want to attack the PDF files, they will adopt readers and all. There will be some charges and all. Okay, so that makes the increase of the attacks nowadays, day by day, it's increasing enormously. So as it also supports, artificial intelligence can also reduce the cyber attacks. How it can able to, as it supports the attackers, it also helps the cyber experts or cyber analysis to reduce the attacks. Okay. And basically, as I mentioned, this complete cybersecurity broadly divided into two categories, as we can see, which we can depict it in this picture. Hardware attacks will also happen, and also IT attacks will also happen. So the hardware attacks is nothing but the control systems, or IT attacks is nothing but information technology systems. Okay, so if you want to manage physical sources, like such as it might be IO input SCADA, or input devices, or output devices, or it might be hardened PCs and servers or industrial networks, or it might be sensors, cameras, scanners, or embedded systems. On the other facet, we can have the printers to get the information. This is all about the data, and this is all about the hardware devices. Okay, so how this can get compromised with the third party, and how we can reduce the attack with the help of the third party is a challenging one. And yes, okay. So this is all about somewhat some introduction towards cybersecurity, and some basic introduction towards my artificial intelligence. And if you want to talk about artificial intelligence, basically we have machine learning algorithms, which can be broadly divided into two types. I think many of you people know about this: supervised, unsupervised, and reinforcement learning. Labeled data sets for training, and unlabeled data set for training, and learning with the help of mistakes are the three definitions for three categories of machine learning algorithms based on the data. It's all about based on the how to choose a machine learning algorithm, which machine learning algorithm have to choose for various attacks, cyber analysis and all. It's simple as you have to analyze your data first. What type of data you're analyzing? It's a decision making data, it's a classifying data, what type of data you want. Deeper analysis, you have to go for random forest kind of thing, correct? No? So based on the complete analysis of the data, you can able to decide which machine learning algorithm is required for which attack, which analysis. Okay, this is one thing which we can have. And the positive impact of AI on cybersecurity is based on artificial intelligence based measures which are taken for protecting the networks from the systems, which avoids attacks of cyber attacks in the virtual world. AI can assist in keeping the cyberspace clean and secure by applying security measures through algorithms and a lot of mathematical calculations. Alright. And the second important positive impact is that identity and prevent cyber attack. The cyber security systems which has been upgraded with AI can easily identify the unexpected attacks in the cyberspace, which mostly include high security based official website. See, when we talk about websites or web links, or it might be web, a normal text message, or it might be multimedia message. Based on this, this complete phishing has been basically categorized into three categories. Okay, one is wishing, one is smishing, and one is mishing. Okay, MISHING. Okay, so if you want to talk about phishing, I think we all know that you are getting faked by third party by without knowing the actual attacker. Correct? No, so it's called as phishing. Okay, but we feel that it's an actual one, but it's not actual. Same as of a normal phishing, how it does. Correct? No, so what the fish will does, fish feels that I got the food by the fisherman, but the fisherman is going to catch hold of the fish. Correct? No, same. The vocabulary sense might be different with the help of the spelling, but the normal tendency of phishing also does in the same operation. With the help of for phishing links, or it might be phishing messages, or it might be bombarding a lot of advertisement messages. We feel that we got the actual lottery, or we got the actual message from the actual person, but it's not. Correct? No. So this can be broadly divided into three major categories. One is wishing, VISHING. It's normally does with the help of voice calls, hence it is called as wishing. And phishing attack, which is going to does with the help of voice calls, any telephonic calls, we can call the attack as wishing attack by asking the passwords, by asking the usernames, by asking the email IDs and all. It is one kind of phishing attack. The second is nothing but smishing, SMISHING. Basically, smishing will be does with the help of sending messages. Okay, some fraudulent messages, or it might be some phishing messages across. It might be SMS or emails, and we can call that attack as meshing. And the third one we can have called as meshing, MISHING. Basically, meshing is nothing but taking a photo and uploading somewhere here and there and harassing the persons for the amount, for the money and all. We can call them as meshing. And basically, this attack will be done with the help of mobile devices, any mobile device. Hence, any attack that is going to happen with the help of mobile device, we can call it as meshing. Keeping all these three attacks in your mind, how you can imagine how phishing has been enormously grown nowadays. So how we can reduce the attacks of phishing by using artificial intelligence is the one challenging issue. Okay, the hacker tries to mediate the system for initiating the cyber attack. The AI-based algorithm which detect it on the spot and prevent any further intervention. Mostly, virus attacks and malware are used by hackers for triggering the attack, which leaves the complete network and system clueless as what exactly happened. You will be not at all get to know what happened, when happened, and who does the attack. Okay, so that is a major impact on of this cyber impact. Okay, and the second positive impact of AI and cybersecurity requires minimum human intervention. And it's not about expertise with the machine learning or expert will do the analysis and all. It's not about a person who is a system analyst, or it might be data analyst. He has to do it. A machine can do plenty of work as without any human intervention. Okay, so one example is high security websites are depend upon AI for detecting any unauthorized entry and combat it even without any direct human involvement. Detection of huge website, how many logged in and how many logged out. So what we have a lot of captcha comes into picture. Correct. No? So the analysis of the captcha entered by the user by the device, it's totally differs. Okay, the threshold also differs. Hence, those kind of analysis can also be done with the help of AI techniques. Okay. And AI cybersecurity systems are adding new horizons as it is making use of predictive analysis, which will provide a most fast and effective approach as compared to manual human intervention. Okay. By keeping the positive impacts on AI with cybersecurity, what are the importance of AI and cybersecurity to improve cybersecurity threats? One is the just we discussed just a takeaway. What we can discuss so first, network security, intrusion detection, phishing attack prevention, password protection, user behavior analysis, antivirus software. Yeah, when it comes to the point of antivirus software, we never ever ready to upgrade the system or update the softwares quite oftenly. See, intentionally when we nowadays people will suggest you people to upgrade your softwares. It might be a operating system, or it might be a software, or whatever. Correct? No. So when any nowadays the people will give a lot of advertisement for upgradation of the software. Correct? No. So this also supports the attackers to launch a lot of fake upgradation APK files in the market, such a way that instead of uploading your file, your software with the no proprietary platforms, like it might be if you are using Android phones, you have to upload your software only with the help of Play Store. Similarly, with the help of iPhones users, they have to upload only with the upgrade with the help of Apple Store. Similarly, other respective users, the attackers will read if you got any APK files to upgrade your softwares, or it might be your machines. Don't do it. Why? Because they all get compromised. Okay, so the new patch has been introduced, and they will give you advertisement mails, new patch of operating system, new patch of applications are ready in the market. You can upgrade with a lot of features and all, but never ever do that. Why? Because as I mentioned you very clearly, nowadays each and everyone bothers to upgrade the softwares immediately because of the new features, and make sure you will upgrade only with the help of app stores and regular authentication stores. Okay, so this kind of antivirus software analysis, whether it is your system or your machine is upgrading properly with the help of authorized services, or it's upgrading with the help of fake services, can also be identified with the help of this artificial intelligence technique. Okay. Yeah, one simple behavior analysis, as I mentioned very clearly. A typical example I have posted here. Have a lot of log files, log data. As you enter, I think many of you people know about the log files, right? So if you want to enter your login details like time, date, and all, similarly everything will be recorded nowadays. Based on that, it will decide the behavior of each and every individual. Okay, so complete log files will be categorized based on every individual, and obviously this will be a kind of supervised learning, because every data is labeled. Okay, so this behavior is of x1, this behavior is of x2, and all. Correct? No, based on this behavioral indicators, obviously we cannot go with unsupervised. We should go with the supervised learning, and this will also track, for example, if the user enters and if the user enters the data with the help of proper with some time consent, or it might be the wrong or right consents, entering the password, that also matters when we talk about the behavior analysis. Correct? No? So keeping that in mind, it will identify and it will give the ID. For example, if the event happened properly at that respective time, they call it as event vectors, and they'll give the ranks. Correct? No? So based on the wrong attempts or wrong or else the time constant, based on all the features, they'll give the rank. Correct? No? So this kind of analysis can also be done with the help of this artificial intelligence technique. Correct? No? Even though we may enter the right password, or we may enter the right biometric, the analysis will be done for the behavior. Okay, so this kind of feedback mechanism makes the system to keep secure, and keep somewhat secure from the cyber attacks. As I mentioned, phishing attack or phishing detection is one of the challenging issues, as I already mentioned in prior. Let me show you some article I have. Yeah, I think the screen visible. I guess it's visible. So yes, yeah. Uh, this one. Yeah. Phishing website detection based on effective machine learning approach, and it is published in one journal, one of the journal of Thailand Francis. Here, what we did is, I'll show you the details, and you guys can also evaluate with other machine learning algorithms also. So what we did is we have used basic machine learning algorithms like naive Bayes, KNN, random forest, and support vector machine, and the complete data set. Yeah, exactly, this is also required. if you guys, I'll share this with the organizers. See, you can say log in with the help of the databases which are already present. And I'm not talking about the Kaggle website. They'll also get the databases. I'm talking about some other platforms where you'll get only, especially for phishing attacks, and you get a lot of features or training data set and all. Using this data sets, we train the model. Actually, initially we train the model with the help of this data sets. And then based on features extraction and some of the feature extraction, what we took is one is address bar features for website phishing website, address bar features, like it might be slashes, continuous slashes, or http or https. This is one important feature what we took for the phishing website. And abnormal base function, like the metadata, script, and link, where it redirects to that. And it also we have taken server from handler web pages, like redirection, correct? No, so see, sometimes if you enter the actual website also, it will redirect to some other website, correct? No, so for example, instead of my attempt to direct my website to for example, let me show you something. Actually, if I enter something like I want to, this is my website, an example. If you type the website like this, it has to redirect to my website. This redirected immediately. But sometimes you can observe many of the website will not redirect to the actual websites directly. What it does is it will redirect to some other home page, and again you have to click OK or some button, or immediately it will take some time to redirect to the actual web page. Correct? No, so those kind of server from handler web pages, that's also considered as one of the abnormal based features. And HTML and JavaScript features also were taken, and most of the website are built with the help of HTML pages and JavaScript pages again. So we have given some threshold value, and we had used the features or functionalities of syntax and semantics of this. And I think you all know a very important fact is that if you right click this and you can inspect here, I'll get the complete code of this, correct? No, the complete code of my website. Anybody can able to see this. I mean, anybody can able to copy this. Somebody can reproduce a fake website with the help of copying the complete code, right? You may many people or many students will ask the same question. So why they have the option of having the complete page? Because if you want to do any kind of research, you cannot do from the scratch. So hence if you want to build any kind of website, many platforms are available. And if I want to have, for example, I have one website called Amazon website, an example. Okay. What the attacker will does, instead of Amazon, Amazon.com, a small change in the website we can reproduce, correct? No? So those kind of what the attacker feels, he never bother about the website name or website extension and all. What the user intended to buy a best product out of it, correct? No? So but it's redirecting to some other website. This was again one more article we reproduce. Actually, we can alarm reproduce a fake website just for research purpose. We develop a fake website and deployed. And that is where one more important feature we have called Java and HTML features we had taken here. And yeah, one more thing is domain-based functionalities like .com, .in, .gov.in. Those government, lot of domains are there, correct? No, if it is Indian website .in, if it is an academic version .ac, correct? No, so or if it is a commercial website .com, those domain-based function or those domain-based features also considered for this feature extraction. And by analyzing all these features what were taken, and as I mentioned, the database, and we explicitly use random forest algorithm. Okay, those you may feel that only those features are enough, and have you compared all possibility features were taken for analysis of this? No, it's not like that. That depends upon your usage. Okay, depend upon your availability of data. We had taken these 4 features. That's what I said. If you want to extend, you can take up the other features also. And explicitly, we have used a lot of other classifiers also to analyze K nearest or SM and all. Explicitly, random forest is one good algorithm. I think many of you people know about this. Intentionally, I'm not highlighting much of the features of machine learning algorithms. because it is cyber security, network security, program. I don't want to highlight much on the cyber, machine learning algorithms. But random forest, basically, one of the, classification regression algorithm. Basically, it will use two steps. One is called as creation and prediction. In creation, it will create the random forest tree based on the input data, and in the prediction, it will give the prediction. I mean, what the accuracy or what the proper percentage of accuracy it will keep. Okay. Basically the output of the random forest is a class selected by the trees. For example, the set of based on those features, it will classify this is phishing website with these features. This is a set of phishing website with these features and all. Okay. So this is all about that, and we got this random forest classification tree. I have copied here already. Yeah, this is a big classification tree we got. I can zoom in based on various features, based on threshold value. We got this. For example, it will tell about various index parameters will be there. I think those who are aware of this random forest will get to know, called as Guinea index, and how many samples and all. So based on that, we have classified and some set of categories as some phishing website with some threshold, phishing website with more threshold, the valid website and all. So this is one important thing what we have done, I think. And yeah, this is all about how phishing can be used, how phishing can be analyzed with the help of various parameters. Again, I'll explicitly mention this is not constrained that you have to use only these parameters. You can use more number of parameters. Okay. So, and all the regression tree, I think we all know that can be analyzed with the help of each and every individual prediction for unseen samples. Let me assume the unseen samples has x dash, and which can be made by averaging all the predictions of the complete inputs, and it will be the case study of this phishing attack. Okay. Yes, this we discuss, and right now, I think we all having the situation where whether the phishing attack happened or not, something went wrong. Will tell to your friends or somebody, IT support and all. What they suggest you people to reboot the system. Nothing is there. The same, the website or the phishing website. As I mentioned, phishing we have three things, right? Phishing mails, phishing website, or something. Nothing happened. You reboot the website, and again they'll tell, yeah, somewhat it's secure now. It seems to be safe. Okay, but it should not be actually nowadays. The redirection will not affect you instantly. It will immediately affect you later somewhat, correct? No, and that is called as spyware. Now we don't have malware at all. Now malware we have, but spyware also comes into picture. I think you all know that. Initially, malware is to take out the data of your machine. Spyware is to take out the is to affect the system, like introducing the virus, or it might be Trojan horse, or it might be virus, or it might be worms and all. Correct? No? To replicate, to occupy the larger space and all. But spyware, it's not like that. The main job of spyware is to take out your login credentials. How will login? That credentials will be taken care. That has to be recorded. That is the main job of spyware. Okay, so initially you'll not get to know whether spyware has been there in your machine. Once the better examples for spyware is ransomware. Correct? Now, how ransomware works? It is one spyware. They'll completely catch hold of your complete machine, and they'll demand for bucks, right? I mean to say amount, right? Okay, so those kind of attacks should be there, will be there. So the user should be something went wrong, and he has to check, and you should make sure analyzing the complete website you are secure or not. That is a main thing. Okay. And when we talk about the password protection, yeah, I think we all know what the top one password frequently attacked is 123456789. That's a common password. Or password itself is a password. Okay, so this kind of passwords will be immediately compromised by the third party, especially nowadays, as all has been analyzed with the help of machine learning, correct? So, or your dictionary attacks password. What is the meaning of dictionary attack? I think you all know that, I guess. Dictionary attack is something but your relevant information about something like date of birth, or it might be your surname, or it might be child name or whatever, correct? So these names will be easily compromised, get compromised. Okay, so especially as we have added intelligence to the system, they will immediately catch hold. So even though the banks and all, they never give the password for lifetime, they'll ask everyone to change the password, because each and every password will be having an age. What is the meaning of password age or password aging? They'll set up a lifetime of a password. After some time, the password will get expired. Correct? No? So that, so such passwords we can call them as password aging for 90 days or 100 days or some days. Within that, so one or the other way, the password will be get compromised. So we have to keep changing the password. And usually what we used to do is to save all your password, we'll give the same password. Actually, that is also one major, artificial machine learning attack, in which usually we'll give the same password for almost all the credentials, correct? No, have an habit of using the same password for all the credentials. That is also one behavior analysis to use the same password, and that also catch hold by the attacker. So try to use different passwords. The machine will find difficult to analyze which passwords you are using. Okay, that is one thing. And I think we discuss about antivirus, and also here the you know yeah, we already discussed here the user behavior analysis, and also we discussed about antivirus software. One of the typical example is yeah, the spyware. Spyware is one typical example. Okay, so why business becomes nowadays, it's very easy for the people to attack, because as I mentioned, you don't want to be an expert. Okay, if somebody expert at machine learning, you can ask him to attack the other website by introducing machine learning. See, I'll tell you one more important aspect. Wireshark tool. I think many of you people know about Wireshark. It is one of the strongest packet capturing tool. And nowadays, the people are amalgamating Wireshark with artificial intelligence. I mean, to say machine learning algorithms in such a way that it will also capture the packet, and it will also analyze the packet. We all know that, right? What's the job of machine learning? To learn how to predict, correct? Along with it, it will also analyze. Okay, so what kind of data, where data, which data, all the analysis can be done with the help of Wireshark with artificial intelligence. Yes, and decrease time in detecting threats. And yeah, nowadays, by with the, introducing artificial intelligence, we can able to reduce the time. It is one of the vital factors in the cybersecurity system, as action on time must be considered to fight against attacks and threats. Okay, and the time is reduced by 12% taken for the detecting breaches and threats. And organizations can detect different threats with AI fast. Yeah, a fast AI also we have. Artificial intelligence is one mechanism, and we have fast AI is nothing but introducing deep learning with artificial intelligence. It will use convolution neural networks, or artificial neural networks, or it might be regression neural networks, which will again enhance the analyzing of the data, and make sure immediately it will at instantly it will detect, and it will highlight what it is, and what type of database and what type of attack and all. And nowadays it's very difficult to classify the attacks. It's a lot of attacks coming up, correct? No? So new attacks are coming up. So how to classify they belongs to this attack? And the challenging thing in machine learning is to classification of the attacks itself, because almost many of the attacks having the same feature. Almost many of the data attacks or the data breaches have the same features. That again requires deep learning or fast AI to enhance the classification of the attacks also. Incomparable accuracy, no way to help humans to match the accuracy of artificial intelligence. Yeah, when it is about to produce large chunks of data and analyze unusual scenarios and activities in lesser time. An AI program may be provided with the wrong input and programmed in another way that results in an unpleasant page. Yeah, as I already discussed about this. And as I mentioned, finally, with cyber teams of organization, there are certain organizations. What the job is to give the ratings. Okay, so the main importance, the very significant, as it provides a broad range of advanced AI solutions and tools to predict investigate, scan, and check consistently for the vulnerabilities at each level of the enterprise. AI tools can be placed on the network and also authentication and analytical level also. Okay. Yeah. One more important challenging issue of artificial intelligence is sometimes that by looking at the picture only you can able to judge. Sometimes we may judge, that's what we have, false positive and false negative. I think many of you people know about this, correct? No, false positive means nothing but we interpret wrongly, correct? No? Even though the attack, it is not an attack, we interpret it is an attack. Many times we interpret it is not an attack. Some many chances it might be an attack. Right now, so this kind of false interpretation also plays a very important role in artificial intelligence. Many times the right file or right data may interpret it as a wrong one, and many times the wrong file, the wrong data may interpret it as a right one. So this kind of machine learning adaptation and deep learning algorithms can point out the changes and patterns and gradually start to learn about those. Okay, so small change, a minute change, identification. Yeah, phishing website we did it for, and we got the accuracy of very few. You taking up the very huge amount of data with various parameters, we got almost 70 to 80% of accuracy. But again, if you want to achieve more and more, the data size, we have to make the machine to learn more and more and more. Correct? No? This kind of false positive, false negative can be reduced with the help of making the data volume larger. And we are at the last phase of my presentation. As I said, the limitations of using AI for cybersecurity. Summing up with the role of AI in cybersecurity, it can be asserted that there exists a rapid change in the detection and prevention of cybersecurity challenges. That is one thing. And as hackers are trying to utilize artificial intelligence for fulfilling their wrong intentions, hence they work on developing process which can assist them in breaking against cybersecurities. Okay, and AI is adding values and security levels for individuals, corporations, but if it is used negatively, will spread the power in wrong hands. Okay, these are major challenges on cybersecurity, AI with cybersecurity. At the outset, okay, well, we cannot assure the 100% fast, efficient, secure data, free from data breaches, free from vulnerabilities, and all from AI and artificial intelligence. Somehow we can enhance the performance, and I think there are various pen testing tools, penetration testing tools, which are readily available, and many attackers will also make use of those, and many cybersecurity analysts also we can make use of it to analyze the cyber attacks. Okay. So I think these are the famous attacks or famous analysis can be done with the help of machine learning. These are the best advantages out of it. As we discussed so far, whatever we discussed so far, to put up the complete summary, it's a faster detection can be done, obviously, which increases the performance, which provides network secure, which avoids phishing detection, and which avoids secure authentication, which provides secure authentication, and it also analyze the behavior of the the user, and preventing online frauds. These are the complete these are the problem statement. You can consider them as a problem statement itself. Okay, you take up any of the challenge, any of the this kind of analysis, and you can apply machine learning algorithms. Okay, this is all about my talk. And if you have any questions, please have your questions. And this is my website, and I'll keep posting my books, my conferences, my call for any chapters. Recently, I have one call for chapters. It's open for submission still. Again, it's on cybersecurity with machine learning only. Those who are interested, they can submit the book. And I'm running one more conference. I have. Yeah, those who are interested, they can submit the papers to this conference for this. Okay. Yes, I'm done. If you have any doubts, please put up your question. I'm very happy to take up your questions. Thank you. Thank you so much. So please unmute, sir.
Any questions? Audience connected online. If you have any questions, you can please come up. Our speaker will be very happy to answer.
Any questions at any point of time, you can contact me. As I mentioned, this website. It's me, guru.in. You can check out the details. You can catch me up and you can have your questions.
Yeah, Dr. Gururaj, it was a wonderful session on role of artificial intelligence in cyber security, and you have discussed the various cyber security attacks, how AI can be used for mitigating those attacks. Very happy to see your contributions to the technology through your website, and you have projected one of your paper also, which you have published in Tyler and Francis, very renowned journal. So thank you so much for joining with us for NWC 2021. Young researchers like you really makes a lot for such conferences. Once again, we will come back to you for detailed discussions in Department of Computer Science. Also, I will put a word to have you as a speaker related to various topics which you have posted in your website. So thank you so much once again for joining with us. Please stay back for the valedictory session, which will start another 5-10 minutes. Okay.
Thank you, sir. Thank you so much thank you for giving me a wonderful opportunity. Thank you, sir. Thank you so much.
Thank you. Thank you. Yeah, audience connected online, please stay back. We'll be coming back exactly at 4:10 with the valedictory address by Dr. R. Balasubramaniam, and we will be signing off from NWC 2021.
Hi, Indul Gupta. Yes, you are muted.
Yes, sir. Good
Hi.
afternoon, sir.
Yeah, it was nice. And in fact, whatever I wanted to say, some of the things, elliptic curve, etc., since you already introduced in your lecture,
Sir.
it turned out to be somewhat easy for me to cover what I wanted to say.
Yes, sir. How are you, sir? Since long.
Exactly. We have not met for a long time. Yes.
Yes, sir. So possibly, if, in the project, some project meeting, definitely we will meet. We will meet again.
Yeah, exactly. I think so. Yeah. I mean, I have not moved out of Chennai for the last 2 years.
2 years. Exactly. Last time you told me that you have not moved out since last 2
Yeah,
years.
exactly. And now I think it's getting a little bored. One has to probably.
Yes, sir. So most of, I think that I discussed with you long time back regarding some project.
Yeah.
Yes, so it got sanctioned. So I think in the meeting, definitely we will try to meet.
Oh, fantastic. Superb.
Yes.
Superb.
Yes, sir. Also, I'm planning to visit Chennai soon. So that time I will try to meet you.
Oh, I see. Very good. Which is the place you are visiting? IIT sets or what?
Sets.
Sets you are visiting.
Yeah, most likely next month I will try to visit.
I mean, sets seems to have now a director whom I seem to like very much. He seems to be somewhat active and
Yes, sir.
very forward looking.
Yes. I know that because Dr. Saxena told me its duration is over, now it's going to be over.
Oh.
Yes, that Babu. That, yeah.
Sharath Chandra Babu.
That's Chandra Babu, yeah.
And I mean, I seem to like him very much. I mean, he seems to be somewhat an energetic director.
Yes. Right.
எம்மாடி ஆண்டவன்.
Yeah, we shall start the function another 3-4 minutes. We are waiting for our beloved principal, Dr. K. Nagendra Prasad. He is on the way. Once he joins us, we will start the function. Another just 2-3 minutes.
A warm good evening to all. I'm Sheila S., your anchor for today's valedictory session, National Workshop on Cryptology 2021. It makes little difference how many university courses you may own if you cannot use words to move on idea from one point to another, your education is incomplete. With this idea, NWC 2021 had invited many eminent speakers to share their knowledge and ideas related to information security, which is very much essential in our day-to-day communication. As great minds discuss ideas, all the speakers of these 3 days of workshop discussed lot of ideas and also gave research ideas in the field of cryptography to enhance the security system in the online communication. Now, we are at the end of this 3-day workshop. let us begin with an invocation let us begin with an invocation. I would like to call Mrs. Sumati S to give the invocation.
ಗಜಮುಖ ವಂದಿಸುವೆ ಕರುಣಿಸುತ್ತಾಯೋ ಗಜಮುಖ ವಂದಿಸುವೆ ಗಜಗೌರಿಯ ಪುತ್ರ ಅಜನ ಪಿತನ ಮೊಮ್ಮಗನ ಮೋಹದ ಬಾಲ ಗಜಮುಖ ವಂದಿಸುವೆ ಕರುಣಿಸಿಕಾಯೋ ನೀಲಕಂಠನ ಸುತ ಬಾಲ ಗಣೇಶನೇ ಬಾರಿ ಬಾರಿಗೆ ನಿನ್ನ ಸ್ಮರಣೆ ಮಾಡುವೆನಯ್ಯ ಪರ್ವತನ ಪುತ್ರಿ ಪಾರ್ವತಿಯ ಕುಮಾರ ಗರುವಿಗ ಚಂದ್ರಗೆ ಸ್ಥಿರ ಶಾಪವ ಕೊಟ್ಟನೆ ಗರುವಿಯ ಚಂದ್ರಗೆ ಸ್ಥಿರ ಶಾಪವ ಕೊಟ್ಟನೆ ಗಜಮುಖ ವಂದಿಸುವೆ ಕರುಣಿಸಿ ಕಾಯೋ ಹರಿಹರರು ನಿನ್ನ ಚರಣ ಸೇವೆಯ ಮಾಡಿ ದುರುಳ ಕಂಟಕರನ್ನು ಹಡಿದು ಬಿಸುಡಿದರಯ್ಯ ಮತಿಗೆಟ್ಟ ರಾವಣ ಪೂಜಿಸದೆ ಸೀತಾಪತಿ ಕರದಿಂದಲೇ ಹತನಾಗಿ ಹೋದನು ಮಾರಿ ಜನಾಭಶ್ರೀ ಹಯಮದನನ ಪಾದ ಮಾರಿ ಜನಾಭಶ್ರೀ ಹಯಮದನನ ಪಾದ ಸೇರುವ ಮಾರ್ಗದ ದಾರಿಯ ತೋರು ಸೇರುವ ಮಾರ್ಗದ ದಾರಿಯ ತೋರು ಗಜಮುಖ ವಂದಿಸುವೆ ಕರುಣಿಸಿ ಕಾಯೋ ಗಜಮುಖ ವಂದಿಸುವೆ ಗಜಗೌರಿಯ ಪುತ್ರ ಅಜಯ ಪಿತನ ಮೊಮ್ಮಗನ ಮೋಹದ ಬಾಲ ಗಜಮುಖ ವಂದಿಸುವೆ ಕರುಣಿಸಿ ಕಾಯೋ. ಥ್ಯಾಂಕ್ ಯು.
Thank you, Sumati, for your melodious invocation. Now I request Dr. Pramod Kumar S to welcome the gathering.
Thank you, madam. Good evening to all. I, Dr. S. Pramod Kumar, Associate Professor, Department of ECE, JNNCE Shumaga, take this opportunity to welcome you all for the valedictory of NWC 2021. It is my immense pleasure to welcome today's chief guest, Dr. Al Balasubramanian, President CRSI, Kolkata, for this event. Welcome, you, sir.
Thank you.
And I would like to welcome Dr. Indivar Gupta, SAG, DRDO, New Delhi, to this event. Welcome, you, sir. I also welcome our beloved Principal, Dr. K. Nagendra Prasad, to this event. Welcome, you, sir. I welcome Dr. S.V. Satyanarayana, Professor and Head, Department of ECE, who is also the organizing chair of NWC 2021 for this event. Welcome, you, sir. I extend my warm welcome for participants connected online as well as offline for this event. I also welcome all my faculty colleagues for this function. Once again, I welcome one and all for the event. Thank you.
Thank you, Pramod sir. Now I request Mr. Darshan KV to give a brief report on the workshop NWC 2021.
A warm welcome to everyone. So I am here to read the workshop report. The Department of Electronics and Communication Engineering, in association with Cryptology Research of India, Kolkata, JNNCE IEEE Student Branch, organized the 3-day workshop on cryptology, NWC 2021, from 18 to 20 November 2021. Dr. S.V. Satyanarayana, Professor and Head of the Department of ECE, as an organizing chair, formulated the workshop that included 10 technical talks with 2 keynote speeches. The workshop got sponsorship from CSRI, DRDO, and IETE. Around 40 participants from various institutions had registered to the workshop. The workshop was inaugurated by Shri A.S. Vishwanatha, President NES Shimoga, in presence of Shri S.N. Nagaraja, Secretary NES Shimoga. Dr. Bimal Roy, Chairperson, National Statistical Commission, connected online and graced the inaugural function. Dr. K. Nagendra Prasad, Principal JNNCE Shimoga, in his presidential address, highlighted the importance of information security and motivated the student community, teaching fraternity, and research scholars to work in the area of cryptography and take up open problems and develop solutions. After the inauguration, we had the keynote speech by Dr. Bimal Roy on e-voting. In his keynote address, he presented the prevailing threats in the existing voting systems that use EVM machines, which included the manipulations of data stored in the EVM machine and possible solutions to overcome the threats. The keynote speech was followed by the technical talk by Dr. Alvin Roshan Pais from NITK Surathkal. In his delivery, he explained the phishing attacks and its influence on privacy of user information. The various solutions to counter the phishing attacks like machine learning framework were discussed along with the implementation results. The post-lunch session was an invited talk by Dr. Ashok Kumar Das, IIIT Hyderabad. In his talk, he introduced the concept of blockchains and its constructions and properties. As an application, he gave an overview of the Internet of Drones environment. After the technical talk, we had the paper presentation session, the first paper presentation session, and was chaired by Dr. Ganesh Aital and Dr. Alvin Pais. The second day began with the second keynote address by Dr. Roland Eric Haas, IIIT Bangalore, on automotive cyber security. In his address, he dealt on various security issues related to automatic vehicles. His speech covered the software complexity, attacks on the battery and thermal management system, locking system of electric vehicles, and cyber security management system. The talk was followed by the paper presentation chaired by Dr. N.R. Sunita, SIT Tumkur, and Dr. Gururaj HL, VVCE Mysore. The next session was a technical talk on privacy preservation on speech processing by Dr. S.R. Mahadeva Prasanna from IIT Dharwad. He explained the importance of privacy of speech information and possible misuse of the same. The various aspects in privacy preservation like noise addition, speech transformation, etc. were covered during the talk. The post-lunch session was on the ABCD of cryptography by Dr. Kannan Srinathan, IIIT Hyderabad. He gave a mathematical approach to the fundamental principles in the cryptography and the need of the mathematical procedure for information security. The next invited talk was on the scalability issues in blockchain by Dr. N.R. Sunita, SIT Tumkur. The importance of the blockchain and the need of the scalability, the challenges involved were discussed. Along with that, various solutions for efficient scalability like off-chain computations, consensus protocols were discussed. The last day, that is today, began with the technical talk by Dr. Purushottama B.R., NIT Goa, on secure access delegation. In his talk, he discussed about the symmetric key solution, public key solution for providing the access control from the cloud. He also introduced us with the proxy cryptography and the challenges. The next session was by Dr. P.K. Saxena on challenges in securing information. He gave an overview of various types of digital information exchange, the process involved in communication, various threats involved during the information exchange. Also, various measures to counter the threats were presented. The next talk was delivered by Dr. Indivar Gupta, SAG New Delhi, on applications of public key cryptography in secure communication. He highlighted the advantages of public key cryptography systems, the mathematics involved, and demonstrated the applications of public key cryptography in online banking, WhatsApp, and other media. The post-lunch session was an elliptic curve cryptography by Dr. R. Balasubramaniam, President, CSRI. He gave a deeper mathematical insight of elliptic curves and its properties. This was followed by a talk on by Dr. Gururaj Hechal, where he discussed on the role of artificial intelligence in the cyber security. So these were the proceedings of the 3-day workshop, the technical talks. Thank you.
Thank you, Darshan. So now I request our today's chief guest, Dr. R. Balasubramaniam, to address the gathering.
Thank you. Am I audible?
Yes, sir.
Good. Yeah, I am very happy to participate in this validity function of a very successful conference. I think this was planned last year, and due to the pandemic, it got postponed. And if we had done it in the last year, most likely you would have been to do it only on the online mode. The situation was very bad. And now you have been able to run it on a hybrid mode. And hybrid mode actually has its own advantages. I mean, the students, the participants can even discuss among themselves, know what they are doing. And besides attending the lectures, the discussions among themselves already would give them a little more input to really how to go about doing the research in this area. And this, by all means, was a very successful conference. And I think the main credit goes to Dr. Satyanarayana, and who has taken all efforts to run it so well. And probably I should also congratulate this JNNCE College of Engineering, and in particular, the principal Nagendra Prasad, for giving all the supports to Satyanarayana to run it so well. And the cryptology, unfortunately, is not a core subject. I mean, in order to understand the cryptology in its full entire thing, you may have to need more subject. You have to know some electrical engineering, you will be able to do some programming, then you need some mathematics. And this can come only from a certain collaborative efforts rather than individually, because there are too many subjects which you have to understand really to become a good cryptologist. And that is one of the reasons why these offline things, where the participants can discuss among themselves and even participate with the lecturer, etc., would be much more beneficial than an online meeting where you do not really have an opportunity to meet each other. And given this pandemic situation, of course, the physical meeting is impossible, but then you have done what is best that could be done, a very good hybrid mode. And let me again congratulate all of you for that. And that's all. I mean, it was a very well done thing, and it was very well summarized also. And by the previous speaker, I mean, I did attend the lectures at least today incompletely, and I think it was a very high level conference. Thank you.
Thank you very much, sir. So now I request the participants to give their feedback. So first, I request Dr. Murthy DHR from Presidency University to give his feedback.
Hello, good evening, everyone. Am I audible?
Yes, sir, you're audible.
Yeah, thank you very much. First of all, I would like to congratulate JNNCE and Satyanarayana sir and team for this wonderful event. and such a good organization, and the way they treat with the paper presenters. It was overall wonderful event. And also I'm happy to say that 2016 JNNCE NWC, I was a part of that also in the offline mode, and 2 papers were discussed. And this time also I presented 1 paper. I am just happy to share that also. Yeah, just very good. Overall, it was very good, and just we will we all work together and then just do some good for the field of cryptology, and then do something good for the welfare of the students. So that's what I can say. Thank you, sir, and congratulations, Satyanarayan sir and team. Thank you.
Thank you, sir. So now I request Ajit Kumar from NetApp Bangalore to give his feedback.
Good evening. So I'm an alumni of JNNCE. I completed MCA in 1999, actually. And I'm the first batch. I think Dr. Satyanarayan sir taught us computer networks. And I have attended all 3 national conferences organized by JNNCE. It was well organized. I know how much meticulous preparation is required when we are going to host such a national workshop. I can say I would like to congratulate the management and faculty members, students for making it all happen. Few things I would like to highlight here. Arranging speakers for technical talk. This is one of the hallmark. Like, we had very good speakers from IITs, NITs, and reputed organizations. Then coordinating with the speakers over multiple channels like WhatsApp, then email, phone calls sometimes. So time management, it is I think Dr. Satyanarayan sir is known for that. He always makes sure that program should start at the right time and should end at the same time. Starting at right time is good, and it is also important we have to wind up at the right time. I would like to thank the students for sitting here. I know I will understand sitting in a cryptographic conference is very difficult because it requires a lot of mathematics and understanding about the subject. I'm pursuing PhD in the same area, and I have consulted Dr. Satyanarayan Reddy sir multiple times actually. And I'm also a life member of National Cryptology Research Society of India. So I enrolled myself in 2005 itself, and my membership number is L180. So that's what I can also say that I'm one of the senior life member for this. And I'm expecting, and I wish JNNCE to host IndoCrypt very soon. I think JNNCE has all the infrastructure, and Shimoga city is also considered as a smart city. We have all the infrastructure available. Hope one day we will be able to host IndoCrypt in JNNCE. Thank you.
Thank you very much, sir, for your feedback. Next, I would like to call Ms. Divya from AIT Chikmagalur College to give her feedback.
Good evening, everyone. Am I audible, ma'am?
Yeah, ma'am, you are audible.
Okay. Good evening, everyone. I'm Divya from AIT Chikmagalur. Talking about the workshop, it went on very well. So we had the pleasure of hearing from the eminent speakers, that too from IITs and all. So it has been possible because of the online mode. So because of the online mode, we were able to hear from them. Otherwise, physically, it might not have been possible for all the IIT speakers to be there physically present. So because of this online, so it has been possible. So I congratulate Satyanarayan sir for successfully organizing such a workshop. It has right from the basics of cryptography to the current trends, the challenges and all. So it gave insight into the topics where the researchers can be done. So very well organized. I thank Satyan sir for giving us an opportunity to be a participant in such a workshop. Thank you, one and all.
Thank you very much, ma'am. So now I would like to call our students to give feedback on the workshop. So first I would like to call Shashank GS to give his feedback.
Good evening, one and all. My name is Shashank GS. And yeah, this session has been an eye-opener for all of us. And when I say this, I hope I'm saying on behalf of everyone. And yes, it has been an eye-opener. And I would like to extend our gratitude to our Satya sir and JNNCE management for organizing such a wonderful event. And we all know, for those who are following LinkedIn and all, some of the famous quotes nowadays is data is the new oil, means data has become so important in our daily lives. And it has so much significance, like once America was signifying its oil. That's why cryptography has become very important subject, and various hacking techniques have been developed over the 2 decades or so. And at the same time, we find many applications of ethical hacking. And these phishing attacks and all, we knew those words, but what were those, how they were working, we did not know. And via these workshops, we knew how people do phishing attacks and other stuffs as well. Mainly, personally, I like the session on elliptic cryptography, which was delivered by Balasubramanian sir. And another one which I really liked is automotive cybersecurity, which was by Ronald sir. And yes, as sir said, in upcoming future, the cars or these more equipments will be more dependent on software than on hardware. And yes, it is true. As you know, we have using IoT, this sort of this, and that has more significance. And how these equipments as well as can be easily hacked as well. And there stands the significance of cryptologists and cryptographers. So I hope this session, it has inspired me, but it has inspired many of my friends here as well. So thank you, sir. Thank you, JNNCE management, and thank you one and all for organizing such events. Thank you.
Thank you, Shashank. Now I would like to call Priya KV to give her feedback.
Good evening, everybody. I'm Priya KV from 7th semester Electronics and Communication Department. This was a really nice workshop, which was conducted for 3 days on cryptology. I would like to thank our HOD SVS sir and all our staff members for conducting this beautiful workshop, which was an eye-opener for us, and it gave us a lot of information. And it was my immense pleasure to meet prominent speakers online, which would not be possible if it was offline. And yes, thank you management for giving this opportunity, and I would love to look forward for more workshop like this in the near future. Thank you.
Thank you, Priya. So now I would like to call Yashaswini to give his feedback on the workshop.
Good evening to one and all present here. Professor Satyanarayan sir and Principal Dr. K. Nagendra Prasad, and all our professors seated here as well. Before I start off, a couple of things to get out of the way. The best way to teach someone is to ask an especially absurd question and accidentally teach them stuff about the universe and how stuff works. That is probably the best way to teach someone anything. And I believe to a certain extent, this workshop made that possible by asking some pretty absurd questions in the initial day and then moving on to other absurd questions on the second day, and we had some pretty absurd questions today as well with regards to secure access delegation, elliptic curve cryptography, automotive cybersecurity on the second day, and the questions that Dr. Roy had asked us, the open-ended questions that Dr. Roy had asked us on the first day as well. They were all really absurd, but at the end of the day, there was a significant amount of learning that happened. Secondly, the purpose of feedback isn't to gloss over things, but rather to help an event organization or an event organizer to improve the event standing and to make the event more useful to students and the other stakeholders involved in the process. Now, over the past 3 days, we've had a number of well-recognized speakers who have come and given us their insight into cryptography and into cryptology. But one thing that was lacking, at least that I saw that was lacking, was the participation of the students from the student end. Very, very few people came on board and asked questions and actually tried to interact with the person who was talking. It was especially evident when Balsubramaniam sir was talking about elliptic cryptography. Now, obviously, I am not a student of cryptology, but most of the students present here are. It is not something that should be taken lightly. You are the people who are learning cryptology. Elliptic curve cryptography is a part of the syllabus. So is RSA algorithms. So is Diffie-Hellman and Merkle key distribution schemes. You should ask questions and make sure that the person who is talking and the people who are listening are actively involved in the process, right? So that is one thing that was missing. Secondly, there might have been better branding possible for the event. Instead of just calling it a national workshop on cryptology, calling it a lecture series would have been better in case, because this was in effect a lecture series. And that is the second thing that I have to note. Barring this, moving on to more significant things, I was really, really happy and the learnings that I gained, primarily from Dr. Roy's workshop on Dr. Roy's lecture on the problems faced by the Election Commission of India, as well as the Commission on Cybersecurity that he's a part of. Then what Dr. Sakshina sir spoke about with his role as a principal scientific advisor to the Prime Minister's office. These were eye-opening lectures, and we had a lot of learning from these particular lectures. There were a few lectures, on the other hand, that did gloss over a lot of things and didn't really give us in-depth analysis as to what was happening. And thirdly and finally, I would like to talk about some of the topics that were raised during the paper presentations. I believe it was Dr. Murthy HR or someone else, the person from CSIR who has done some significant research into RSA algorithms and so on. The fact that many of us as students do not know the backstory of RSA algorithms is something that is hindering our learning of these sort of events, of our active participation in such sort of events. It would be better if we were prepared better. And also it would be better if these lectures were toned down to the level of the students currently. Instead of just going ahead and saying, okay, fine, these are the students, we believe that they have learned this. It is a matter of information exchange here as well. To say, okay, the students have learned this much, they know what a modular cipher is, they know what this is. So maybe it will be good to give them a little bit of backstory to what is happening in an RSA algorithm or what is happening in a Diffie-Hellman key exchange scheme before going ahead and talking about it. Now, those are a few of my observations, but overall, I believe this workshop on cryptology has given all of us the information that we need in case we are truly interested in cryptology and cryptography to go ahead, either make projects in cryptography or do some research in cryptography the same way Hellman and Diffie were interested in solving the public key distribution scheme, or the same way that Rivesh, Shamir and Adelman were interested in solving the asymmetric key distribution and the creation of the public key. That's about it from me. Thank you.
Thank you, Yashas. So now, if anyone are interested to give the feedback on the workshop, you can. Okay. Now I request Dr. S.V. Satyanarayana to announce the prize for quiz on previous 2 days workshop.
Yeah, just to create interest among the students and to judge the knowledge of learning. So we had every day posted a quiz containing about 15 questions on the topics what we have covered. So very happy to place it on record that all the students participated. Maybe they might have browsed or they might have gone through once again the YouTube videos. Anyway, some sort of learning has happened, and I am very happy to announce 3 prizes which were decided by our coordinators. I would not say this as the first prize, second prize, or third prize. The 3 students who we have recognized they are the best among the quizzes what they have answered. The first student is Navin CJ. The prize was decided based on how accurate you are when you are posting the quiz. In the sense, whoever has posted first on the time axis. Second student, Nikita Yadav. Third student, Sumant Shanbog. So thank you so much. It was very nice that you have answered all the quizzes. Thank you.
Thank you, sir. So now I request our principal, Dr. K. Nagendra Prasad, to give presidential address for the gathering.
Dr. S.V. Satyanarayana, the professor, the person who is responsible for organizing this national workshop on cryptology, and the members of the Faculty of Electronics and Communication Engineering, distinguished speakers from across various premier institutions, and my dear student friends. This particular workshop on cryptology tells us that there is a need for all of you to think of higher studies, because this is a very specialty area, what I understand. And you have in electronics and communication engineering very wide width. You talk about electronics, you talk about communications, you talk about embedded systems. This is all basic information for all of you. But one of the problems that nation is facing now is the cybercrime. As I said, Bipin Rawat, the Chief of Defense Staff, was telling that during pandemic, the entire cybercrime went up by 500%. And a whole lot of machinery, particularly involved in the policing, was engaged in trying to find out who are the culprits. What I feel is most of the times, 80% of the consequences, they arise from 20% of causes. Entire development process that we are undergoing, when you positively use it, they all serve for human advancement. But there are some criminals who are lurching in the darkness. They would like to exploit the whole technology by whatever the technologies that we have in the form of internet and other types of the drones and other things, they are encroaching onto privacy of others. And as I said in the opening remarks, whether you like it or not, we have all become public. All our information is public. That's why I always say that the students must be very, very careful, because this is the age where you are more emotional than applying any considered thinking, because age is like that. You should never get distracted by any of such temptations and try to share your information without proper scrutiny, because the whole thing will be endangered. Personal dignity, we are seeing day in and day out. For privacy, many, many concerns are there. I call upon all students to be very vigilant. I'm sure that last 3 days, coding and decoding of entire seminars, you'd have got tired. This is what cryptology says. I don't like to take much time, but I would like to tell you that when you are having opportunity to meet distinguished speakers, we have to make some observations. The first observation is that how a concept is presented. Because you know that listening is one of the important communication skills. You have got an opportunity to listen to distinguished speakers. So you should understand a complex subject like cryptology, how lucidly it is presented, how to develop a particular topic in the form of a lecture. What I say, they're all in between the lines. We have to see not only the concept, but how it is presented by going in between the lines. And the listening is very, very important for you, because I always say that communication has got 4 pillars. If you want to be an effective communicator, you should be a good reader. The first thing is you should read and get as much information as possible. Once you read, lot of database, lot of information is there at the back of your mind. Then when an opportunity comes, it is easy for you to speak. Reading is very, very important pillar, important aspect of communication skills. The second important aspect is listening. Because whenever you read, whenever you hear news, either through CNN channel or any channel, how a word is pronounced, how an idea is expressed, these things are very, very important. You need to pick up, because once you emulate some of these examples which you are observing, that goes a long way in your career, because one of the things that is pervading entire world now is communication. Whatever may be the engineer you are, your communication skills will take you far and above. So communication is very, very important. One day, if you have time, I would like to say, to spend a few minutes. One day, one speaker, one alumni, a distinguished alumni from our university has come from America. And as usual, whenever such guests come, I would expose the visitor to the audience, to the students. And at the end of the conversation or presentation, I asked students to ask questions to the distinguished guest who happened to be our alumni. And one person at the back benches, he stood up and started using American accent. He used American accent and asked a number of questions. And then the distinguished speaker was answering all questions related to subject, and also how one can view the career in America. Many questions he asked. Then I wanted him to go to my room after the lecture was over. Then I bid farewell to the speaker and I was retiring to my room, and I found the student waiting in front of my room. Then he asked me, "Sir, you wanted to go to your room. I am waiting for you." Then I said, "A distinguished speaker is using Indian accent. You being an Indian, why you are using American accent?" Because sometimes it will be mistaken why you are using American accent. Then he said, sir, from childhood, my father is a doctor. From childhood, I used to listen to CNN channel, and I used to reproduce entire news bulletin in front of my father, because I knew that when I become sufficiently grown, and I need to have communication skills. Therefore, I used to repeat the entire bulletin by standing in front of my father. I picked up only American accent. I can't help it, sir. That is one of the reasons I came to know that listening has got very powerful impact. And if you properly use it, so we all listen to news, we all listen to many people, and we pass time, but we don't stay and live the moment and try to understand what is actually happening, how the idea is expressed. My student friends, whenever, because our feedback also, many of you said, we are looking forward to have such interactions and workshops. So whatever that you have missed now, you can always relive, or again, don't miss when you actually get opportunity to listen to such great speakers. Not easy to get all of them on board on a very appointed time. And I thank all the speakers for having spared their time and come here and interact with my students. And Professor Satyanarayana has got very good knack of attracting students. So he announced the prizes, but he did not open what is there inside. So I was not knowing that, but packet is looking very cute. And I really do not know what is there inside. Normally, I would like any gift to be given by opening it, because audience would know, and the person who is presenting it also knows. Because if it is not good, then the blame goes on to the person who presented it. The principal of the institute has given me this very, so I want next time, sir, please open it and give it. But anyway, I like the way you wanted to attract people. I'm very, very happy. The third pillar of the communication skill is writing. You should be a good writer. Whatever that you listen, whatever you read, whatever that you gathered, you should write. And writing is very important communication skill, because when you write CV, the person who is there is not seeing you. He only sees what you have written. So this entire material should reflect your personality. Therefore, writing your project, writing a document, writing a technical paper, these things are very, very important. Writing is very, very important. So it is a continuous endeavor. We have to sharpen our saw every time and try to excel in our communication. Somebody asked me what is a skill. I say that skill is always associated with question, why, how well you speak. Everybody speaks, but how well you speak is very, very important. So the question how is always associated with any skill that you taught. The fourth is speaking. So you must be a good reader, you must be a good listener, you must be a good writer, and then you should start speaking. This is actually the completeness of communication. So in that respect, this seminar has covered very, very important aspect of listening. So my student friends, I'm very happy the Department of Electronics and Communication Engineering has organized very good workshop in appreciation of you who are here until last minute. Though it is a weekend, I appreciate your patience, and particularly R.V. Satyanarayana and all the members who have actually made valuable contributions. Let us all put our hands together. Thank you so much. Thank you so much.
Thank you, sir, for your motivational words. So now we came to the end of the workshop. So I request Dr. S.V. Satyanarayana to present a vote of thanks for the guest.
Good evening, everybody. Dignitaries on the dais, our principal, Dr. K. Nagendra Prasad, our chief guest of today's function, who has joined online, Dr. R. Balasubramanian, Dr. Indivar Gupta, Dr. Gururaj KL, and other delegates joined online, and my dear friends, my dear colleagues. Gratitude makes the sense of your past brings peace for today and create a vision for tomorrow. With this quote, it's my duty to thank one and all who made this event a memorable one. First of all, I thank Cryptology Research Society of India, Kolkata, for associating with us to organize NWC 2021 jointly with IEEE Students Chapter JNNCE and IET Shumoga Center. I wholeheartedly thank Dr. Bimal Rai, Chairperson of National Statistical Commission and General Secretary of CRSI, who has virtually inaugurated the conference and delivered the keynote speech. I thank all the authors who submitted their research outcome as a paper and presented, because of whom this program became very meaningful. Thanks to all the reviewers for their scrupulous and diligent work. I thank all the invited speakers for their excellent presentation and for giving their valuable time and made this workshop a memorable one. And it is a very useful academic activity. I just place it on record that this time we had 12 invited talks, out of which 7 speakers were newly joined to our list, because this is the 3rd time we are organizing this event. Just to answer a question of Yashas, this is the name given by the society. It is a pioneer event, annual event, as a National Workshop on Cryptology is the name coined by CRSI, so which we cannot change as a lecture series. I thank all the session chairs for making the critical evaluation of the paper presentation sessions by giving their comments and suggestions, which would definitely help the researchers to continue their research. We thank CRSI family and Dr. Alvin Pais from NITK Surathkal for connecting us with renowned innovative speakers. I personally thank Dr. Indivar Gupta, who helped us in getting funds from DRDO New Delhi. I thank Mr. Ajit Kumar, who is here, who is our alumni, for helping me in getting permission to host NWC 2021 by presenting our application bid during IndoCrypt 2019. I thank CRSI and DRDO New Delhi for extending financial support for this NWC. I thank our technical co-sponsor IET Shumoga Center, as well as our co-organizer JNNCE IEEE Student Branch. We are grateful to the college management, National Education Society, Principal JNNCE, Dean Academics, Dr. P. Manjunatha, Dean Infrastructure, Dr. M. Rajat Hegde, for all the help and support extended by them to this program. The support, help, cooperation, and assistance provided by the members of various organizing committees, HODs, faculty, and non-teaching staff of various departments of JNNCE is gratefully acknowledged. I thank all our final year students who are the captive audience of the workshop. I thank the technical team of the workshop led by Dr. Pramod Kumar S, who is one of the coordinator of NWC, and Satish Kumar HG for successfully executing this first ever online NWC without any technical glitches. Give a big hand to them. Just I wanted to quote here that not a single time we lost the network. It was very clear, audio, video, etc. All credit goes to my team. I thank our 2021 batch alumni Mohan Kumar for designing brochures and invitation. Many thanks to Mr. Mohan HG, Assistant Professor CSE, for designing NWC website and continuously posting the related updates. I thank all the committee members of NWC 2021 who worked very hard to make this event a memorable one. I thank Nripatunga, PRO NES, and Sharath SM for arranging press and media. I also thank Nripatunga for arranging YouTube Live. All the sessions are live streamed on YouTube so that we can refer in future also. I thank all my faculty colleagues who are the session coordinators for coordinating all the technical session as per the schedule. I thank all office staff, non-teaching staff members of JNNCE, especially NC, who joined hands with us in organizing such an event. I thank hostel staff for preparing nice food and transportation staff for providing transportation facility to our students. I thank press and media who gave a wide coverage of inaugural program. Last but not the least, I thank the co-conveners, Dr. Pramod Kumar S, Associate Professor Sheila S, Mr. Darshan KV, Mr. Harish TS, assistant professors of ENC department, who have managed the whole proceedings of the workshop completely with great passion and confidence. A big round of applause to them. I also thank all the concerned who joined hands with me to organize such a memorable event. I always say NWC is my baby. I want to host it periodically. My next aim is to host this event, same event, in 2025. 4 years once I host. Hope CRSI definitely give an opportunity to me. So this is the vote of thanks for the whole event. Now just as a formality for this valedictory program, I once again thank Dr. R. Balasubramaniam for accepting our request as a chief guest, Dr. Indivar Gupta, Dr. Gururaj KL, and all the members who has joined online. Our beloved principal, Dr. K. Nagendra Prasad, even in a Saturday afternoon, I disturbed him. I thank all my faculty colleagues, my dear students who stayed back patiently. Thank once again. Let us join hands to the success of NWC 2021 once again. Thank you one and all. Yeah, we are signing off this edition of NWC 2021. Thank you so much.